Hello everyone and welcome to you in my Python the Ultimate All-in-One course. Together we are going to have an amazing journey exploring one of the most famous and most job-demanding programming language, which is Python. With this Ultimate course, you will learn everything that Python can do with detailed step-by-step tutorials suitable for any total programming beginner all the way to senior programmers. With tens of amazing hands-on real-life projects, this material will never go boring or dry. And when I tell you that you will learn everything in one course, I really mean everything. From the basics of Python language, scripting, to image and video processing, data analysis, machine learning, web design, automation, games, and even GUI interfaces. Meaning that you will learn all of those big words that you hear around the industry. This course is so dense that usually it is divided to multiple courses, but not in our course. You will master everything here with me. You will not need anything else to become ready for the hot job market. Let me now give you a very small summary on what projects we are going to implement together. We will learn how to handle all sorts of files like Excel files, PDFs, and text files. We will also learn how to process those files to extract important information. Not only that, we will learn how to convert scanned documents, for example, into text, build web-based machine learning applications that can be accessed anywhere in the world. We will also build email and SMS spam detectors, and we will build a very cool program that is going to distinguish between images which contains objects in them. Also, if you have a boring job, we are going to learn how we can automate it using Python famous libraries like Selenium, so that you will never have to do your boring job again, and Python scripts is going to take care of all of that for you. One of the most famous aspects of this course is actually that we are going to break data science into a very simple, easy to digest information. It's like explaining to a 5-year-old how a certain algorithm works. This oversimplification is going to help you overcome the barrier between you and data science. In this course, we have a huge focus on machine learning, deep learning, and data analysis. We will be analyzing tons of datasets obtained from around the internet, and we are going to draw cool insights about those data that we have collected and even predict future insights without actually having to have a travel machine in order to predict those events. It's just with the pure data science. There isn't any level of programming required to start this course. There is no specific academic background, because I'm going to be taking you step by step from ground to become a professional Python programmer. So what are you waiting for? Let's get this long journey together started. In the next couple sections, we will be preparing and installing our tools and environment to start programming with Python. Then we will be talking about the most basic Python functions like variables, user input, and of course random number generators. This simple section will help you break the first barrier between you and programming. At the end, we will be building a very simple command line game to warm up and apply what we have learned. I'm really excited to start this journey with you guys, so let's get started. Hello guys, and welcome to you in this course. In this lecture, we are going to see how we can download and set up all of our tools. Basically, we will be using Anaconda, which is a distribution for Python and the R programming language. We will basically use it for Python. This distribution is supported by Windows, Linux, or even Mac OS. So let's get started, see how we can install it, and see how we can open the IDE that we will use initially to program Python. The first thing you need to do is just type on Google Anaconda Python, and you should get this website which is called Anaconda Distribution. Click on it, And then here you should see all the supported operating systems. For me, it's saying that here for Windows, so I can click on download directly, and it will download the version that is suitable for my Windows. Initially, it is 64 bits. I'm using Python 3.9, the newest version. At the moment I am recording this lecture, if you click on any of those, be it macOS or Linux, you should be able to get it for those operating systems as well. So for me here, I'm going to be clicking on download, and it will start downloading. Now this version is actually suitable for both 32 and 64 bits Windows. Now I can open my installer, and you just need to follow the instructions. You don't really need to do anything special. So say I agree, all users, just choose your setup directory and finalize this setup. And this will be the first step, which is installing the Anaconda Python distribution. Now that we have installed Anaconda, we are ready to open our IDE. An IDE is the editor that you are going to use in order to run your code. Any programming language, be it C, C++, Python, each has its own set of IDEs, or editor. So let's see what we are going to use for this course. We will be using two editors. One of them is called Spider and the other one is called Jupyter Notebook. At the initial stage, we will be using only Spider, then we will be switching between Jupyter Notebook and Spider along the way, because each one is suitable for certain applications. Now let's see how we can open our Spider IDE. You need to press the Windows Start button and type Anaconda prompt. Now Anaconda prompt is a command line very similar to the command line that comes along with Windows. But this one actually comes along with Anaconda distribution. So let's open it. Now the command line will open. All you need to type is Spider, like that. And to run this command by pressing enter. Now the IDE is initializing. Alright, so this is our IDE, the Spider IDE. Now we will write our code here, and after we are done, we will be pressing this Run File button and the code will be executing. You can save all of your files by just clicking on File and then Save As, and then you can simply just choose a directory to store your Python program. And that's it. Now we are ready to start coding some Python. So let's get started. So let's dig into our first tutorial. The first one, we're going to talk about variables. If you ever took any math class, you would know about variables. We used to say in school something like x plus y could equal to z, right? Or we could say a plus b plus c is equal, let's say, to z, okay? There is multiple types of equations. And we could fill these letters with numbers. So we would say 1 plus 2 plus 3 is equal to z. So 1 being a, 2 being b, and 3 being c. And the result here, if we just sum them up, will be 6, right? This is what variables is about. We can write equations or store numbers in variables. Now, those are all variables. If you take a look at here, all of those are variables. Actually, if we are in Python, variables would be written the opposite way. So we would be saying z is equal to x plus y. Or we could say z is equal to a plus b plus c. And those could have values in them, okay? Now, in programming, you cannot just say z equals a plus b plus c without first defining what is the value of a and b and c. So it's going to be something like that. A is equal to 2, b is equal to 3, c is equal to 6. then we would say a plus b plus c is equaling to z, like that. Okay, so this is the way we can write variables. Now there are multiple types of variables that we can use. For example, we have integers. So we have the integers, and they are like 1, 2, 3, 4, -1, 100, etc. Then we have something like floats. Okay, or we call them sometimes doubles, and they are decimal numbers like 1.1, 2.5, 0.3, -0.7, etc. All the decimals are floats. Then we have strings. And strings are letters like S, Z. We need to put them in double quotation marks, E, and so on and so forth. Okay, so those are our main variable types. Let's go and dig into some code. So right now we have opened our IDE and we are ready to type our first code. Let us define a few variables like A is equal to 5, B is equal to 3, and C is equal to 2. Then we could say Z is equal to A plus B plus C. Okay, now we can go and hit on run file. And here in this screen, we will see the output, but currently we are not printing out anything. Yes, inside the memory, we have all of these variables stored and calculated, but if we want to see everything here, in the terminal, we would say print, open a parenthesis, and simply just print whatever you want to print. In our case, it's Z. Run, and we can see here that it's 10. That is correct. Now, let's say I want to print other variables. Like I want to print A, I want to print B, and I want to print C. If I do that, I will see that 10, 5, 3, 2. This is exactly what I want. Now, let's say I want to print this whole formula like that. Okay? So I want to say Z is equal to 10, A is equal to 3 to 5, B is equal to 3, but I want to print it like here. I mean, right now, if I read this, I really don't know to which variable each number here is corresponding. So to do that, we can just do the following. Inside the print, if you open a quotation mark, you will be writing your own message. And if you put a comma, you would be putting your variable. You will be printing out your variable. So here you'll write your message, then the variable will be displayed next to it regardless of its value. So in my case, my Z is equal to, okay, now if I copy this whole thing and do it for every one of them, here, here, and here, and I only change Z to A, B, and C. If we hit on run, we would see my Z is 10, my A is 5, my B is 3, and my C is 2. Okay, now let us continue. How about we clear this out and see the types of variables we can have. So as I said, we can have an integer. A is an integer equaling to 1. B is a float equaling to 2.5. And C is a string equaling, let's say, to my string. Okay? Now let's say, for example, Z is equal to A plus B, and let's print Z. What value would I get? As you can see, it has added the integer value with the float value directly. Well, that's good. That's really good. Now we can also print the string, print C, and as we can see here, it is printing my string. So variables hold values. Okay, all of those are values and all of those are variables. So right now, let us talk about user input. Why would we need to use user input? So let's say you want to give the variables yourself by typing them instead of coding them. So far we were writing codes like A equals 3, B equals 7. What if I want to run the program, Then I want to give the value of A and B. Well, in order to do that, we need to use an input. The input function is going to take the user input and then it's going to store it in a variable. Something like that. Let's say you want to put the value of z. You would say z is equal to input, and then you would write your message like enter value, and that's it. Now, once you execute this, you'll get this message displayed, enter value, and then you will have the chance to input any number or letter you want, and whatever you input is going to be stored here. So if you say here, let's say you've written 5, what's going to happen is z is going to equal to 5. Let us execute this. Now, let us code what we have written previously. So let's say we have a variable called z, and this z is going to equal to input. And we open a parenthesis. And we're going to say enter your name. And let's give a meaningful name here. So I'm going to say this is called name. And let's say next we're going to have the age. So this is my age. Enter your age. Okay, then I'm going to be printing the following. We're going to say my age is, remember, we put the message here, then we put a comma, and we put the variable, which is name. Now, whatever we have written here as a user input, it's going to be replaced here and displayed. Same thing here. This is name. And this is age. Okay, so now if we run this, as you can see here, it says enter your name exactly as you have given it. So I'm going to say my name is Mr. Hamsho. And what's your age? Let's say it's 29. And as you can see here, it said my name is Mr. Hamsho, my age is 29. And that's exactly what we are looking for. Right now, I want to talk quickly about operators or math operators. We have been using the plus sign so far, but in Python you can use every operation you have on mind. So you can use minus, multiplication, division. You can use even module. I mean, we can use any operation we would like. Now, let's go and program these. First, I'm going to create 3 variables. One of them is called A, and it's going to equal to 100. Then we have B, which will equal to 20. Okay, now I'm going to perform multiple operations on these and print the result. So I'm going to say Z is equal to A plus B. Then I'm going to be printing Z. So print Z value is, and I'm going to just say Z. Okay. Now I'm going to repeat this. I'm going to say this time Z equals A minus B. Now, as you can see, Z A equals B will be replaced by Z equals A minus B because we are overwriting the Z right here. So, because here it had a value, then we are assigning a new value to it. So, this value will be deleted forever. Okay, now we'll do the same for division and for multiplication. So this is my division and this is my multiplication. Now, if we run this, as you can see, we got Z value is 120, which is for addition, correct. For subtraction, we got 80, correct. For division, we got 5, and as you can see, it's 5.0 because it was converted to float. So division by default will try to convert everything to float. Now all of these values are integers right here, but by division it's a float, and it makes sense because usually by division we get some decimal values. And finally multiplication, we got 2000. Okay, great. Right now I'm going to be talking about random. So random is a function that can help us generate random numbers, and it's really cool if you want to create some small project. So, because in the next tutorial, we'll be creating a small project. So, what is random? So you give it a range, let's say between 0 and 100, and then you run it, and it's going to give you a value between 0 and 100 randomly, like let's say it could be giving us 11, 15, 99, and etc. Okay, so in order to do that, we need to import a module. Python has a lot of modules, meaning you can download and install a lot of libraries for Python. This is why it's so powerful. And the module we will be importing is called random. Okay, and the way to do it, first we would say the keyword import, and then we say the module name. Okay, now let us execute this. Now let us code that random we have talked about. We're going to say import random. This is the name of the library that we are importing. Now, in order to generate a number, we are going to say the following. Let's say x is the variable I want to store the random number in. And we're going to say random dot rand integer. And then we will put the range. Let's say it's from between 0 to 99. Now, if we say print random number is, and we just put x, click on run, we will see that we got 14. If we run it again, we are getting a different number now. It is 86, again 76, again 51, again 73. See, this is what a random number generator does, and it's really cool and has tons of applications. So now we will be creating our first project. This is my project 1. You have made it so far, and we still have a lot to cover. But let's do some exercise and we apply everything we have learned so far. Let's say that we want to create a small game that is going to generate numbers for every name. So let's say you're playing with your friend and you put your name and you'll let the program generate a random number between 0 and 10. And whoever gets the highest number wins. Right now, we will not be using any conditional statements. We will just be printing the results and check ourselves to see who got the highest result. So we are going to have a section for user input. Then we will be getting the name for this user input. After that, we will run the random number generator. Okay, and then we are going to give the second name. And we will be copying and pasting this for how many players as we have. Now this is very simple, and when you progress in Python, you're going to do it totally in a different way, but I just want to get your hands dirty. Think about it, pause the video, and try to solve it yourself. Okay, so let us write our project. There is no shame in leaving some codes from the previous tutorial. That's totally okay. Okay, now, first thing we said that we want to input the name. So we're going to say name1 is the variable, and we're going to say input enter first name, and then we are going to randomize this. So name1 random number, and it's going to be between 0 and 10. Alright, so we are not going to print anything yet. We will print the result at the end. Okay, now next, let's copy and paste name2, enter. Second name, let's say that the game consists of 3 players. Alright, so let's continue. Name3, between 0 and here we're going to say third Alright, so far so good. Now we are going to say print. Now we are going to say name1, and we'll write the string got a value of, and then we'll put another variable, which is name1 random number. See what we have done here? We can put a variable, comma, write any string we want, comma, and then put another variable, and it will print it all as one line. That's cool. Now, let's continue. This is name1, of course. This is name2, 2, and name3, 3. Okay, let's play this game. Enter the first name. Let's say the first name is Jack. Enter the second name. Second name is me, Mr. Hamshaw. And finally, what is the third name? Tony. Jack got a value of 6, Mr. Hamshaw got a value of 1, and Tony got a value of 3. Okay, I lost. That's totally okay. So the winner here is Jack. We can play this again if we run it one more time. Enter first name. Let's say you. Let's say the name is you. Second one is me. Third one is they. You got 7, me got 4, and they got 5. So you are the winner and you got 7. So this is how we build a very simple interactive command line based games. Now that we broke the barrier between us and programming, let us learn some cool Python programming statements which will help us make more complex programs. We will learn about what we call conditional statements, and by that we can add decision-making capabilities to any of our programs. So let's get started. So right now we are going to talk about if statements. So what is an if statement? Well, let us say that you are driving your beautiful car. That's not really the best car out there, but let's say you are driving it. And in this car, you have the front lights and the tail lights. The car has a software, actually, and it runs all the time, and it will take care of all the electrical and electronics aspects, and even the mechanical ones that are running in the car. At least all modern cars are like that. Let's say that you want to turn on the front light or the headlights. Now, in order to turn it on, you need to rotate this light switch that is over there. So what we do is we do rotation for the switch, and then light is on, right? So this is what an if statement is. An if statement is a line of code that says if switch is on, then turn on light. It is as simple as that. This is how we use if statements. Now, let us take another case for the tail lights. We would say, how would we turn on the tail lights? Well, this happens if we hit on brake. So there is a condition in the software of the car that says if brake pressed, what will we do? Turn on tail light. Okay, it's the same as saying this. Let's go and code this. We have the rotation switch, and it's going to equal to true. Remember, you can say true, or you can say 1. It's the same thing. So let's say that my rotation switch is turned on. Alright? This rotation switch will turn on my front lights. Next, let's say that my brake pedal is equal to false. You can write 0 or you can write false. It's all the same thing. Now, let us create two variables, one for the headlight and one for the tail light. So this is my headlight. Initially, it should be false. And this is my tail light. And this initially also should be false. Let me redecorate this quickly. Okay, now I would say if rotation switch is equal true, and then put a column like that. This is how we write the if statement. In order to compare a condition if it has a certain value or not, we don't write only one equal sign, but we write double equal sign. Okay? So we are saying if this variable has a value of true, okay, depending on what is the value we have assigned here, I want to do something. Now, you might fall into the mistake that you would write your next statement exactly right here. Let's say headlight equals true, or set headlight to true. You'll see that we have an error here saying it is expecting an indented block. What does this mean? If you have an if statement, you need to put the statements after it by adding an indent block. How to do that? You just go to the far left of the next statement and press tab. So right now, you would know that this statement is related to this if statement. Okay? So what we are saying here, if the rotation switch is activated, then set my headlight to true. We are changing the value of this headlight from false to true. Okay? Now, also, I want to do the same thing for the braking pedal. I would say if brake pedal equals true, add a column like that, then make sure you go there, press tab. Okay? And we would say tail light is equal to true. Okay? Now we can simply print the final results. I want to print what is the status of my headlight and tail light. So I would say here headlight is headlight. Copy this, paste it down here, and say tail light is tail light. Okay? Now if we run this, you will see that headlight is true, correct, and tail light is false. So we have, because the rotation switch is pressed, the headlight was activated, and this is what we are getting. But right here, we are not pressing the brake pedal. We have set it to false. It's not pressed. So it's a checking. Is the brake pedal pressed? Well, is it true? No, it's actually false. So this condition is not satisfied. It means that if the condition is not satisfied, we will never execute this line right here, meaning tail light will never be true unless this is satisfied. Okay, that's it for this small section. Okay, so what do we need to do now is to program that very simplified game. We're going to define a variable called skill points, and let's say that initially this skill point is equal to 15. Now we're going to use the if else. If skill points is less than 15, we are going to print you will say welcome to city 1. your vanilla level should now if it's less than 15 we would say welcome to city 1. This is the easy part. Okay, now I'm gonna say else. Also we need a double column like that. Also we need a column like that. We would say print welcome to city 2. This is going to be tough. Okay, so now if we run this, as we can see, we said welcome to city 2. This is going to be tough. That's really what we are looking for. Now, let me show you what kind of bug we would have if we delete this else. Let's say you are walking, you are playing an interactive game, and you don't have an else condition. As you can see, you will be printing nothing. Okay. We still have few more things to talk about regarding the conditional statement. So we have talked about if, else, but we still have one more. So we have if, we have ELIF, and we have else. So let's say that we have multiple explicit conditions. We can put them in if, ELIF, and then we have a default case without condition. When none of these is satisfied, then we would be jumping to the default state, which is the else. So let's say that you have a remote controlled car. So this is the car, it's a toy car. You have bought from somewhere. And it has a wire. Remember those old wire cars where they have two buttons with a remote control? This is button 1. This is button 2. This is forward. And this is backward. Okay, so how would we program this car to go forward or backward? Using if-else. So we have two buttons, forward and backward. If we press forward, it will go forward. Now, if we press backward, meaning we will be utilizing this ELIF, if we press backward, we would go backward. Now, what do I mean by go forward or backward? We would turn on the motor in a forward motion, or we would turn on the motor in a backward motion. Okay, so the motor, if this is a motor, it could be rotating this way, or it could be rotating this way. If I press this, I want to rotate it forward like that. If I press the backward, I want to rotate it like that. Now, here comes the else. If I am not pressing anything, I don't want to rotate the motor at all, so I want to turn it off. Okay, this is one use case. Let us go and program this small car. We have two buttons, so I'm going to say here forward button is, let's say, equal to true, meaning it's pressed. And let's say that my backward button is not pressed, so it's false. Now, let me encode the rotation of my motor. So let me write a comment. A comment is nothing but something that only humans can read, and it won't be compiled, it won't be executed by your Python compiler or interpreter in our case. So I'm gonna say here
that 0 means no rotation for my motor. Another comment, 1 means clockwise rotation, and 2 means anti-clockwise rotation. Okay? And let me explicitly say that this means forward and this means backward. Alright? So right now, I'm gonna say motor status, like I wanna know what is it, equals initially to 0. Alright? So we have a turned off motor, the button is pressed, and the forward button is pressed, and the backward button is not pressed. So let us start writing our conditions. We're going to say if forward button is equal to true, then what do I want to do? I want to set my motor status to forward, right? So motor status is going to equal to 1. Now I would say ELIF, see, this is the second condition. If my backward button is equal to true, what do I want to do? I would like also to turn the motor status but to number 2, right? Because 2 means anti-clockwise, meaning go backward. Now my default state, let's say if not pressing forward, not pressing backward, then this will be an else motor status would equal to 0. Okay? Now let's print also the status of the motor. I would say here print car is moving forward. Here we would say car is moving backward. And finally we would say here car is not moving. Okay, so let us run this. As you can see, it's saying car is moving forward because we are pressing this button. Now let us press this button instead. This will be true. This will be false. We see that car is moving backward. That is correct. Now let's say that both of them are false, meaning we are not pressing any buttons. Car is not moving. Now let's go to a corner case where we have both of the buttons are pressed and we are getting car is moving forward. Why is that? Because the first condition is satisfied. Remember, Python executes everything line by line. So the first condition is forward button pressed? Yes. So it's pressed, so it won't be looking at any of those anymore, because only one of these will be executed, whoever has the condition satisfied first. So in our case, forward button is pressed, actually yes. So we will be moving forward. We did not really check the backward button because, well, this is the first one. This is the winner between the if statements. Alright, so now let us implement our new project related to the if statements. Project. Alright, so let's create a simple program that will determine the letter you will get depending on the grade you have. So let's say you are an instructor in a school or a teacher, and let's say there is the following letters. There is A, there is AA, there is BA, there is BB, there is CB, there is CC, there is DC, and we have a DD. Okay? Let's say that to get an AA, your grade needs to be higher than 90. To get a BA, your grade needs to be higher than 85. To get a BB, you need a grade higher than 80. A CB is 75, a CC is 70, a DC is 65, and then we have a DD, which is a 60, and we have a final grade, which is an F. An F is when it is less than 60. So our goal is we input a number, a grade, and it will output these letters. Okay, we input a number and we output this letter. Let's go and write this in code. Alright, let us program our grading. So first we need a variable called grade, and it's going to take the input from the user. We'll say input, enter the grade. Okay. Now let us utilize the if statements. We'll say first if grade is larger than 90, then I'm gonna print you got an AA. Congrats. Okay, now let us just continue. Next line, instead of if, we will be using ELIF. If it is higher than 85, then you would say here you got a BA. Now, you would think, okay, 85, higher than 85 could also mean 90. But remember, we are executing this in sequence. So if this one wins, we will never get to this anyway. Alright? This is why it's totally okay to do this. Now, if I change this to if as well, here is the problem that's gonna come out. Now, we will see two problems here actually, but bear with me. If I run this, and the grade, let's say it is 95, I'm gonna get an error. And it's saying this operation, this one, is not supported between instances of string and integer. What does this mean? What is the type of this? It's an integer, right? But what is the type of the input? So you are putting input, the program is taking your input and storing it in grade. But the input here is a string actually, and it is not a number. Input always gives back a string. So you're saying here, is some text larger than 90? Well, this makes no sense actually, because here it needs to be a number or an integer, a float, any number in order to be able to compare it. This is where casting comes in. Now, casting is just converting a value from one type to another. How to do that? Let's say this is a string and I want to convert it to integer. I would simply just do integer, open a parenthesis on the whole instruction and close it here. Now, this should resolve the issue. Let me just remove this for 1 second and run this. Enter your grade, it's 95. And as you can see, we have no errors anymore because we have casted it. This is casting, converting from one type to another. Now this returns a string, it was converted to integer, and integer is comparable with an integer. Now, let me go back to the other issue I was talking about. If I said here if instead of ELIF, if I run this and I say my grade is 95, I would get two messages. Why is that? Because when I use ELIF right here, if this one is successfully satisfied, then I will never execute whatever I have from ELIFs or else's. It will just be omitted. But if I use if and then another if, each condition will be evaluated individually. They are not related to each other at all, right? So you will evaluate this. If it's satisfied, it won't omit this. It won't ignore it. It will just continue and execute it as well. This is why if you want to use this format, you would need to say and grade is less than 90. Okay, now if you execute this and you put 95 here, you will only get 1 because now this condition is not satisfied because we are now specifying a range. You need grade to be 85 and at the same time you need grade to be less than 90. This is what AND does. It says this condition and at the same time this condition. Okay, now I'm not gonna get into this. We don't want to do that. We will just say ELIF. Okay, now if ELIF 85, you'll get a BA. Now if you execute this, you'll see that you'll get only one statement. Let's say 95, you got only one statement. All right. Now let us continue. ELIF, this is larger than 80, you will get a BB. ELIF, this is larger than 75, you will get a CB. Maybe in the next one, let this be 70. And now we have this. The 70 is CC. And then we have 65. Maybe I won't say congrats for a 65. But you still passed. So this is a DC. And finally we have a 60. And then we have a 60. This is a DD, almost passing. And we would say else. Okay, right now let's utilize the else. You got an F. Sorry, you failed the course. Okay, now let us run this. What's your grade? Let's say I got 71. We got a CC at 71. Now let us run it again. Let's say that we got 41. You got an F, you failed, and the program is ready.
Congratulations on making it here. You already know the basics of Python. These concepts that you have learned so far can be applied to any other programming language. Now we will learn about organizing our variables with what we call lists. It's like an array if you are coming from a different programming background. And if not, you can think about it like a shopping cart where you can add and remove groceries. So let's play around with some lists.
And now let us talk about our next topic, which is called lists. Lists are very important in Python. Now, let me give you an example. Let's say that we have a user interface for a program, for a website. Doesn't really matter. Let's say that we have 3 buttons. Button 1, this is, let's say, will navigate to the main menu. Let's say a second button will open a file. You know those file open, settings and stuff. And then let's say that we have the help. We have a help button. It will take us to support. It will take us to some documentations. Now, if we want to implement this according to what we have learned so far, we would have created something like that. Let's say button, main, variable. Okay, let's say it equals to a string like main. We would create another button for file. It will equal to file. And then we will create another one. Let's say it's called help. And it equals to help. Okay, now we have defined 3 variables so far. And this is really a problem. Let's say that we have in our GUI around 100 buttons. Do we really need to define every single one of them just like that? Especially that maybe all the buttons have the same properties, the same shape, the same everything. Do I need to define it like that every single time? The answer is no. we won't be doing this. We will be doing something like that. We will define a list. We will call it buttons. And we will put all of our buttons inside. So this is an empty list right here. If we want to fill it, we would do something like that. So this is main. This is file. And this is help. Make sense? So this is how we define a list. Now, how can we access the elements of this list? There is something called index, which is the number corresponding for every element inside the list. And these numbers start with 0. So this is 0. This has an index of 1. And this has an index of 2. Okay? So if I say something like a print buttons, and we open a bracket, we say 0. What do you think it's going to print? Well, it will print the element that has index 0, which is main. Same thing, if you put 1, if you put 2, you will be printing file and help. This is how you access it. But the thing to remember is the access is always starting with 0. So the first element is not indexed as 1, it is indexed as 0. Okay? Alright. So let us write some code. I'm going to define a list that contains, let's say, names. So I'm going to have a very simplified database that contains names. And I'm going to do it like that. So names is equal to, let's say that we have 5 people here. First one is called James, Ellie, Mr. Homshow, Adam, and Ida. Okay, so this is called the list, and you see that the definition of a list is done by opening a bracket and putting all of our elements. Now, how about we create another list for the ages of each of these? Okay, so I'm going to say ages is equal to 24, 25, 21, 48, and 17. Okay? So as you can see, list can take numbers, it can take strings. You can put any type, actually, whatever type in Python inside a list. Now, let's play around with accessing these. Now, if I say print names, let's see, what would I be printing? Let me clear this. Print. As you can see, I print the whole list with the brackets if I try to print this variable. Now, if I try to print ages, I will just get the same thing. Well, okay. Now, what if I wanna print the name and the age of the first element? How would I do it? Think about it. Talked about it a few minutes before. What I would do is print, then I would specify names and the index. Let's say I want to print the first element or the first person in my list. So this is James. So this is 0. And I want to print the age, even though the age is in a separate list. And this is not really preferable if you have a related list like that. There's another way to define them. But just for clarification purposes, this should be okay. Now I'm going to say ages 0. Okay, now if I click on run, and yeah, I'm going to remove these first, run again, you would see that James 24. Now let's say that I want to print the fourth person. Remember, this is the fourth person. What is the index of the fourth person? Well, we start from 0. So 0, 1, 2, 3. So the fourth person in our list has an index of 3. Okay, so if we put 3 here, what should we get? We should be getting Adam and 48. We got Adam and 48. See how indexing works? Now let's say that I put an index that does not exist. 6. You would get an error called list index out of range. It's important to remember this error because you might face it when you program in Python. When there is an error called list index out of range, simply this means that you're trying to access an element inside the list with an index that is out of the bound. The bound here is from 0 to 4, and we are trying to put 6. Same thing if we say 5, for example. If we try to run this, list out of range. Okay. Okay, now we are going to continue with lists. I'm going to continue with the methods we use in order to add elements to lists. So add elements. How can we add elements? Well, we can do that by saying append. And then we specify the element. What does this mean? Let's say that I have a list of names. So name 1, name 2, and name 3. Okay. Now let's say I want to add name 4. How would I do that? I want to do that in runtime, meaning I have a program running, and I want to add one more element. The way to do this is, let's say this is called L. I would say L dot append. Then I would say something like name 4. Now this name 4 will be appended to the end of my list. Okay? So I'm going to give you an example on what append means in some real application. Let's say that you have a shopping cart. Okay? And you want your user to be able to add to the shopping cart. So initially right now, we would have a shopping cart that is empty. All right? This is how we define an empty list. Okay? Now let's say that you wanna let the user put the name of the item and it will be added automatically to the list. Now let's say that we want to append 3 items. All right? How would we do that? We would say item 1 or just item equals to input. Please enter the name of the product. Okay, now let's say he entered here oranges. What happens is this oranges now is stored in item. Okay, now if we append item to this shopping cart, we would have oranges in our shopping cart. How would we do that? We would say shopping cart dot append. What do we want to append? Whatever the user gave to item. Now we have added whatever the user put here into item, and then this item went into the shopping cart using the append list method. Now let us repeat this multiple times. Let's say 3 times. 2, 3. All right. And finally, I just want to print whatever I have in my shopping cart. So print your items are shopping cart. Okay, so we will print the whole list. Now, if we hit on run, please enter the name of the first product. Let's say oranges. Now, let's continue. What's the next one? Let's say that we bought milk. And finally, let's say that we bought almonds. And as you can see now, it says your items are oranges, milk, and almonds. This is how you create a list in Python, and you append to it. Alright, so we are still talking about lists. But this time, we are going to talk about removing elements from lists. We have talked about adding elements. Now I want to talk about removing. So we have two methods. One of them is called remove. We have also pop. And we have a delete all, which is called clear. What is the difference? Well, remove is very simple. You have item 1, 2, and 3, and you just want to remove one of them by name. So you would say list dot remove, and then you would specify what do you want to remove. Let's say I want to remove number 2. Now this will be deleted. Okay, this is for remove. Now there is also pop. If you say just l.pop, pop is going to remove this item, the last item, from the list. Remember, append added an item to the end. Okay, but pop is going to remove an item from the end. All right. Now finally we have clear. If I hit l.clear, this will remove the whole content from my list. Alright, let's code this. So let's say we have this same shopping cart, and let's say that the user has added an item by mistake and he wants maybe to change it, he wants to remove it forever, but we need a mechanism in order to do that. So what would you do? Let's say that this is your shopping cart, you already inserted all the items. You would do something like that. You would say shopping cart dot remove. Let's say we don't want the almonds anymore, so almonds. Then let's print the shopping cart. Hit on run. You will see that we have removed the almonds. That's good. Now you need to be careful. If an element does not exist or there is a problem in the capitalization of the letters, you will have errors. So I changed the A from capital to small. Now if I run this, I will get an error because it says list x remove x is not in the list, meaning that the element here does not exist in my list. Okay, just be careful about that. I just want to remove the last item I have inserted. So maybe I wrote an item by mistake, I have a typo, for any reason. Let's say I just want to remove the last item. I would just say shopping cart pop. Now if I print this, you will see that it removed only the last item, which is almonds. That's good. Now we know how to remove the last element, and we know how to remove by name. Okay. So lastly, let's say that I want to clear all my shopping cart and I don't want it anymore. I want to start over. I would say shopping cart dot clear. Now if I run this, you'll see that my list is empty right now. All right. So we have covered this as well. Now there is a very important function that we can use, which is called len, which will return what is the length of my list. We are still at lists, okay? And this len, if you just type len like that, open a parenthesis and pass the name of your list, let's say L, it will return the number of elements inside it. Okay, why would this be useful? Well, let's say you have a list and you are appending to it, and you want to say when I have 10 items, please do something, right? So how would you measure what is the length of your list? This is the way, by using this len. It's also important if you want to check if your list is empty, right? Let's say for any reason you want to check the condition if I have a list and it's empty, meaning that len L is returning a 0 to me, then I want to do some action. Okay, the way to do that is with len as well. Let's go and see some examples. Alright, so we are back at our oranges, milk, and almonds. What I want to do is to check what is the length of my shopping cart. In order to do that, I would say simply length, create a variable, let's say, in order to store what is the length. And I'm going to say len shopping cart. Now, simply, if I print this, length, I would get 3 because I have 3 elements. Well, that's really good. Now, let me clear this. So I'm going to say shopping cart dot clear, meaning my shopping cart will be empty right now. And I want to make a condition that if my list is empty, to print me some message. So I would say if len of shopping cart is equal to 0, okay, then print your shopping cart is empty. So let us see what's going to happen now. Hit on run. You'll see that we printed the 3 first because we are here. Then we cleared it. And now we are checking if it's 0 or not. As you know, when we clear it, we don't have any elements anymore, meaning what is the length when we have no elements? Well, of course, it's 0. So I'm saying here, if the length of my shopping cart is 0, then I want you to print your shopping cart is empty. And this is what we have printed. And now we are going to continue talking about lists, but this time they are nested. What is a nested list? Well, remember when I told you that list can contain any type of variables? Well, somebody thought of putting lists inside lists inside lists. So we can put lists inside lists, and that's really useful in a lot of scenarios. So if I define a list like that, I could open a large main list, and the elements are going to be lists as well. So let's say first one is 1, 2, 3. Then second one is 4, 5, 6. Can you see that? Take a look here. This is my first list, and this is my first element in the list. Okay? And this here is an element inside the list. Okay? Indexing these is going to be interesting. Why? Because this element right here has an index of 0. And this element right here has an index of 1 relative to the large list, right? Is that correct? Because we have 2 elements in the main list. This is index 0 and this is index 1. Now what about this if I want to access the number right here? What should I do? Well, to access that, you would need to say, I want to go to L0. This will give me access to this list when I say L0. And then if I add another bracket like this, and I say element 0 again, it means that I am accessing this one right here. See what we have done? So we need 2 brackets, 2 brackets. These 2 brackets will get us access to the first list. Then these 2 brackets will give us access to the list inside the list. Now, let's say I want to access this 4 right here. What should I do? Well, I would say L. What is the index of this element relative to this list? Well, if this is 0, this is 1, right? So this is L1, correct? Now, what is the index of this element relative to its list? What is the index of 4 relative to its x? It's actually 0. It's the first element. Okay? Now, let us give more examples. Now, let's try this element. This element is inside this list. And this list has an index of 1, so L1. Then we go tinier. 5 is also inside this list. What is its index? The 5 relative to this list? It's 1. See what I mean? If you have questions, please write me in the comment section. Now we're going to apply this. I'm going to create a list and call it database. Okay? And it's going to be like that. A list which contains 2 lists. 1 here, comma, 2 here. I'm just making spaces for you to see better. Okay? The first list will contain the names, and the second list here will contain the ages of people. So this is John, and this is Mr. Hamsho. And here's the ages, let's say 25, 29. All right? So, I want you to remember what I've talked about a few minutes ago and tell me, how can we access Mr. Hamsho right here? Pause the video for a second and think about it. First, we need to specify my list, which is database. Open a bracket. Now, Mr. Hamsho, where does it exist? Is it in which list is it? Well, as we can see, it is in list number 1. This is list number 1, and this is list number 2. Remember, list number 1, we start the indexing from 0, so the index is 0. Next. Now we go tinier. Now, within this index 0, what is the index of Mr. Hamsho? This is the list for it. This is index 0, and this is index 1, right? So, 0, 1. Now, if I put all of this inside a print, and run, we would get Mr. Hamsho. Great. Now, how can we access this one? Same thing. We write the name of our list, then a bracket. This is list number 2, right? Meaning, what's the index of the second list? This is 0. This is all 0. This is 1. So we have 1 here. Now we go tinier. Inside this number 1, where is my 29? Is it 0? Is it this element or this element? Where is it 29? It is index number 1, right? This is index 0. This is index 1. And that's it. Now if we print this, we would get Mr. Hamsho, first one, and 29 right here. Okay. That's really good. Alright, so we have talked about lists. Now I want to talk about while loop. Why do I want to talk about while loop? Well, if I want to create continuous applications, I would need to put them in a loop that will continue looping forever. Okay? So, as you have seen so far, we were doing some code, we were writing code, we were executing in sequence, and then when we reach the end of the code, what happens? Stops. The whole program stops. Well, I want this to continue and jump back to the beginning every time. This is important if we are creating stuff like menus, like GUIs, user interactions. we need this kind of mechanism that will continue looping. Okay, there is tons of applications for this while loop. Now let's go and see how we can program that. Okay, so how can we program an infinite loop? We simply need to say while 1, and that's it. Now everything inside here will continue repeating forever. I'm gonna just make a user input. Let's say this is user input, and it will say enter a letter. Now this program will execute forever. It will keep asking us enter a letter, enter a letter. We will enter a letter, it will repeat. Let's say that we are printing the letter afterwards. So print user input. Okay, so we will be entering a letter and then printing it. This will continue forever. Now I'm going to create a condition to break out of the loop. It's important to always have an exit point from the infinite loop. Otherwise, your program will never stop until you force it from your command line. So we're going to say if user input is equal to, remember it needs to be a string, right? Because user input is storing a string. Exit. Then how do we break out of a loop? We just say break. See what's happening? We are taking the user input, printing it. Now we're checking what is the user input. If it equals to exit, I want to break out. Now let's try this. Enter a letter A, B, C. Enter whatever you want. It won't exit. It will continue forever. U, me. Now if we type exit, we are out of the program. As you can see, we broke out. This is the use of while one loop. Now while loop has different syntax for different cases, but for an infinite loop, all you need to do is only this. And don't forget you need an indentation block. As you can see, everything is within indentation with respect to while. Same here in the if, we have an indentation for the if, for the break inside the if. Okay, that's good. There is one more data type that I would like to talk about along with lists, which is called tuples. A tuple is defined like this. So T for tuple is equal to, we open parentheses like this, and we just pass elements to it. So A, B, and C. Now we can access the elements inside the tuple just like the list. We can say print, maybe T0, and we would get A, T1, we would get B and T2, and then we would get C. Now let's try something. If I say T0 and then I try to change the element to a different letter, let's say like Q, I would get an error because tuple object does not support item assignment. What does this mean? It means that once we create the tuple, we cannot change any of its elements. Now you might ask, where do we see tuples anyway if we cannot really change their elements? Well, in libraries like OpenCV, for example, we would see tuples when we are working with coordinates. Usually all coordinates are passed as tuples like that, with the x coordinate and the y coordinate. We see them also when we are passing colors in OpenCV. We would see that we pass colors like this. We pass the R value, the G value, and the B value. So tuples have some limited usage, at least in the world of Python. Now, it was designed for a larger purpose than this, but developers worldwide agreed that tuples is not used as much as lists because of their inability to change their elements, for example. I wanted to give you the syntax anyway because you are going to encounter it in a lot of libraries. Even though the focus is more on lists, tuples cannot actually be ignored entirely.
You made it here, meaning that you are halfway through Python basics. Now we will learn about loops. A loop statement will save you a lot of repetitions in your code. They are like a smart way to repeat multiple statements multiple times with a few lines of code. At the end of this section, we will learn the basics of how a picture can move on the screen. We will be utilizing some really cool techniques, and we will see how moving objects on the screen take place. So let's get started.
Right now, we are going to be talking about loops. What are the Python loops? Let's take a look. So, as the name says, a loop is doing something over and over and over again. Before, we have talked about the while one loop, which was an infinite loop, right? So we would have multiple line of codes and we would be repeating them forever. Now, it's a good idea to implement a very small application for loops, which is a counter. We want to be able to print 1, 2, 3, 4, 5, up until any number we say. Now, so far we have learned that we can do that by saying print 1, print 2, but this is not really practical. We want a way to do that. And the way to do that is by using something called the for loop. Let's see how we can program a for loop. Let's say that we want to print the numbers between 0 up to 100. Okay? How can we do that? We would say for, and we need to specify something called a counter. This counter value will change and sweep in between a certain range. So if we say for I, then we say in range, what is the range I want to sweep? Between 0 and 100. We put a column like that, and all we need to do is just print I. What's happening here? As I said, this is the counter. This counter value will change for every iteration. So in the first loop, the I will be 0. It will execute this, and then its value will increase and go back here. Now I equals 1. It will execute this, so it will be printing I, which is 1 now. Then it will loop again. Now it will be incremented by 1. Now I is equal to 2. Again, print what is I, it's 2, it will print 2. And so on and so forth until we reach 100. We will print 100 and we will exit. Now let us see what's going to happen. And as you can see, we have printed everything from 0 to 99, but we did not print 100. Because the print here is actually this value minus 1. So if you want to print all the way to 100, you need to specify this to be 101. Okay, now if we do this again, as you can see, we are printing from 0 to 100. Now, we don't usually use loops for such applications. What we really use loops for is to iterate, let's say, over a list. So let's define a list, and I'm going to call it L, and this L is going to have the following elements: apples, bananas, and strawberry. Okay, so we have strawberries, bananas, and apples. Now, how can we print all of these but one by one? You know, before we've said that if we want to print a list, we just say print L. Okay, now let me remove this. If I print, I'm getting the list itself with the brackets, but I'm not printing the individual elements. What if I want to extract every individual element? Well, we also have learned that we can access them by index. So if we say print L0, we would be getting apples. This is great. We are extracting them, but if we want to extract all of them and print them separately, we would need to do something like that. Print L1 and again print L2, right? This is a lot of code and this is not really practical. What we can do instead is say the following: for. Now, let's create a placeholder that will, while we are looping, it will keep the value of every element in every single loop. So for, let's say, element, and we say in L. So what do we mean by that? What we are saying is, for every element that is stored in L, what is L? This is L, this whole list. And now, since we will be looping for every element, how many elements do we have? We have 3. So we will be looping 3 times over this list. We will be, in the first loop, we will be taking apples, so element will equal apples. In the second loop, element will equal bananas. And in the third loop, element will equal strawberries. Okay? So now if I say print element itself, and I remove these, as you can see, I got the same output, but with shorter code. Now imagine I have hundreds of these. I can loop over all of them simply by doing that. Did you get how for loop works? Just an element that will extract every element inside the list. It will store it inside it for every loop, and we are just printing whatever it's storing in that specific loop. Okay? Now, let's do another practical application. Let's say that I have an array that has numbers which are 1, 3, 5, 7, and 9. And for some reason, I want to shift all of these numbers by 2. See what I mean here? Every number, I want to make it plus 2. So I want to change this to 3. This will be 5. Here it will be 7. Here it will be 9. And here it will be 11. Okay? So how can we do that? Well, we simply loop over it and we increase every element by 2. So we would say for element in A, so get every element in A, and we are going to say element is equal to element plus 2. Now if we try to print element, we would get 3, 5, 7, 9, 11. That's great. We have done that. But what we are doing here is not actually storing or replacing these values in A. So right now, if I print A, the value will not really change. Let's take a look. As you can see, the value of A is still as it is. Why? Because this is a separate variable actually, and we are just changing this variable and printing it. But we are not changing the elements inside A. So how can we really change the elements inside A? Well, we can do that by using the method we used before in the counter. So we would say something like for I in range. What is my range here? Well, it's from 0. But what is my max number? I mean, I want to change the value of each element of this list, but I really don't know what is the length of my list. So I would say len of A. Okay? Remember, we've talked about len. Len of A is going to be replaced by how many elements do I have here? In my case, I have 5. So it's the same as saying 0 to 5. Okay? But since my list length could change, I would make it dynamic by just saying until the len of A. Okay? What do I want to do? I want to change every element value in here. How would I do that? Well, AI is equal to AI plus 2. What do I mean by that? How can I translate this to English? Well, again, we are going to be looping through all of this list one by one. But we are looping through a counter, right? So what we are saying here, we are saying I is going to sweep a value between 0 and 5. Take a look. If I right here is 0 in the first loop, it will be A0 equals to A0 plus 2. What is A0? Well, it is 1. So I'm saying this element here, I want its value to change to A0, which is 1, plus 2. So let's replace A0 with the real value. It is 1 plus 2. So I'm saying, hey, my A0, I want it to equal to 1 plus 2, which is 3. Okay, now let's continue. The next loop. We're done with the 0. We will increment this by 1. So right now I is equal to 1. So it's A1 plus A1. What is A1? A1 is actually this element, right? And it equals to 3. So this will be like replace A1, which is this element, with this new value, which is 5. Okay? And we will go like that. So let's say that we reached 4. So A4 equals A4. Change the value of A4, this one, to A4 value, which is 9 plus 2, meaning 11. So now this will be 9 plus 2, it will be 11. Okay, so right now, if we just print the whole A array, we will have an updated list, as you can see here. So this is how we modify values of a list. If you have questions, please ask them in the Q&A. And if you like this series so far, please hit on like and subscribe for more easy to understand content. And right now we will be continuing with more for loop functions. So far we have learned how we can iterate over a list that contains multiple items. We have also learned how we can iterate over a certain range of numbers. But sometimes we would like to combine these two iteration techniques together. So let me give you an example. Let's say that I have a list of cars and I have the brands of multiple cars. Let's say BMW, Hyundai, Toyota, and let's say Jaguar, etc. What we have learned so far is that we can iterate over this list and print it out. So we will say for items in cars, we can say print items. And here we will be getting all the names one by one. Now, sometimes I would need to actually print the index of every element. Right now I am only printing what's inside the list, but what if I want to print the number of every element? So I would like to print BMW is 1, Hyundai is 2, Toyota is 3, and Jaguar is 4. We can certainly just say for items in, let's say, range between 0 and the len of cars. We can certainly say that, and then we would be printing items, and we will be getting 0, 1, 2, 3. And then if I want to print the car, maybe I would say print cars, and then pass the items as an index. So we would be getting 0 BMW, 1 Hyundai, and etc. But Python supports a different method, and you will see it in any professional Python code, which is, we will be saying here, for I and items in, and then we would say enumerate cars. Okay? Now all I need to do is just print items and print I. The syntax of me having the list and its index is not necessary anymore if I am using this method here. Okay, so here, if I just print the item and the I will be getting BMW 0, Hyundai 1, Toyota 2, Jaguar 3. See what's happening? Let us arrange them in a better way. So here I would say I and then the items. Now let me print this. You'll see 0 and the car brand, 1 car brand, etc. To use enumerate, you need a counter first, and then you need the variable that will be assigned to all of your list elements. Alright, so what I want to talk about right now is something called list comprehension. This is a very important topic in Python, and it saves you a lot of time when you are coding for loops. So let's say that I have a string s which contains the following, this. Okay? It's just a string that says this, okay? And I would like to extract this string and put every single letter in a list. All right. The conventional way to do that is by just saying for maybe L for letter in S, and then we would say something like, let's create an empty list here. Let's say this is li for list, and it is empty. So here I would say li dot append L, right? This is how we usually do it. And this will iterate over every letter we have, and then it will add it to this list. So I will end up with something like this. I have a list and it will be like T, then we have the H, then we have the I, then we have the S. Okay, we will end up with something like that. But take a look, we had to write a for loop and a statement to do that. With list comprehension, we can create a shortcut when we are trying to append to this list. The syntax would be something like that. Let's say that li right now will equal to, we will open a bracket, and we are going to say x, for example, and here we would say for x in S, and that's it. So what we are saying here is, take this x and start adding it as an element to this list. What is x exactly? Here we are specifying what is x. So initially we are saying add this x to the list or append this x, and then here we are specifying what is x exactly. And here it is for x in S, meaning that extract every element in S in every loop and put it in X. Okay, so it will automatically end with this list right here. Okay, it's a really simple syntax. But sometimes it's confusing because we have an X here and X here. What does this mean? So this is why I'm just making it easy for you. The first X is nothing but what you want to put in your list, and then you are specifying what is X exactly. Let's try to code this. So right here, we are going to create a string, which equals to this is nice, maybe, okay? And in order to implement the list comprehension, all we need to do is just say S is equal to, meaning update my S, to this new value, X for X in S. Now, if I try to print X, sorry, not XS, take a look here. We have all the letters unpacked into this list, even with the spaces. See, the spaces right here are just an empty string. That's good. Now, let's say that I need more conditions. Maybe I don't want to include the spaces. Well, you can simply just add a condition to this list comprehension as well. All you need to say is if x is not equal to an empty space, right? This is all you need to do now. Run it again, and you will see that we got rid of all the spaces. Let's say that maybe I have another condition. Maybe I don't want the letter I to be included. Okay, so all I need to say is and x is not equal to the letter I. Okay, we don't want any i's. And here we go. We removed the i's and the spaces, so you can add as many conditions as you need actually. That's really good. So let me sum it up one more time. I know I have repeated this multiple times. Just separate it like that for the syntax. Remove all the conditions for less confusion. Separate this to two sections. Create a letter here, let's say X, whatever, and this letter will be what will be packed inside this list. Then just say a simple for loop for X, the same X variable you're saying, which will be unpacked in the list, in whatever list you have. So this X in every iteration will go inside this S and extract every element. Where will this X go? It will go in here, in the list. Let me give you another example. Let's say you want to create a list with a certain range. You can easily do it like that. So we would say li of numbers. Let's create a list that is called like this, and we'll say we'll say x for x in range of maybe 100, or maybe this is too much, 10. Okay. And now all I need to do is maybe just print this list of numbers. I'm gonna remove this print for a second. And let's print it. As you can see now, you got yourself an array of numbers. So that's really good. All you said is for x in the range of 10. So extract the whole range from 0 to 9 and put it in x, and then this x will be populating the whole list. Let's say that maybe you need only odd numbers, okay, in this list. You don't need any even numbers. So all you need to say is if x modulo 2 is not equal to 0. If the number modulo 2 is equal to 0, it means it's even. If it does not equal to 0, it means it is odd. Now, if I try to do this, you'll see that I got only odd numbers. Let's say I want even numbers. Just say equal equal. And I will be getting 0, 2, 4, 6, 8, which are even numbers. So list comprehensions can be really, really useful in many cases. What I want to talk about right now is what we call the zip keyword. Now, let me create two lists. The first one is going to be containing some shape labels. So I'm going to say here shapes is equal to square, circle, and let's say triangle. Next, I would like to have a list that contains the centers of those shapes. So I'm going to say centers is equal to a list that contains multiple tuples. Let's say the center of the square on the screen is at the coordinate, let's say 10 by 10. So the x is 10 and the y is 10. And then I have the circle is centered at around 50 by 50. And let's say that the triangle is centered around maybe 100 by 100. Let's say that I would like to print every shape and its center. Python tries to minimize the index axis as much as possible. This is why it invented all of these keywords like enumerate and zip. Let's see what zip is. But first, let me give you a scenario where we will not be using zip. So as I said, we will be printing the shape and the center next to it. So we will say for I in range, let's say from 0 to the length of shapes, right? This is how we try to iterate over everything. And then we'll be printing shapes, I, and then here centers, I. When we execute this, we will get square, and then the coordinate, circle, the coordinate, and triangle, the coordinate. That's really good. But as I said, Python tries to minimize this syntax because relatively for Python, it's slow. This is why we have enumerate, we have zip. So let's see how we can do the same thing, but with the zip keyword. I'm going to leave everything here and just write in the line just below it. I'm going to say for. Now we need two placeholders, one for the shape and one for the centers. So I'm going to say shape and center. Those are just placeholders. And then we will say in and then say zip. We will be passing shapes and centers. Okay? And here I'm going to be saying print, shape, and center. Now, this is the same as getting a variable iterating over a list. But let's say you have now two lists. You would need two variables. So we created the two variables. Then we would say zip to pass the two lists inside. I mean, we cannot just say in shapes and centers. This syntax will not work. If we execute it, we will get too many values to unpack. This is why we have zip actually. Now we have two keywords. Each one is iterating over a list, and then we are extracting them right here. So it's a really very similar syntax. Now let me comment this out so that it's not printed. If I print this, you'll see that I got the same thing. And the zip keywords can take multiple lists. Let's say here I have the color of every shape. So maybe here I have red, blue, and yellow. Now I can simply just pass color here as well. And here just say color. Now this needs to be colors actually. These are colors. And this is the placeholder called color. These placeholders can be called anything you want. Now let's print the color. If I execute this, you'll see that now I have shape, center, and color for every shape I have. And this is how we use the zip keyword. Okay, so right now we are going to start a new small project. What is this project is about? Well, when you are learning programming, you might not be able to relate to some really big project because especially when you are learning the basic. But I will try to give you an example that is really close to the real life applications. Let's say that you have your computer. This is your monitor. Okay? And let's say that you have a drag and drop functionality. So this is an image right here. All right. And this image can be dragged and dropped all the way to wherever you want it to go. Okay. You can drag it and drop it here by just holding and then dragging to the other side. All right. Now, every image consists of pixels, right? It is those lighting small things that give the image the shape it has, right? And every pixel right here has a coordinate on the screen. So let's say this is my screen, and let's say that this is my X and this is my Y. Now, for example, let's say that this pixel has a coordinate of 50 on the X and 30 on the Y. Now let's take another pixel, and it is this one. This one is moving towards the Y, as you can see, and the X is the same, right? I mean, this value and this value have the same X, but they have different Ys. So this is X and this is Y. So it has the same X, and Y is increasing, let's say, by 1 for the next pixel. And we can continue sweeping all the Ys, right? Same thing, if we go to the right, this pixel, for example, has an X of 51 because we moved only one unit to the right, and it has the same Y because we are only moving to the right, we are not moving up and down, so it would be the same Y. Alright? Next pixel would be 52, 31, and so on and so forth. As you can see, we end up having multiple coordinates, and here where I will link the drag and drop for you to this concept. Now, when you drag and drop, what you are telling your computer is change all the coordinates of this area from the screen to those coordinates. Okay, so maybe by just changing from here to here, we are shifting all the x's by, let's say, 200 pixels, and we are shifting all the y's by, let's say, 10 pixels. Okay? Because when you are moving it, you are actually shifting all the pixels with the same amount on the x and with a certain amount on the y, right? Does this make sense? I mean, this pixel will be here, this one will be here, here. They are just moving from one area to another area with a fixed ratio. I mean, if this ratio is not fixed, what does this mean? It means that the image will not keep its form. If this pixel changes to here and the second pixel changes to here, you will have some really messed up image. Okay, so here where we will be creating a small function that will take coordinates and it will translate it with a certain x shift and a certain y shift. Okay, let's see how we can do that in Python. Alright, so let's work on our small algorithm which will be shifting pixels to any direction we want. Let's assume that I have a picture with the size 4 pixels by 4 pixels. And let's assume that my whole screen is 16 pixels times 16 pixels. Okay? All right. So let us first define our pixel for the image. So this is the image pixels, and we said it's going to be 4 by 4. So let's create a list inside the list. All right. So this is the first row. It has 4 pixels. This is 1, 2, 3, 4. Now, second row, also 4, also 4, and also 4. So we have 4 by 4 image. Each one of those is the pixel location. Now, I'm going to assume the following. This is my screen. This is 16 by 16. And my image is at the left top portion. This is a 4 by 4 image. Now, we're going to do some operations to move this right, like that, and then some movement left. All right? Let's do this shifting. So let us fill the position. Since it will be at the top left, it's going to start from position 0, 0. Then we are moving in the x-axis, right? Because this is a row. So y will be the same, x will move. So it's 1, 0, 2, 0, and 3, 0. Now we are moving in the y direction. So this is going to be 0, 1, 1, 1, 2, 1, and 3, 1. Next, this is 0, 2, 1, 2, 2, 2, and 3, 2. Finally, we have 0, 3, 1, 3, 2, 3, and finally 3, 3. Okay, this is my pixels. Now, how can we implement the shift? We will be utilizing the for loops. We are going to say the following. For I in range between 0 and whatever the length of my image pixels. What are we saying here exactly? What we are saying is, I want this I, this counter, to loop over every position individually. Remember, a position has an X and a Y. So every single position we will be looping through them. All right? Now, we are saying loop from 0 to the length of image pixel. Remember the len function we have talked about? It means that it will see whatever the size here we have, and it's going to go to all of them. All right? So, what are we going to do? Let's say that my goal is to shift the x-axis, okay, in the positive x-axis, 3 pixels, meaning 3 pixels to the right. All right? So, I am intending to move the index 0 of every position by 3 pixels. How would we do that? We need to replace this index right here for every position. How can we replace it? We need to say image pixels I, and what do I want to change? Remember, I am changing the x, meaning index 0 is going to equal to image pixels I0 plus 3. So, since we are looping, this portion right here, only this portion, is related to looping through those. Now, this portion says that while you are looping through those, check the index 0 and replace it with, again, same. Let's say we are at the first element, index 0. What is the value of image pixel I0? Well, assuming I is 0, it means that we are at this cell and we are looking at the 0 index, meaning this one, and we are replacing it to whatever value it is, which is 0 in this first element, and we are adding 3. When I equals 1, we will be jumping here So it will be image pixels 1, 0. So it is this one, right? Because this is the 1 and this is the 0. And we are adding 3 to it. So it is 1 plus 0, it's going to be 4. All right? Now, if I simply print my image pixels, as you can see now, all the X positions was increased by 3. Can you see that? It was 0, 1, 2, 3. Now it is 3, 4, 5, 6. It was 0, 1, 2, 3. Again 0, 1, 2, 3. Again 3, 4, 5, 6. And so on and so forth. Now, let's say that after that I want to shift by 2 positions, 2 pixels down. So shift y-axis 2 pixels to, or let's just say downwards. Okay, so I'm just gonna copy all of this, add it here, and all I will need to do is just to change that. I want to change the y's, not the x's, right? And I'm gonna move it by 2 pixels. Now let's print again. Now this is the second print. As you can see now, all y's were increased by 2. So we have all 2's right here, all 3's right here, all 4's right here, all 5's right here. Okay, so we have completed this small exercise.
Now it's time to leave the main Python space and move to the functions space. Functions are like shelves that organize our code. Instead of spreading everything in one place, we will organize our code chunks in a more meaningful way. This will also help other programmers understand your code, because after you start using functions, the overall look of your code will be much better, more readable. So let's go and get started writing some functions.
Alright, new topic, and it's about functions. And no, this is not the same as math functions. Okay, so let's give an example of what functions are. Functions are important in order to eliminate repetitive code in our code. Okay, so instead of writing something a billion times, we can just write it once or call it once. What do I mean by that? Let's say that I have a database of a company, and this company has multiple branches. So let's say this is company branch 1, company branch 2, company branch 3. And it has an employees list. Each has an employees list. Okay, this is employee 1, 2, employee 1, 2, etc., etc. Now, let's say that I have hired a regional manager. Okay, bear with me. Now, when I look up this regional manager, I want to see it in all the databases in every branch. Okay, because he is directing all of those branches. So when somebody looks him up in a certain branch, he should be able to see him in all of them. Now, I know this is a little bit of an exaggerated example, but bear with me. Let's say that I want to add this regional manager to all of those. Let's say that we have multiple roles that need to be included in all of the databases. Now, the way we have learned in order to add something to a database, we would say, let's say that this is my list or database. We would do append, right? And we add the name of the employee. Now we would do this for database 1, database 2, same thing, database 3, we would append the same name. Now imagine if I have around 5 roles that needs to be appended to all of these databases? Well, this is name 1, okay? I would need to do the same thing, database 1.append name 2. Maybe a second regional manager or a second general role. I would need to do the same thing for database 2, 3. All of them are for name 2, right? So I'm going to be creating 3 lines of code every time I want to add a general employee who needs to be added to all 3 databases. Imagine if I have 15 employees like that. Well, 15 employees times 3, this is around 45 lines of code. This is repetitive. This is not right. And here comes what we call functions. Now, a function, if we just define function, let's call it function 1, we could do these db1 append name. We will pass name here. We would do db2 dot append name, and same for db3. Okay, this is a scope which is called function. Now, everything we have written so far, we have written it in a function actually, and it's called main. All the code that we have written, even though it's not visible, it's written in main. Okay, everything. Now, inside this main that we were writing, we would say, instead of writing all of these 3 lines of code, I would only say func1 and pass a name, and I'm done. It will jump to this piece of code every time, and it will do all of those operations. Let's say I want to append a new name. All I need to say just func1 and a different name. Okay, it will jump, take this name, and fill it here for me. Okay, now let us see how does this work in action. So let us code those functions we have talked about. So as I've told you, whatever we write here, this is main. Okay, so right now let us define a piece of function that we will go to every time we want to execute some code. Let's add that database functions. We're going to say definition add to database. This is the name of my function. You can call it whatever you want. And here is a parameter to pass. We are going to pass name to it. Okay, this is a parameter that we pass to the function so that we can use it in our function. So what do I mean by that? Let's say that this is where we write our function, and here is my main. Alright, so if I want to call this function, I would have to say add to database and just pass it a name. Let's say John. Alright, this is all I need to do. Then this piece of code will execute and add it to the database. Same thing, I would just do the same thing, and I will say add to database Mr. Hamsho. Okay, it will go and do whatever necessary in order to add it to the database. I don't have to do all the steps every time in the main. Okay, let's see how we can implement those steps. Now, the John here is the name. The Mr. Hamsho here is going to be the name again. Okay, so let us now, just fictionally actually, and I will tell you why I'm saying fictionally, let us define the databases inside my definition, inside my function. So let's say database 1, which is for the first company branch. It has employees like Kate, Moss, David. Same thing here, database 2. Let's say that it has different employees like Lee, Steve. Okay, and database 3 we have Tony and Laura. Alright, now what we are going to say is db1.append name. Same thing for db2, same thing for db3. I'm going to append this regional manager, let's say, to all my 3 databases at once. Alright, so right now, whenever I call this function, all of this will be executed. Whenever I call this function, all of this will be executed with the name Mr. Hamsho or with the name John or whatever. Now let us print here. Print db1 is db1 Let's do this for all the others. Now let's hit on start. As you can see right now, we have added John to my database for the first one, and we added Mr. Hamsho to our database. See what functions do? They really save you a lot of coding. If I need to do this regular way, I would need to write 3 lines for every 1 line here. So we have saved around 70%. Alright, but if you have noticed, I added John here, but I cannot see it here when I added Mr. Hamsho. Now, this is what I said. Let's take this fictional example. Okay, it's because these databases were defined inside the function here. And whenever I execute this function and I exit it, any variables will be deleted. So those are like temporary memory. So remember, I call a function. It goes here. It executes everything. Okay, it executes every line. But once I'm done executing, every variable that I have defined is going to be deleted. So this is what we are going to talk about next. Now I'm going to talk about global variables. Well, this topic comes hand in hand with functions. It's also related to scopes. What does all of this mean? Well, remember, we can define functions. So define func1, and it could do some stuff. Then define func2. It could do some stuff, and then I have my main. Okay, which is also doing some stuff. Now, if we create a variable here, this variable will be deleted after execution. Okay, same thing here. This is another variable, same scenario. Now in main, this won't happen. If I created a variable here, it will stay. So I can say that the scope of this variable here is only function 1. And the scope of this variable here is only function 2. It means this variable here is alive only as long as function 2 is executing. By the end of execution of function, this variable will die. Okay? Now, what can we do in order to create a variable that is accessible by everybody? Let's say I want a variable that is accessible by main, by function 2, by function 1, by everyone. At the top, you could define something called a global variable. Okay, so if you define a variable just at top, let's say variable here, it's equal to, doesn't really matter, to an empty list, let's say. Now, each function can have access to it and actually modify it. It doesn't die, it stays here. It is there forever. Okay, So, and this is called the global variable. This is called the global. However, in order for this global variable to be accessible, let's say by this function 1 right here, we need to write it as follows. We need to write a global var. If you don't write global, it won't understand that you are referring to this one. Okay, so if you just write variable like that, as in here, this won't actually modify the one right here. Only if you write it like that, like this way, you will be able to modify it here. Okay, so it's a condition that you add the global keyword inside the function in order to modify it. Now you don't have to do that in the main. Now let us apply this in an example. So we have implemented this example previously, and we had a problem that we defined 3 databases inside the function, and when we tried to add them and print them, we printed them correctly, but adding 2 names resulted in only adding one of them. If we run this again, as you remember, we said that we tried to add John, we added it, but when we tried to add Mr. Hamsho, John was gone because the databases are defined inside the functions, which will die actually once this function is done executing. What we need to do is cut all of these, put them here. Now those are global variables. And let's cut all of these and just put them outside. Okay, let us try to run this. Things are much better. Now we have John and Mr. Hamsho in every database. That's great. So right now this database scope is global and everybody can access it. That's why you don't just put variables inside a function unless they are temporary variables to help the function do its job. Now, I have talked about global. Why didn't I mention global inside the function? Remember, I said that you need a global keyword in order to modify any of those that are global. Well, since here we are not really changing the variable value from its root and only modifying an object, or let's say we are only modifying it for now, well, we don't need to add a global, but I want you to observe this closely. Let's say that I want database 1 to equal to only that name. Okay, I want to delete everything. Will this work? Will I keep everything that I have done? Will all the names be kept? Or will they be replaced? Remember, my goal here when I do this is to replace it. I mean, I want to delete everything and just add the names I am putting here, right? So the first print should generate me all Johns. So right here, when we execute this, all of those should be John, and then when I execute this, it will be overwritten, and all of them should be Mr. Hamsho, right? Because, bear with me, because look here, add to database John, modify database, and make its value only equal to a list that equals John, same here, same here. Next, add database, add Mr. Hamsho. Again, override the whole database and just make it equal to Mr. Hamsho, Mr. Hamsho, Mr. Hamsho. So if I print those, I will get Mr. Hamsho's only. Let's see what's going to happen. As you can see, the value did not change at all. See, it's no John, no Mr. Hamsho, it's just stayed as it is intact. Now, in order to be able to modify a value of a global variable from its root, like change it entirely, you need to do global. So you need to say global d1, then say global db2, then say global db3. Now what you have done is you have linked this db here, linked this db here, and linked this one here to the global ones. Now if I run it, I should get all Mr. Hamshows. And as you can see, I got all Mr. Hamshows. And by that, we have learned what is a scope and what is a global variable. Just a quick summarization. If you want to only modify a variable like appending to a list, you don't need to do this global. Only if you want to change the variable from its root. Alright, so we are continuing with functions. We are not done yet. We need to talk about return values. What are those? Well, our beautiful template here, having a define a function, it takes some argument or parameter, and it does something, and then we have our main. Okay. Sometimes we would like to send data from main to the function. We want the function to do something and then return a result back to my main. What could this be? Could be anything. I could create a very simple function here that maybe it will just multiply the number I pass by 7. So I would say, hey, argument is equal to argument times 7 plus 100. I could do an entire mathematical operation here and just say return argument. Now in my main, I have called func with number, let's say 6. And I assign it to a variable here. So what's going to happen? This function right here will jump all the way. It will pass 6. So this is 6. Now we are saying this argument that you have passed will get updated and it will equal to the value itself, which is 6 times 7 plus 100. And then the final result will be returned here. Now this result will go back to main and it will be stored in this x. So x will equal to whatever value that argument, that returning argument has. Okay? Let me give you a simpler example. Let's say that I have a function called power of 2. Okay? And I pass it a number here. And it will just say return number times number. It will only do this. Okay? Now in my main, all I need to say is y, let's say, is equal to power 2, 7. So let's track it one more time. 7 will be up here. It will be passed here. And we are returning, what is number here? It's here and here. So this will be 7 times 7. So the result is 49. I'm returning 49 here. Okay. So where am I returning this? Back to the main. And exactly to the variable that is supposed to hold the result of this function. So this whole function now will be replaced by 49, which will be the value of y. Okay? So a return is simply a very simple number or a list or an object that will be returned from my function to my main. Let's write a small program for this. Let us define a function and see how return works in action. Let's get to it. First, let's have a define, and I want a function that returns, and I have a function that you pass to it a number and it returns power 2 of this number. Okay, so I'm going to just call it power 2, and here I will be taking a number. The easy way to do that is just by saying return number times number, right? Now, see this return? I'm going to show you now how we can save this return in the main. Now this is my function. This is my main, right? Everything in function will be under the function with a block indent like that. So if I have more code to write, I just write it all with the same block indent, that is this space right here. Okay? The moment I just go away from this space and I am on the beginning of the line, I am in my main. So right now, I'm just going to say result is equal to power 2, and let us pass a number. Let's say 5. Okay. Now, if I just print result, I got 25. So what happens is, this power is called, we are here and we are passing a number to it, which is num. So this 5 is actually this num. Now we have num times num. What is num? It's 5. So 5 times 5 is 25. And we are returning it and exiting this function. So instead of this whole function right here, we will get the return value. Okay, so right now, the return value is here and it will be assigned to result. Okay, so result will be 25. There is also another case where I can return multiple values. So let's say I want to return 2 values. First one is the power 2 and it equals to num times num. Okay. And then maybe I want to return something like the division of these two numbers. So maybe num divided by num. So all I need to do is just in return, I would say return bw2 and return diff. Okay, so the calculations are done here. Now I'm returning the result variables. Now in this case, I need only to pass one number, that's correct. But returning will not be okay if we have only one variable, because we have 2 variables to be returned. Now if I try to just run this, what I would get is the result being packed with 2 values, alright? A better way to do that is to actually have 2 variables, so maybe bw2 and div. Alright, so right now, if I say here bw2 is, and I just say bw2, same here, div is, and div is equal to that. Now if I run this, you would see that bw2 got the right result and div got the right result, right? Because 5 over 5 is 1 and 5 times 5 is 25. Okay, so you need to watch out when you are returning 2 variables. You need to prepare 2 variables to catch it after the function is executed and is returning. Okay, you can have multiple values to be returned using Python, and that's really a powerful trait that Python have, and most other programming languages don't have this feature. Okay. This section is going to be really fun because we are going to create a ping pong game that 2 players can play at the same time. This section is based on a library that is called Turtle. And Turtle is a very simple library that helps us create simple games like those we saw on the arcade in the 80s. So let's get started and code some Turtle. First we are going to import what we call a turtle. Before we start coding any game, let us create a window that will show our game. We are going to create a screen first, and this screen is called turtle.screen, capital letter, and by that we have created the screen. Now we can give it a title, so I'm going to say screen.title. We're going to call this ping pong. Next, we can specify the background color for our window. So I'm going to say here screen.bgcolor, and then we are going to say that the background is going to be blue. Next, we need to specify the size of this screen. So we'll say screen.setup, and then we will say the width of the screen is maybe 800 pixels, and we have the height, and let it be 600 pixels. We are almost done. We just need to activate the tracer. So we have screen.tracer, and we need to initialize it with 0. And by that, we have prepared our screen. Now, if I click on play, I will be getting a window that looks like this, but it will crash immediately. So let us add one more thing, which is called screen update. And this will be in an infinite loop. So we will say while 1 to create an infinite loop. Then here we will simply just say screen dot update. And we will run the program again. Now take a look. We have a window that is called ping pong. It has a background of blue, and we have a width of 800 and a height of 600. So this is how we initialize our first window using Turtle to create our ping pong game. Now let me explain how will this ping pong game be. We are going to create two bars right here that will represent the player paddle, which they will move up, down, right, and left. We have two of them, and then we have a ball in the middle that will be bouncing between these two paddles. And the goal is whenever this ball will be bouncing between the players, and if a player can get the ball into his opponent other side wall, like right here, then he will get 1 point. So this is what ping pong is. Now let's start implementing more functions and see how easy it is to create simple games with Turtle. Now after we've done and created our window, let us create our first paddle. So to create a paddle, we are going to do the following. I'm going to define a variable that is called paddle underscore 1. Okay, so this is for player 1. And then we need to create an object that will be our paddle. The way to do that is just by saying turtle dot turtle capital letter. Now turtle is those objects that will be moving around the screen, and we are creating a turtle object, which will be our paddle. We can specify its shape, we can specify its color, we can specify its size and its position. So let's do all of those that I have just mentioned. First we need to say paddle underscore 1, and now we need to specify the shape. How do we do that? We just put a point, dot like that, and then just say shape. Now the shape here is going to be square. This will be my paddle 1. Now how about we choose its color? So I'm going to say paddle underscore 1 dot color, and the color here is going to be white. Okay? What's next? We need to specify the shape size. So we're going to say paddle underscore 1 dot shape size, and here we can specify what is the width and the height of this square. Remember, we are trying to create a rectangle that will be our paddle. So let us simply just say stretch underscore width is equal to 5, and the stretch underscore length is equal to 1. Okay, now let's see what's happening on the screen. If I try to execute this, I will be getting a rectangle like that is white in the middle of the screen, but it does nothing. But this one has a potential to be moving around. Why? Because we created it using a turtle object. Now don't worry about these terms like object, because we will be talking about all of this in the object-oriented programming section. But for now, just imagine that you are creating a function of that turtle, and you can pass to it a shape, color, and shape size, and you can do all of this stuff with it. Okay? So as you can see, it's very simple so far. Now let's add more functions. How about we change the position of this rectangle? I'm gonna close this. The program will crash here. I'm gonna press this X button here so that we can execute again. And now let us specify the position. If I say paddle underscore 1 dot go to, which will specify the position, and then just say minus 350 and 0. What does this mean? The window we have will be divided into two sections. The width will be spanning between minus 400 until 400. If you add these up in the absolute value, you will get 800, right? Because we have 400 in the minus section and we have 400 in the positive section. So the screen will be divided into two sections. The height as well will be divided into two. We have plus 300 and minus 300. Okay, so let me illustrate this really quick to you. If this is my screen like this, and I specified that I want the width to be, let's say 800, and the height to be 600 like that, then I will be having an origin point, which is here at 0, and here I will be having two sections, okay? This is the 0 point, this will be my minus 400, and this will be my plus 400. Okay, so here the values are increasing from 0, 1, 2, 3, all to 400. And here the values are increasing minus 1, 2, 3, all the way to minus 400. Same thing for the height. If we go like this is my height. This is still my 0 point. This will be plus 300. And this will be minus 300. Okay, so the screen will have 1, 2, 3, 4 sections. Okay, so right now I said that I want my paddle to be at the most left, which is at the minus 350. I'm leaving about 50 pixels margin so that we can let the ball go behind the paddle in order for the second player to score on the first player. So let me execute this really quick. I'm gonna press this X button to refresh everything and execute. Now, you'll notice that there is this weird line that is happening here. And the position is correct of the final rectangle being at the minus 350, right? It is at the far left side of the screen. And the y point is being at 0, right? Because the y is this vertical line and the x is this horizontal line. Okay, so this one is correct. But what about this fine line we have here? The reason is when you say go to, it will be drawing all the way from the center to whatever position you are specifying. So this go to, we actually use it to draw shapes on the Canva or the window right here. How can we prevent this and just move this rectangle from being in the middle to being on the left without drawing the line it went through? Well, we need to use a function before that, which is called pen up. So I'm going to say here paddle underscore 1, then dot pen up. And now if I execute this again, let me refresh, run this. As you can see, the line is gone and we have created our paddle. Congratulations, now you have your first playing object. How about we create a second paddle that will be on the far right side? Well, this is very easy. I'm going to be copying everything I've done here. I'm going to just put it here. And then I'm going to change the variable name to paddle2. And how about we only change the position to be at plus 350? Let's close this, refresh, and run again. Now you'll see that we have two paddles on parallel sides of the screen. This is at 350, 0, meaning 350 at the x-axis and 0 at the y-axis, right? And this is at minus 350 and 0. Okay, that's really great. Next, we will be adding some functionality to move those paddles around. Alright, so right now, how can we add functions to move the paddle to the up, down, right, and left? Every position will have its own function, so we will be having in total 4 functions for every paddle. How can we do that? Well, we are going to define a function here that is called paddle underscore 1 underscore up. This will move the player 1 paddle up every time we press a key, okay? So, the first thing we want to do is to take the current position of our rectangle. What is the initial position here? It is minus 350 for player 1. So when we call this following function, it's going to read wherever the paddle is on the screen at that reading moment. So I'm going to say here y is equal to paddle underscore 1. Then we will be calling here a function called y coordinate, meaning that I would like to read the y coordinate of that pedal. Why the y coordinate? Well, because when we want to go up and down, we are moving on the y-axis. So up is a plus y and down is minus y. So first I would like to know where is it on the y-axis right now, where is my pedal? Then this will return a number. So initially this number will be 0, right? Because we are looking at the y coordinate. This minus 350 is for the x, the 0 is for the y. Okay, so what happens next? What I would like to do is, after I read it, I would like to change the y coordinate into a new coordinate. So I'm going to say y is equal to maybe y plus 10. So I'm going to be moving this 10 pixels whenever I am moving up. So this whole object here will be going up 10 pixels on the y-axis. Is that it? No, we have defined a new step. Now we need to set it or confirm it and send it to the pedal. How do we do that? We just say pedal underscore 1, then we say dot set y, meaning give y a new value, and then we pass it the y value. Okay, and that's it. By that we can move the pedal up. Now we need to link this to a key, right? Because right now, yes, we have a function that will go up, but what is the key that we should press in order to execute this function? We need to call the following. We need to say screen dot, it is the same screen we have created at first, and we will call a method here which is called onKeyPress, meaning whenever I press a certain key, I want you to do the following. What key is it? Well, let's say when I press W, I would like to go up. So here you specify, hey, if you see me press W, call the function pedal1 up. Okay? So here I will be passing this function name pedal1 up, and I will be linking it to this W key. So I press W, pedal1 up will be called, and it will be executed. There is one more thing that we want to call, which is called the screen.listen, meaning that the screen will be listening to your keyboard to see if you press any key. Now let us test this quickly. I'm going to close the previous program, click on this X right here to refresh the environment, and then we will execute one more time. Now take a look. If I press W, we have an error here. Let's take a look. Yes, this is a function actually that we did not call. We need to pass parentheses because we are calling a function right here. Now let's try again. I'm closing this. Let's refresh the environment and let's run it. Now if I press W, you'll see that the pedal is going up, and this is what we expected. But here is the catch. If I continue pressing W, you'll see that the rectangle will go out of the screen. We are going to solve this issue immediately. Let's close everything, refresh the environment, and here we will be setting a condition. What is this condition? Well, we're going to say if y is larger than. So let's give the pedal a space to move to the top. What is the height here? It's 600, so meaning 300 up and 300 down. Now notice here, if I say if y is larger than 300, meaning that if you see that this pedal is trying to exceed the screen, then what I would like to do is say pedal underscore 1. Then we're going to say set y to 300. What does this mean? Remember here that whenever we are pressing up, we are increasing this y by 10 and setting a new y. Now if we calculate and see that y is over 300, I would like to set y to be 300 and never increase at all. Now 300 is the wrong value, and I'm gonna show you why. Even though it is the limit of the screen, this is not the right way to do it, and let's see why immediately. I'm gonna run this. If I try to go up, you'll see that we still exceed the screen, but we stop right here. Why is that? Because we are not accounting for the height of our paddle itself. So a better way to do it is to take the maximum height we can have minus some margin. Let's make this 240 instead of 300. Now let me run this again, reset the environment, and rerun. Now if I go up, you'll see that I stopped here. So I just left a small margin over there at the top, and that's it. Now we are moving up correctly. Let's reset this. Now, same way we did this for the first player, we are going to do the same thing for the second player. We'll say here, pedal 2 up is equal to y equals pedal 2. Okay, same thing, y equals y plus 10. And same thing at the y right here. Everything is just the same, but here we need pedal 2 instead of pedal 1. We also need to assign a key for the second pedal. So we will say here screen on key press and then pedal 2. And here we need to say up like that, meaning that when we press the upper arrow on our keyboard, the second player is going to move up. Now let's test this. Now if I press the upper arrow, you'll see that it is moving. I'm pressing the W as well at the same time. And now both players are moving up and stopping at the boundaries we have specified. That's really cool. Now we have two objects moving on the screen using our keyboard. How about we add more functions? So far we only binded the upper movement to both pedal A and B. Now how about we bind the other movements? Let's say the down arrow, the right arrow, and the left arrow. So let's do that. I'm going to define here a function called pedal1 underscore down. So this will be the downwards movement. We are going to do the same thing. We will say y is equal to pedal underscore 1 dot y coordinates. So the first thing in order to make a movement is to read the current position, increment it or decrement it, and then update that position, right? So right here we are going to say y is equal to y plus 10. Now, I would like to generalize this as a step. So right here, I'm going to create a variable that is called the step. It will be equaling to 10, so that if I would like to change the speed of the pedal, I can simply do that by just changing the step. Because this one is indicating how many pixels would I like to move whenever I press a certain arrow. And right now it is determined by 10 pixels. What if I wanted to make the movement faster? Then I would like this pedal to jump more pixels whenever we have a step. So here this will be step. This also will be step. Now let's continue. Do you think this is right? Well, since we are moving downwards, we would like to go downwards, meaning that y need to be decremented. So y will equal to y minus step. So going up, we will be incrementing up the y coordinate, and when we are moving down, the y coordinate will be decremented down. Now we can say pedal underscore 1 dot set y, and we need to pass the new y, right? Now we need to put boundaries, the same thing we put boundaries when we were moving up so that the pedal does not go out of the screen. We need to do the same thing for the down movement. So we're going to say if y is less than minus 240 this time, right? Because the screen is divided into plus 300 and minus 300. Now we don't want the pedal to go out of the screen in the negative section since we are going downwards to the negative coordinates. Now we are going to say pedal underscore 1 dot set y to 240. And this will be my downward movement. Now let's do the same thing but for the second pedal. So this will be my second pedals. Here as well, second pedal, second and second. All right. Now, lastly, we would like to bind those with new keys. Okay. So let's say for the first player, if we press S, then we would go down. So right here, this will be down, right? And now for the second player, this will be down. And here we need to say player 2, right? So right now we have paddle 1 up, paddle 1 down, paddle 2 up, and paddle 2 down. Okay, now let us close the previous game and let's recompile. Now let's take a look. If I press S, you'll see that the paddle is going downwards. But here I think we have a bug because whenever we are reaching the end, we are going back here. Let's say Y. Yes, because this needs to be minus 240. Right now what we are saying, whenever we reach the end, we want to change the coordinate to 240 instead of keeping it at minus 240. This is why we are jumping back. So let's fix this for the other one as well. So this will be minus 240. Let's close everything and rerun the program. Now let's say S. And as you can see, we stopped at the end of the screen. If we go up by pressing W, we stopped at the upper end. Now let's try this one. This is up, upper arrow, and this is down with the other arrow. That's really good. Now we are going to create the right movement and the left movement. Let's start with the first paddle as well. So we're going to say diff paddle underscore 1 underscore right. Now let's design the right movement. How would we like to program the right movement? Well, since this is not up and down and this will be right and left that will come next, it means that we would need to move on the x-axis and not on the y-axis. It means that we need to get the x-coordinate. Unlike here where we got the y-coordinate because we would like to move up and down, now we need to get the x-coordinate because we would like to move right and left. So x is equal to paddle underscore 1 dot x-coordinate. This will be the difference. Now, when we are moving right, we are incrementing the x-axis, right? So if this is the origin and we are moving this way, it means that x needs to be incremented. So x will equal to x plus step, the same step we have defined here. And finally, we need to say paddle underscore 1 dot set. We need to put an indented block here. Here we need to set x this time. And it will be the x. Okay, so the difference between up and down, right and left is that up and down is y, right and left is x. And all the functions will correspond to x, like x coordinate and set x, unlike here y coordinate and set y. Now we need to put the boundaries just as usual, right? I'm going to be saying here, if x is larger than minus 10, why minus 10? Well, let me show you. Take a look here. This is the first paddle. Let me draw it really quickly. This is my first paddle actually. Okay. Now, this paddle, when it moves right, it needs to move here. We are in the negative section of the x-axis, right? Because this is the x-axis. This is x. And we are moving along the x-axis. Now, we are moving from minus 400 all the way to the 0. Where would I like my paddle to stop? Somewhere around here, just before the 0, so maybe at minus 10. If we move a little bit further, we will get to 0, and I don't want that. I want to stop just before the 0 point. So this is why we are making sure that the boundary is at minus 10 on the x-axis. So if it is minus 10, then what I would like to do is say paddle underscore 1 dot set x equals to minus 10. And by that, we have finalized paddle 1 right. Now let's do paddle 2 right. It will be a little bit different this time, and we will see why. So let's design the paddle 2 right. Now we are going to keep this, x is equal to paddle, just change this to 2, here as well, here as well. Now the boundaries will be different. Here I'm going to be saying if x is larger than 350, then I would like to set x to 350, okay? This will be paddle 2, this will be paddle 2. Why is that? Let's take a look. Paddle 2 actually is located right here. And when we are moving right, meaning this direction, we need to make sure that we don't hit the boundary right here, right? So we are leaving some gap, okay? So this is 400 at this point, at the last point. So I would like just to stop just before it, maybe somewhere right here. Okay, and this coordinate here would be around 350. All right, and this is why we are choosing 350 here, because we are moving right, and we need to make sure that we don't hit this boundary. I mean, unlike the right movement for this paddle where we are coming to the 0, here with the right movement of the second paddle, we are moving towards the end of the screen, right? This is why there is a huge difference between how the coordinates work in the right direction. So I'm gonna copy this, paste it here. So now paddle 1 right will be using my D key on the keyboard. And paddle 2 right will be by pressing the right arrow button. So this is right. Now let's stop the previous program and let us re-execute. Now let's try the right movement by pressing D. You'll see that we stopped just before the middle of the screen. We can go up, we can go down, and the boundaries are just working perfectly. I cannot go right any further. Now let's try this one. Up, down. Let's try the right. I cannot go right anymore. This is the maximum that I can go for the right paddle right here. We can decrease this a little bit, but I think it's really good to leave this kind of a gap between the paddle and the end of the screen. All right, now let's do the last one. We need to move left. So I'm gonna copy this paddle 1 right. Okay, I'm gonna change the name here to left. And the same thing, we would like to get the x coordinate because left and right are on the x coordinate. But right now, when I'm moving left, let's take a look. Now, take a look here. When we are moving left for this paddle, coordinates are decreasing, right? Here it's 0 and decreasing towards minus 400. And I need to account for the boundaries around the minus 400. Maybe I'll stop here at minus 350, just like the one here where we stopped at plus 350. Okay, it means that here we need to make x minus step because we are moving in the minus direction, and here we would like to check if x is less than minus 350. If yes, then we will say minus 350. Okay, now we will do the same thing for the second paddle. I'm gonna copy this, paste it here. Second paddle. We need to change everything to the second paddle. Second and second. Now, what is the condition right here? Well, let's take a look. When the second paddle is moving left, it means that we are moving in this direction, right? The x is decreasing, correct, and the boundary is just around the 0. We will stop at 10, just like here when we stopped at minus 10 when this one was moving to the right, okay? Because we are approaching 0 right now. So when you are designing this stuff, it's really important that you draw them out and try to see how the coordinates are distributed around your window so that you can program them correctly. Okay, so here it will be when it is less than 10, and here we will say 10. Lastly, we would like to bend it to a key, so let's take this. I'm gonna copy this. Now left is using the A button, and this will be left. I'm gonna copy this as well. This will be the left arrow. And the function is called paddle to left. Alright, so let's test it. I'm gonna close this, and I'm gonna rerun the program. Now let's try. If I press D, you'll see that I'm moving this way. When I press A, you'll see I'm moving this way, and the boundaries are just working as expected. If I go up, everything looks really good. I'm just pressing D, W, A, S, so it's working. Now let's try the second player. I'm moving to the left with the left arrow. I hit the boundary. I go up. I hit the upper boundary. I go down. Also hit the lower boundary. And let's try the right movement. Everything is working as expected. Let's see now, will they merge when I put them too close to each other? Yes. So they're really stopping just at the middle point right here. Okay? Alright, so right now the paddles movement is programmed and it is working as expected. So far we have two paddles to play around with, but we don't have any ball to play with. So let's create a ball to bounce in between these two paddles. Okay, so let's go to this section up here and make a space for the ball variable. I'm going to say ball. What do you think the variable here should be? Yes, it's just a turtle, like any other turtle. But this turtle will be a little bit different in shape. So we're going to say ball.shape. Then the shape here is circle. Makes sense since this is a ball. And we need the color. So ball.color. Let's give it the green color. Okay. All right. Now let's do a pinup so that we don't draw the trace when we are relocating the ball. And let's set the ball at the center of the screen. So we'll say ball dot go to 0, 0. Now, what I would like to do here is to define what we call a dx. This will be the step of the ball when it is moving. Okay, so here I'm going to say ball.dx will equal to 0.1, okay, and ball.dy will equal to minus 0.1. We will see what those terms mean when we progress a little bit. But for now, let's define the change in x and change in y to be 0.1 and minus 0.1 respectively. Now let's try to see how the window looks like. Reset everything and rerun the program. And here we go. Here we have a ball right now that we actually can just go under it, but it does not move, it does not bounce, it does nothing. How about we add some functionality to that ball, right? How about we create a function just right here to move the ball, and I'm gonna call it move ball. How would this function look like? Well, to move a ball, we need to set x and y values all the time, right? I mean, moving a ball all the time means that x and y are just constantly changing. So I'm going to say ball.set x. What are we going to set x into? Well, we will set it to ball.x coordinate, so whatever our current x coordinate is, plus ball.dx. What did we do here? You already know the setX function. We have used it a lot here, which is used to give a new location on the x-axis. Now I'm saying the ball location should be the current location. Let's say it is at 0, 0, plus this small change. This small change is 0.1. So every time we call this function, it will be the current location plus 0.1. And if we call it all the time, you will see that this dx will be changing all the time as well, right? If I call it 10 times, it will be x plus 0.1, it is 0.1. Then it is x plus 0.1, the x is already 0.1, plus 0.1, it will be 0.2. So the ball will be moving constantly. Now how about we set a y movement as well? So we'll say ball.set y, and then I'm going to say ball.y coordinate plus ball.dy. Does this make sense? The same thing, but we are moving the dy as well. Okay? Alright, it means that the dy will always be moving to the negative y-axis and the ball will always be moving in the positive x-axis. Just initially, it will be like that. Now, how about we set some boundaries? Because without it, the ball will go out of the screen. But let's test this out. Maybe let me show you one step at a time how will the window look like. Close this and just rerun. You'll see that the ball is not moving at all. Why? Because we did not call this function yet. Where should we call this function? Well, I'm going to show you. all you need to do is just go to the while loop and say here, move ball. Okay, does this make sense? Move ball will be called all the time. It means that the ball X and Y coordinates will change constantly because we are changing them every time we call this function. And we are calling it infinitely because we are in the infinite loop. Now the ball will not stop, but it will go out of the screen. Let's take a look together. We'll see that the ball is already went out of the screen and we cannot see it. Okay, so let's set the boundaries, and this will keep the ball bouncing inside the window. The boundaries will be left, up, down, and right. So we need just to set 4 boundaries. So let's do that. I'm going to say here x is equal to ball.x coordinate. So first I would like to see where is the ball right now. Then I want to check the boundaries. I'm going to store the x and the y in variables. So here ball.y coordinate is equal like this. Alright, so now we have the x and the y. I'm going to say here if x is larger than 390, meaning we are trying to set the right boundaries, then I would like to say ball.set x to be at 390. Okay? Then I would like to change the direction of the x-axis, because if the ball hits the boundary, we need it to bounce back. How can we do that? By changing this movement into a minus movement. Meaning instead of incrementing 0.1 to the current position in every frame, when we bounce from the right, we would like to take it to the opposite direction of the bouncing, right? Meaning that it should be minus here. And this is what we will do. We're going to say ball.dx is equal to ball.dx multiplied by minus 1, right? This will change this whole positive dx into a negative dx, meaning the ball will bounce in the opposite direction. Okay, so this is the first boundary. Now let's set the second boundary, which is on the far left side. So if x is less than minus 390, what I would like to do is ball.set x minus 390, and we need to negate the direction, right? So we're going to say the same thing here. Whatever the ball direction is, just negate it to go in the other way. Negation happens only by multiplying by minus 1 all the time. If you are in the positive, you multiply by minus 1, you change everything to go to the negative. Okay, now let's set the upper boundary. So if y is larger than 290, then ball.set y will be 290, and then we need now to negate the ball.dy this time, right? Because when we hit the upper boundary, we would like to go down. Going down means that y need to be in the negative direction. So ball dy will equal to ball.dy multiplied by minus 1. Okay? And finally, we need to put the boundary on the bottom of the screen. So if y is less than minus 290, then ball.set y will be minus 290, and then we will negate again. So ball.set y equals to ball.set y multiplied by minus 1. Now the bouncing should happen, and the ball should never go out of boundaries. I'm gonna reset all of this and run again. Yeah, okay, we have a problem here. We said set y instead of dy, so this should be dy, and this should be dy. Okay, again, let's run it. And here we go. We can see now that the ball is just moving and bouncing around the corners. Now there is no collision detection in this program, meaning that we did not decide what happens when the rectangle hits the ball, but at least the ball is actually just moving around in the corners without any issues. It's not going out of the screen anymore. All we need to do right now is to design some collision detection to let the paddle hit the ball. Now, how about we design some collision detection? Collision detection is actually a very large topic in the gaming industry. If you take a look at any gaming engine, one of the most important thing you would see is actually collision detection. What is collision detection exactly? Now, if you take a look, if I have a square like that and I have a ball and they are moving, what I would like to have is once this edge of the square, let's say, hit the edge of my ball, see, this is what we call collision. Alright? If you don't design this, this ball will go over the square. And this is not realistic. It's the same as when you have a character that is walking on the ground in a video game. The ground is actually nothing but a square. And the character should always be on top of the line of the ground. If you don't have collision detection, this character will fall and be embedded in the ground, and this is wrong. This is why we design collision detection, and collision detection works by taking a look at the edges of the two objects you have, and it tries to always prevent those objects from being merged into each other. So let's see how we can design a very simple one. I'm going to create a new function here and I'm going to call it collision detection. Let's design it just all the way down here. We are going to say here definition check collision and two parentheses. Okay, this will be my function. Now, what do I want to check exactly? Take a look here. Now, here is what we are going to check. I'm going to be checking if the ball x coordinate is between the paddle x coordinate plus a threshold and between the paddle x coordinate minus a certain threshold. Okay? And by that, we are checking if there is a small margin between the ball and the paddle, so that when this is satisfied, I would like to change the direction of the ball, right? So what I'm saying is, in simple terms, if the ball comes near the edge of the paddle, I would like the ball to change its direction, right? This is what we call bouncing, but not from the boundaries. This is a bouncing just from the paddle. So I'm going to say here, open a parenthesis and say paddle underscore 1 dot x coordinate, and this threshold will be, let's say, 20. This will be larger or equal to ball.x coordinate, and this should be also larger or equal to the minus threshold, which will be paddle underscore 1 dot x coordinate minus 20. Okay, let's try very simple collision. I'm not going to be concerned about the y coordinate now. So if this happens, meaning that if the ball is near the x coordinates of the paddle, what I would like to do is ball.dx is equal to ball.dx multiplied by minus 1. And here ball.dy is equal to ball.dy multiplied by minus 1. So I would like to change the direction of the ball whenever I come near the paddle. Now I would like to give a push to the ball as well. Okay, I changed direction, right? But I also want to give it a push. So let's take the x coordinate. I'm going to say x is equal to ball.x coordinate. And here I'm going to say x is equal to x plus 10. And I'm going to set a new x. Ball is equal to set x. If there is a mistake here, let's make it like that. And we forgot to say if. Okay. So let me recap. If the ball is near the paddle from the x coordinate, change the direction of the ball. And after changing direction, give it a push on the x-axis so that we can have this bounce feeling. And set the new ball axis. Okay, so right here, I'm going to be calling the function now check collision in every frame. Okay, now let's me test this. I'm going to close the old program and recompile everything. Now let's take a look. If the paddle comes here, as you can see, the paddle can actually push the ball. And that's really cool. Right now, we are just pushing the ball. Now let's add one more thing here. I'm going to say if it also comes near the y coordinate. So this is the x coordinate. And I'm going to say here and And I'm going to copy all of this and just do the same thing for the y coordinate. So here it will be y, and the threshold here will be 60, y, and y, and here it will be minus 60. This will give a better feeling for the collision. Now we cannot put this like that, so I'm gonna just put it over there, and here we go. Now let's take a look. I'm gonna restart the whole thing, run it. Now, let's try the collision one more time. As you can see now, the bouncing is much better. So we are waiting for the y and the x approximation, not only on the x approximation. Let's continue. How about we do the same thing for the second pedal? So all we need to do, just copy all of this and just paste it again, but change pedal 1 with pedal 2. So this will be pedal 2, here, here. Just change every pedal 1 to pedal 2, and everything will be the same. Now let's try this. I'm gonna restart the whole thing, run it again, and let's see the collision with the first pedal, with the second pedal. Now here we go. The collision here is not working from this direction. It's working only on the back of the second pedal. Now take a look here. If I just hit it like that, and I try to hit it from here, you'll see that it's not working. Well, let us fix this. Alright, and the reason for this issue is that here we are changing it in the wrong direction. For pedal 2, we are saying that if collision happens, increase in the direction of the positive axis, where we need to increase in the negative axis, right? Because the second player is here and we are pushing this way, right? When you are pushing this way, you are pushing at the negative x. So this will be negative. Now let me close this and rerun it again to see if this will work. Now let's see, this is the first. We hit it. Now let's try the second, and here we go. We are pushing the ball between these two. That's really cool. Okay, now what's left is to create scoring. Now when the ball just comes and hits the right boundary, I would like to have a score for the opponent, and vice versa. Now what's left to us is that we need to keep score. How do we keep score? We have two players. Let's say player 1 is on the left, player 2 is on the right. Whenever the ball hits the boundary of their right, it means that player 1 will get a point, right? Because he's shooting at the opposite side. And whenever the ball is at the boundary of the left side, means that player 2 will get the point. And this is how scoring works. Let's see how we can do that. First, we need to create a text so that we can display it and display the score. Let's get all the way here and just say pen is equal to, let's say score is equal to turtle.turtle. This will be the score text. Maybe I'll call it score text. And I need two scores to define. I have score 1, initially the result is 0. Score 2, also the result also is 0. Okay, so initially the result is 0, 0. Now here, let's put these parentheses. And now we are ready to continue. Next, I would like to give color. So score text.color is equal to, let's say, white maybe. Then we will do pen up. Then we will do score text.pen up, right? Because we don't want to throw the trace, and we will locate this somewhere. So I'm going to say score text.go to will be to maybe 0 to 160. So it will be at the upper portion of the screen in the middle. And then the text will be the following. Score text. Then we will pass a function that's called write. We will say player 1 column then 0 and give some spacing, then say player 2, not all of this spacing actually, and then player 2 is actually 0, Now we need to pass other parameters like align to put everything in the middle. So align will be center. Now the result will be in the center. And then we have the font. The font is a tuple actually, and we will pass the font name, the size, let's make it 22, not here, just outside like that, 22. And then the font type is just normal, okay? So as you can see, tuples is used to pass data, like coordinates, like font types. We pass just certain data through fonts to the function because we have talked about tuples, and this is one of the usages of them. Okay, now what's happening if I just reset this? Now we are resetting. Let's rerun. And here we go. As you can see now, we have the result being right here. That's really good. But what is this arrow right here? Well, this is the turtle. If you don't give your turtle a shape, it will be like this small arrow. So how can we hide it? Because this text is nothing but a turtle object that we have created. We need a way to hide it. Well, let's hide it and add the function for the scoring. So to hide it, you just need to say hide turtle. So I'm going to say here score text dot hide turtle like that. Now the arrow will go. Okay, now let's add the functionality for this. It's a very simple collision. This is how the score will be kept. If the ball is on the right boundary, then one of the players will get a score and vice versa. So I'm going to say here if ball.xcoordinate, if the ball x coordinate is larger or equal to 350, right? It means it is on the far most right. It means that player 1 will have a score. So here we have score 1 is equal to score 1 plus 1. We will increment it by 1. Now we need to clear the score so that we don't draw text above text, right? Because we already have a text right now when we initialize it up here, right? We need to delete this text and draw a new text with the new result. So this is why I'm going to call here score text.clear. This will delete it entirely. And then we are going to say score.text.write. We will write a new text, and it's going to be player 1. We will pass parentheses like this because we will be using the format. Then we have a player 2. Same thing, we will pass these curly brackets. I will tell you what are those in a minute. Now, if you go outside like this and just say format score 1 and score 2, this is what's going to happen. We will be writing player 1 on the screen, and instead of those curly brackets, we will replace them with score 1, and instead of this curly bracket, we'll replace it with a score 2. Okay? So that they are dynamic. Alright. Next, we need the same parameters, so I'm just going to copy the align and the text all the way here. And that's it. Now, once we updated the result, what else would we like to do? Well, I would like to actually put the ball in the middle one more time. So I'm going to say ball.go to 0, 0 after someone has scored. We change the position of the ball, and also we change the direction of the ball, right? Because initially the ball was going to the right and it hit the right boundaries. So the dx is right now going to the right. What I would like to do is right now the dx needs to go to the left. So what I'm gonna say here is ball.dx is equal to ball.dx multiplied by -1, and that's it. Now let's do the score for the second player. So here we'll say if, where should the ball here be? Well, it should be here less than -350. Okay, run. Now, as you can see, the game already started. It's already 1-1. So if this player could not catch it for some reason, you'll see that player 1 is now 2. Let's say player 2 is trying to score. And here we go. Player 2 has scored as well. As you can see, this is recording greatly. And here we go. This is a 3-2. And that's it. The game will just go on and on and on. And as you can see, after every score, we'll see that the ball is going in the opposite direction. So if this guy scores right now, the ball will go to him so that he can shoot it. Okay, and by that we have created this very simplified ping pong game. I hope that you have enjoyed that.
Congratulations on reaching this far in this course. I just want to remind you that this whole 9 hours course is actually a small portion of a much larger course that is hosted on Udemy. So in this course we are learning all the basics that Python includes in its features, but in the Udemy course we will be learning all about machine learning, deep learning, natural language processing, web design, and even designing beautiful user interfaces for our application. So if you would like to expand your knowledge and learn more about Python and go deeper to become a professional developer, you should definitely check that Udemy course out. The link is already in the description and you can actually get it discounted directly from me. This section is all about dictionaries, and no, it's not similar to the word dictionary we know of. This is a data structure that is very similar to lists, but it can be more organized than lists. It can hold keys and value, which is super helpful when we are trying to create small databases to store our information. Don't worry, we will be explaining all of that in details, so let's get started.
Let us now start a new topic, which will be dictionaries. Now, dictionaries are similar to lists, but they are more of an advanced data structure. A dictionary can have two parts. One of them is called a key, and we have a value. Okay, we have a key and a value. So what could this be? So what do we mean by key and value? Remember, when we used to do lists, we used to do something like that. Let's say we want to put the name and the age of someone in a list. We used to do something like, this is John, this is his name, and then we would put something like maybe 27, and we would close it. Now, as you can see, there is no indication that this is a name and this is an age. We are pre-assuming, and we already know that this data structure, this list, can on the first index it has a name, and on the second index it has an age. How about a way that we can already write in our list, for example, that this is a name and this is an age? This is the main difference between a dictionary and a list. In a dictionary, we have a key and a value. In list, we have only values. Okay, so these here correspond to the value in dictionary. Let me give you an example. Let's say that you want to create a new employee. Okay, you want to add them into the database, but you would add them as dictionaries. So it would be something like that. Name, this is the key, and then there is a value, which is, let's say, John. Okay, then we would say something like age. Of course, all of these are in quotation marks. Age is, let's say, 27. See, right now, I can go to this dictionary and just say, print me the name, or print me the age. Okay, there is a special syntax for that, which we will see in a minute. So by that, we don't have to memorize the index of the name, the index of the age. I won't be really concerned with memorizing the indexes of each of my data and values inside my list. I would only say, print me the key. You know, the name is the key, right? So print me the key which is called name, or print me the key that has a name of age. This is what dictionary is. Let's go and write some code. Alright, now we are ready to write some dictionary code. Let us first define a dictionary, and I'm going to call it here database, DB. Now, to define a dictionary, first thing you want to do is open a curly bracket. And now we will write our keys and our values. Let's start with name. So our first key is going to be name and the value is going to be John. All right, let us continue. Now maybe we will have the age as well. So this is age and let's say maybe 27. Let's maybe have the birth date. And the birth date, let's write it also as a string. Let's say that it is 1st of January, maybe 1996. And okay, by that we have defined what we call a dictionary. Now, let's say that I want to print the name inside this database. Well, I could simply say print db name. Now, if I click on run, you'll see that I got John here. So, unlike list, as I said, you don't really have to memorize the index of your name so that you can display it. Since we were doing something like that, name, or not name, maybe John, and here the age, we would have to remember that, okay, this index 0 is the name, index 1 is the age. We don't have to do that anymore. We would just define a key, which is name, and we would say, hey, print me the name that is in here. Now we know how to print every value of every key. Let us try age, for example. We should get 27, and we got 27. Let's try birth date. And the birth date, here we go, we have it here as well. So far, so good. Now, sometimes we have dictionaries that we get them from different libraries in Python, and we would like to see what keys do they hold. We can print all the keys in a dictionary like that. We would say print db.keys. Now, if I run this, as you can see right here, I'm getting name, age, and birthday. So right now I know all the keys that exist in my dictionary right here. So far, so good. We are still talking about dictionaries. Okay, one of the great uses of dictionaries is that they can contain lists. So if I have a dictionary of names, I could add a key that is called name. Okay. And I could have a list as a value. Okay. So same thing here for age. I could have a list. So right now I could create a small database. This is a small database where I could keep all of my information. I could have multiple names here. Let's say name 1, 2, 3, 4, and each corresponding age is going to be plugged in like that. We can have more information as well. So let's code this small database. So let us quickly code a list inside a dictionary, which is, as I said, is a very, very useful case. And you will see it a lot in tons of codes on the internet or in your job or in anywhere. So let's get started. We have a database and we are going to open a curly bracket like that. And simply I'm going to say name, column, and then I will have a list of multiple names. So I have John, I have Mr. Hamshaw, and I have Kate, let's say. Now, let us add another key, which is the age of each of them. So this will be maybe John is 27, 29, and Kate maybe is 23. Now, if I just print the database as it is, I'm going to get everything that this database has, the keys, the values, everything. Let's say that I want to print all the names that are in here. So again, even though it's a list, it won't really matter. I could just say db name. And as you can see, I got John, Mr. Hamshaw, and Kate all inside the list. Now, what if I want to print a name and the age next to it? So all I need to do is name and then add the index. So I want the first name. So since this is a list, actually, it has the same indexing we have learned before. So this is index 0, index 1, index 2. So same thing now. If I just say db age 0, I would be printing the first age. So right now, index 0, and in all entries, this index 0 will be corresponding to John. So it could be his age, birthday, occupation, place of birth. All of those would have index 0, and index 0 is dedicated for John. Okay, so if I run this, I would get John 27. What I want to talk about right now is how can we add keys and values to my dictionary without actually having to write it. Let's assume that I am starting with an empty dictionary, okay? And throughout the program, I want to be able to add these values. This is very important. Most of the time, dictionaries are added in while the program is running in runtime, okay? So the way to do that is very simple. All you need to do is start with an empty dictionary. Let's delete this line. And then let's add the same entries we had, but dynamically, meaning through runtime. After we hit compile, this will be filled. So all I need to do is do something like db, let's say names, and here I could either put one value or a list or whatever I want. In my case, I just want to put here John and Mr. Hamshaw. Okay, let's say I want to add another pair of keys and values. Okay, so this is my age, let's say, and again 27 and 29. Now, not 7, 9. All right, now if I print my database, you would see that I have filled my database like that. This is how we can actually add elements to my database. Now, this is how I actually can add keys and values to my dictionary. Now, let's say that I did that and I want to add another entry here and another entry here. All right? So the way I did it right now is creating a whole new value to names and a whole new value to age. What if I want to update age and names? Like, let's say you have a program where you have a add button where you can add employees or you can add a product. You would need to click on add, and whatever database you have, you need it to be updated with the new item. Let's say that it is a database of employees and you want to add a new one. You want to be able to click on add and you would have a new name here and you would have a new age right here, right? So the way to do that is by using update. So the way to do that is as follows. You would need to say db dot. You would need to do db. Let's say you want to add a new name. Dot append. Let's say what is our name. Let's say Kate. We want to add Kate. And we want the age of Kate. So we need to append to age. And here the age is, let's say, 23. And let me run this. We got an issue that, okay, it's names, not name. Sorry about that. Let's run again. And here we go. We have Kate and her age. See what happened here? We were able to use append because this is a list. Append is a method that corresponds to list. This is why I was able to append to my list, even though this list is inside the dictionary. It doesn't really matter. All I need to do is refer to which key do I want to append to. In my case, it is the names key. And then since the value of this names key is a list, I can append to it. All right. Assume that I don't have a list here anymore. I have only a single value, like the first example we had. The age is only a single value. Will this append actually work here? Because I told you that append only works with lists. We had a list here as a value that had multiple names, but we deleted it and now we have only one name and only one age. Let's take a look and see what happens if I try to append when we have no list in the value of this key. Run. You will get something like no attribute append because Dictionaries cannot really use the method append unless you have a list right here, because it's not using it on the dictionary. It's using it on the list itself. So how can we actually, let's say, update the value here if we don't have append? Like, I know I will update it with a single value, maybe with the list, but how can I update it at all? Well, I'm gonna remove this and I'm gonna remove this. And append is going to switch to update. Because right now I am updating the whole key and its value. Now, what should I put here? Well, we need to open a curly bracket and we need to say names, and let's say John. All right. Same thing here. We need to do the same thing for age. So here we have age, and it is 27. Okay, now Mr. Hamshaw should be replaced with John, and 29 should be replaced with 27. Let's print this. As you can see, we got it. I know this is maybe a lot of information regarding how to deal with dictionaries, but once you got used to them, they are really powerful data structures that can be really helpful in tons of scenarios. Okay, now how can I change here and go back to a list? Well, I would also use update because I want to remove the single value and change it with a list, right? So whenever you want to change the value here, and write something from scratch, like changing its type from single value to a list, you need to use update. All right, as long as it's not an empty list, only for changing and updating, I mean. All right, so here I could go back and just put this in a list again and just add Mr. Hamshaw one more time. And for the ages, I would also do the same thing, 27 and 29. Now, if I hit on run, as you can see, now we have list one more time. Now I can go back and use my append method one more time. So db names dot append gate. Again, I could append one more time the age of gate. Let's say to be 23. Run again, and we are appending again. How about this? What if I want to delete one of my keys? Now we learned how we can append them, but what about deleting them? Well, we can simply do that by simply saying delete db. Let's say I want to delete the whole names. I don't want this names key nor its values. So I would only say names. Now if I print, I get only the ages. That's good. Let's say that you have a problem here. You had a typo in the key, or maybe the key does not exist yet, because in the runtime, maybe this key will be added later, but you tried to delete it before it's added. All right? So let's give this scenario right here where we don't have names yet. As you know, we are appending names later in the code, but we are trying to delete it before appending anything because my dictionary is actually empty. Now, if I try to run it, I'm going to get key error names, and this could crash our program. This is why we need to be careful here. You need to add a small condition, which is if names in db. Okay. Now, only if this names key is inside this dictionary as a key, then we will be deleting this. Otherwise, no. Now, if I try to run this again, we won't have any runtime errors and the program will execute even though the key does not exist. I still want to talk to you about dictionaries. But this time, I'm going to be talking about how can we delete a list element inside a dictionary. So we've seen before that we had a dictionary that had a key, let's say it has a name, and we had a list of names, name 1, name 2, name 3, name 4. And we have learned how we can actually delete a whole key and just remove it totally. But in most cases, especially when I have lists, what I want to do is I want to delete only a certain element from my names. Let's say that we have a supermarket and a certain product is not used anymore. I mean, we are not actually bringing it in the market or buying it from the supplier anymore because maybe it's discontinued for any reason and I just want to remove it from my database. Well, of course, I'm not going to go and delete the whole names, right? It makes sense that I only delete this small element. But in Python, we need to do some tricks to do that. First of all, let's say that we are using these indexing techniques where we have, let's say, multiple data, let's say price, and item 1 has a price of $2, item 2 has a price of $3, this is for $7, 1, 2, 3, and the last one, let's say it is for $17. All right, so every element actually is connected to a price. Now what I want to do is I want to delete this whole group. Remember, all of these has index 0. All of these have index 1. All of those here index 2. And all of those have index 3. All right, I want to delete one of the indexes. So how can we do that? Well, we would like to get the index of a certain name. This is actually very simple. So the steps are the following. Step 1. Get the name of the element. Name of delete element. Which one do I want to delete? All right. Now, step 2 is to search for the index of that element. Search for element index. So there is a function in Python actually that will bring me the index. 3, delete this index for all keys. So let's say we have 2 keys. I would delete this certain index from my keys. Okay? So first, locate it. Let's say this is tomato. So the name is tomato. Check which index it is using a function because maybe it's not in index 0. It could be in index 100. So the function will go search for this tomato and give you the index of it. Finally, we will apply delete index for all of our keys. Let's see how we can do that in code. Let's say I want to delete John from the database. So I need to delete John and his age. Well, the way to do that is by first locating the name. I want to delete John. So I would say db names dot index John. It means that go to db names, we went to db names, and get me John, this is John, and get me his index. His index is 0. Now I want to store this index here in a variable. Let's call it index. All right. Now we give the name, step 1. We got the index, step 2. And step 3 is to actually delete it from all the keys. So what I'm going to do is delete db names and then index. Now I want to do the same thing actually for my age. Now if I run this, John is not in the list, okay, because here John is a capital letter. All right, let's run. And as you can see now, we have Mr. Hamsho and age. That's really great. Now you might ask, what if I have 100 key? What can I do? Should I write delete key index for every single key? Well, that's not really practical. This is why it's time to learn about iterating dictionaries using loops. Let's do that. So, as I said, I did not like it that I have to give the names in this way. So let us iterate over the keys, read the keys one by one, and then delete that index for every key. So I'm going to delete these for a second, and I'm going to say for key in db.keys. All right. I just want to show you something. Now if I say print key, take a look. I got names and age. So using this for key in db keys, which is a small method we use on dictionaries, which will extract all the keys for us and store them in every iteration inside this key. Well, by doing that, we can sweep the keys and do whatever we want for every key, right? If we have 100, if we have a 50, we don't even have to memorize what is the name of every key. All we need to do is just put key and delete that specific index, okay? Let's say in case of deletion. Now, all I need to do is the following: delete db key index. Does this make sense? Key is changing and sweeping all the keys. In the first iteration, key is names. Second iteration, it is age. And we are deleting that specific index, which is 0. So we are deleting John, his age, and whatever information we have in our database regarding John, because we have his index. Let's run it. But first, let's print it at the end. Run this. And we're good. John is gone from our database without actually having to know any of the keys. Now, for example, let's say that you would like to see the values of your database. Okay, so let's make it here. Let me comment this for a second. This is comment. It means it won't be used in the code anymore. All right, but it's there. We can read it, but the interpreter cannot read it. Okay, so let's say here for value in db dot values, and if I print value, look what's gonna happen. Okay, let me remove this, try again. Okay, as you can see right now, by doing that, we are printing all the values inside my dictionary. As you can see, I'm not printing the keys, I'm not printing names, and I'm not printing age. I'm only printing every value individually. Okay, now let's try something else. What if I wanna break these down into individual values? Right now I am printing them as lists, right? What if I wanna print it just like here, like names, like age, individually, not inside the list? Maybe I wanna, because I wanna use it somewhere. I cannot use it if it's inside the list. So to do that, we could do the following: for subvalue in value, and let's print subvalue. Run this. As you can see now, I have them individually. What did I do here? We have talked about iterations in lists, right? And iteration in list, we used to have a keyword and we just loop inside the list. This is exactly what we have here. Now, value here is saving every list individually. This is one loop. Then I'm taking every list and I am breaking it down to its individual elements and printing just that individual element. So I'm going to visualize these two loops for you in a second. Take a look. I had a for loop that is looping my list, right? So I was saying for value in values, right? I was also saying for sub value in value. Of course, here we have a DB. Okay, so first of all, I was bringing every value I had in my dictionary. So I had here John and Mr. Hamshaw. And I had ages 27 and 29. Look, in the first loop, I am getting the values of my dictionary, right? Those are the values. This whole thing right here, all of it, this is a value in a dictionary, right? So right now, this value here in the first iteration, let's say iteration 1, value is equal to John and Mr. Hamshaw in the first iteration, right? We are still in the first iteration for this for loop. Now we are opening a new for loop and we are saying for sub value, so create a new variable called sub value and iterate over whatever we have in value. What do we have in value? We have John and we have Mr. Hamshaw. So right now, in the first iteration of this for loop, sub value is going to take the values one by one. So it's John. See? Now, remember, this for loop right here is still in the first iteration. Now, this for loop is going to finish all its iterations. Then we are going to go back to this for loop, right? Because how for loop works is that everything inside the for loop will finish, then we will increment. But what if we have two for loops? Well, the inner for loop needs to finish before we go back and this for loop continues. So this is the first iteration. We are printing John. Now in the second iteration, sub value, what is the next iteration? What's the next thing in value here? It is Mr. Hamshaw. It's going to equal to Mr. Hamshaw, right? So we are printing this and we are printing this. Now, let's go back. Now let's go to the second iteration of our big for loop. What's going to happen here? We are saying for value in the dictionary values. Well, we took this one. This is the first value. Now, second iteration, we're going to take this as a second value. So right now, value is equal to 27 and 28. Right? Now we are going to continue and we will jump back to this for loop. Now we'll go back again and say first iteration sub value is going to equal to, what is it going to equal to in my case right here? It is the first element because this is the first iteration, it's 27. And in the second iteration, this sub value will equal to 29. So we are printing 27 and 29. See how the cascaded for loops work? Big for loop, small for loop. First iteration in the big for loop will start. All the iterations of the second for loop need to finish. Then we go back. Second iteration of the big for loop. Then again, all the iterations for the second for loop will continue. Okay? And right here, the big for loop is passing the new values to the small for loop, right? Because this value is changing here for every iteration. In turn, this one will change as well because this is linked to it. This is value and this is value. And this is why we printed John, Mr. Hamshaw, 27 and 29 in this order. Alright, so right now we are going to talk about Jupyter Notebook. Jupyter Notebook is an IDE that is used to program Python. So far we have been using Spider, but there is some advantages to move to stuff like Jupyter Notebook because Jupyter Notebook provides a good way to visualize your data while you are programming. And it also gives you the ability to write your code in multiple cells and then run them individually, which is very useful in some scenarios. So this is how it looks like. Now we are going to see how we can open a new Jupyter Notebook. First off, let's go to some directory that we would like to store our Jupyter Notebook in. So let's say I want this directory. You just need to go to it and just copy it. Next, you need to open Anaconda prompt. Just open the Anaconda prompt like this, and you'll be right here. Now, all you need to do is to navigate to that directory right here in order to store our Jupyter Notebook in. So now, the first thing you need to do is to change your directory from C to D. Now, if the directory you have in mind is already in C, you don't need to do this step. So I need to change this to D. All I need to do is just type D and column. And now I am in D and in this directory. Okay. Now let's say that it did not automatically take you to that directory. What can you do? All you need to do is just type CD. It's a shortcut for change directory, and just click on the right mouse click because you have already, okay, I clicked twice here. Yeah, because you have already copied it from the path right here. So when you just right click in the mouse, you'll be pasting it in the command line. Now, if I hit enter, now this is my directory. Now, all I need to do is just type Jupyter Notebook. And this will open like this, and we will be getting a new Jupyter Notebook. Now, this is the list of all the files I have in that directory. What I need is a Jupyter Notebook. So these files that, let's say, I have in my directory, let's take a look. Right here, it's a .py. And Jupyter Notebook has also its own format. So if I click on New, I can create a new Python 3 IP kernel. And it opened. Now, if I want to download this, I can download it in multiple formats. One of them is the IPYNB, which is the notebook format, or I can download it as a PY. Download it and save it, of course. Okay. So it's important to know that there are two types of Python files. When we are working with Jupyter Notebook, we can work with IPYNB and with .py. The differences in between them is that this one is formatted to cells. So if you try to open this in Spider, you will get those cells as comments in order to keep this Jupyter Notebook format. Okay, so now in the upcoming sections, we will be using Jupyter Notebook, and we will see how powerful it is in visualizing data. Alright, so what I'm going to be doing right now is actually to learn some shortcuts when we are using Jupyter Notebook. First, we will be starting with one cell. Now, let's say I would like to have all my libraries and all my imports in one cell and my code in another cell. I could do this simply by saying here, let's say import the library called OS. Okay. Now, let's say I want to move to a new cell without executing this. All I need to do is to just hit right here on this area of the cell and just click on B. By that, I have created a new cell. If you're not sure of the shortcuts, you can just go to Insert and you will see the shortcut in order to create a new cell. It's important to hit on the left of the cell, not inside it, in order to be able to activate the shortcuts. Okay, let's say here that I would like to print hi. Okay, so now I have two cells and I can run them individually. Let's say I just want to run the import cell. All I need to do is just hit on Shift Enter. And by that, I have run this. Now it is imported. Now let's say I want to print the hi. So I need also to press here Shift Enter and I will be printing hi. So it helps us to divide our code into small sections and just run them individually. You might ask, why is this important? Especially when you are prototyping, sometimes you don't want to rerun the whole code. You would like to keep some certain aspects of the code. You might need to only run a specific chunk of code that is independent. Sometimes you only need to run a small chunk of code, and this would be really helpful by using the cells. Now, let's say that I would like to delete this empty cell. What could I do? Well, just click on the cell on the left and double click D, and it's gone. Okay? Now, let's say I would like to insert a new cell above this one. Go to Insert, check the shortcuts. Insert cell above is by pressing A. So just click here and press A and you have a new cell. Let's delete it, double D, and we're done. As I said, if you forgot what you need to press, all you need to do is just press these tabs here, the cell and the insert, to see the shortcuts for inserting and for running the cells. Okay. Now, let's say you're done and you would like to download this Jupyter notebook. Just click on File, Download As, and if you want to open it again in Jupyter Notebook, I prefer that you save it as a notebook like this. It will be downloaded to the directory you have already set in your CMD, as you have seen in the previous tutorial. Okay? You can also download it as a Python file, and there are multiple other extensions that you could use right here.
At this stage, you are not a beginner programmer anymore. Now you are in the intermediate level, meaning that everything you will learn from this point on will be more challenging and exciting. Right now, you will be separated from an absolute beginner programmer, so congratulations. This section is all about preventing your program from crashing, meaning that you will do your best to catch any errors before they happen and ruin the user experience of the software that you have designed. This section is called exceptions, and no company will ever hire you without knowing how to integrate those concepts into their software, because they are key to smooth user experience. So let's get started.
Hello guys and welcome back. In this section, we are going to be talking about exceptions. Now, exceptions are used whenever we have a large error that will cause our program to crash. Okay? Let me give you a very simplified example. If I am to create a variable that equals 0 and to create a variable here that equals 2. Now, let's say that I would like to say C is equal to A plus B. Okay, and then I would like to print C. If I do that, I would get a result of 2. Now imagine changing the operation here to B divided by A. Dividing a number by 0 is an undefined operation, and it causes your program to crash if you try to execute it. Assume that you have a large program and it encounters a case where it has to divide two numbers, and for some unexpected reason, this number became 0 for some reason. Now the program is going to crash and it's going to exit. This is not a really good practice. Whenever you have division operations, you always want to check for situations where you are dividing by 0. Once you check for a situation where you are dividing by 0, you can actually prevent it. This is the role of exception. Now, let us try to solve this issue here in this line. What we could do is use a statement which is called try and except. Try and except. Okay? Try will try to do something to see if we are going to get a crashing error. Okay? It could be a file that is not found. It could be a path that is not found. It could be creating a folder using Python where the folder is already exist. All of these situations, which we will see while we are progressing in this course, all of this situation will cause your program to crash. So this is why all those sensitive statements, you just put them in a try block. Now, let's say here C is equal B divided by A. It's going to try to do this operation. However, if we get any crashing reason, we are going to go to the except block. Okay? In this case, we are going to say print, this is not possible. And then I would like the program to continue. Okay? Let's say that here the program is doing C is equal B times B, print C. It's doing stuff. Okay? Now, if I am to execute this, I'm going to see here that this is not possible. Okay? And the program continues to execute without any issue. So always whenever I have a crashing issue, I can prevent it or even fix it somehow and then continue executing. Now, let's say here that I have other operations, the same ones, and I try to execute them here, I will be stuck at this statement here. And the program will not progress and it will crash. But here we are catching, this is called catching. We are catching this exception and then we are continuing as usual. So this is the whole intuition behind try except. In Python, there are exception types. Right now, what we have catched here is called zero division error exception. In order to distinguish it between different exceptions, like let's say name error, we need to specify this right here. So we need to say zero division error. Okay? Why I am specifying this? Because there are other types of exceptions as well. Let's say, just for example, that here I am trying to divide C is equal B divided by X, and X is not defined anywhere. This is called a name error because the variable is not defined. You might ask, where would I be in a situation where I won't be defining a variable and using it? There is tons of examples, especially when you are working with more complex structure like object-oriented programming. Sometimes you want to create an object or a variable, you can think about it like that, only in a certain cases. So if these certain cases are not met, this variable won't be created. And sometimes in your code, you might want to use that is not yet created. And in these cases, you would like to catch these issues by catching name error. We will demonstrate name error later, but for now, let's talk about this zero division error. Now we have specified that I would like to catch this zero division error specifically, okay? So if I execute this, we catched it in except. Zero division error was catched, and here this is not possible is catched. Now assume that I said here I want to catch name error. And I execute this. As you can see, we did not catch division by zero because here we were only trying to catch if we are dividing by zero. Okay? So it's really important as much as possible that you specify exactly what you are trying to catch. Okay? Now, if you go to the Python documentation and type exceptions, let's do that together. Let's say Python exceptions list, for example, and we go into built-in exceptions. We go all the way down here. We will see all types of exceptions that Python supports, and there is a lot of them. There is one of them that's called file exist error. When we will be talking about OS library, we will be using these exceptions. When we try to create a folder, for example, and this folder already exists or this file already exists, we are going to get exceptions like those. File does not exist, file not found, file exist error, file not found error. I mean, you can read those and actually see what does Python support. Now let's talk about the name error. Let's say that we have here a is equal to 10, b is equal to 2, and then I try to say c is equal to a divided by x. Okay, now naturally when I execute this, I'm gonna say, hey, name x is not defined. Now simply if I say try, and then here I say except, and then I say name error, okay, and print variable is not yet created, you'll see that I'm not crashing anymore. We can continue here the program. Let's say c equals b times b, print c. The program will continue as expected. So now it goes on like that. It's all the same. You type what type of exception you want to catch, and you catch it. Or you can just try to catch a general exception. This works as well. But it's important to know the type. Why am I emphasizing the type? Because you want to know how to handle this exception, right? Let's say here that you know that you are dividing by 0. Maybe in this case, all you need to do is jump with the program to a different place, right? Like instead of dividing b divided by a, you can just bring another variable that you would like to divide in such cases, right? Because of course in the logic of your program, of your software, you already know what is the second case if this case does not work, right? Maybe you would like to initialize a with 1 in that case. So let's say here, except division equals 0, you would say a is equals 1. Then here you would say something like c is equal to b divided by a. And then you would like to print c. So if we continue and remove this statement, for example, you'll see that now the program continue executing with a different a value. Okay, of course we need to execute this first. Of course we need to specify here initially that a is equal to 0 and b is equal to 2. Now if I execute it, you'll see that we got this is not possible and we found a different way to execute it. This is why I'm telling you, you need to know the exception type to know how to handle it. Let's say here, if the variable does not exist, maybe you would like to jump with the program to a different place. Maybe you would like to bring in a different variable, like let's say I is equal to 3. And here you would say, hey, in this case, if x is not yet created, I would like to say c is equal to a divided by I. Okay? And then you would like to just continue. And you continued with the program, but with a different branching. Now we are going to learn how to use the else keyword with exception. Okay? I'm going to copy this whole program one more time and just put it here. Right now, we are checking if the variable exists. If the variable does not exist, I would like to divide it by I. However, assume that the variable already exists and I did not go to except. Alright? I would say else I would like to do something. X is equal to 100. Okay? And here I would like to print X later. Alright? Now if we try to execute this program, we will be getting an exception that variable is not yet created. Okay? Now assume that I already have x, so x is equal to 5. Alright? Now I would like to try to divide this c a by x, it will be successful, and then I would like to assign x to be 100. So if I execute this, I will get 100. What I'm saying here is try will try to execute. Alright? If it's successful, it means the else need to be executed. If try is not successful, except will be executed. See that? Again, try to execute this. If it works, jump to else and execute it. Otherwise, just execute this statement. This is how except else works. What you can do here, maybe you are trying to create a folder, and here you're saying, hey, try to create this folder for me. If this folder exists, then just don't create it. You don't have to. Otherwise, if the folder does not exist, I would like you to put bunch of files inside that certain folder. Okay? This is how we use it. Now, I'm going to copy this whole program again, put it here. There is a keyword that is called finally. Alright? This finally will be executed regardless if you execute it except or else. It's like a compulsory block that will be executed no matter what. So here I'm going to be printing print I will be executed no matter what. Now if I execute this program, you'll see that X was already there, so we went to else and then we jumped to finally. Let's say that X does not exist and I try to execute it. We need to reset this program because Jupyter Notebook actually stores variables, so you need to reset it. And then try to execute this one more time. You'll see here that we executed except. Variable is not yet created, and we executed the finally block. Alright? So again, this is when we are working with folder management, this could be very useful. Let me give you a pseudocode about that. Because we did not yet dig into folder management, I would like to give you a pseudocode example. Let's say here that I wanna create a folder that contains 5 files. Alright? Now there is a chance that this folder is already created, alright, by a previous program run. Alright, let's assume that this program can run multiple times. Alright? So you run it the first time, you create that folder, you put the files in. Now you are trying to run the program one more time. Well, the folder is already there. What's gonna happen? This is what we're gonna do. Try. Now, I'm gonna just use print here. I am trying to create a folder. Alright? Then here I'm gonna say except, I'm gonna print folder does exist, cannot be created. In this case, I could jump to finally and just say print folder created successfully. Alright? Because we already have the folder and it's already created. Now, if the folder does not exist, I'm going to say else print put 5 files in that folder. Okay? And this is how we create a folder. And this is it. This is how we could be use this logic with directory and files management. We are trying to create a folder. We cannot really come here directly and try to put all the 5 files. Because first I want to make sure that the folder does not exist. If it does exist, I'm done. I'm going to just jump to finally. Alright? If it does not exist, it means that here it will be already created. And then I'm ready to put all the 5 files in. And then I can print folder here. Folder created successfully. Now if I run this, you'll see that I'm trying to create a folder. Then folder does not exist. Put 5 files in that folder. Folder created successfully. Okay? This sums up how we can use try except else finally in a practical way. If you notice here, we are not printing the type of the exception. We are only printing the type of exception when we have already crashed. Like here it says 0 division error. But let's say here, if I remove this and just say except, I won't really know what is the type of error that I have. I am only printing this is not possible. How can I actually print what is the actual exception that I am getting without actually crashing the program. Now the way to do that is as follows. Let's take this example. We are trying to divide by A. I am removing this exception 0. And I'm going to say exception as E. I'm going to reset my environment. Now simply if I print E, I will get the type of exception I'm having without actually crashing. Sometimes this is useful if you want to halt your program and actually print in a pop-up message maybe, why are we crashing, and then closing the program, but you are closing it on your own terms. Like, let's say you have a GUI, which we'll be talking about later, like a windowed type of program, and then you try to divide by 0. Let's say that you don't want to do anything because you cannot do anything, and you should crash. At least you will be sending a pop-up to the user saying that you are dividing by 0, sorry, we will be crashing. And then you crash the program. Instead of the Python code actually crashing on its own, not generating any errors to the user and just disappearing, right? So sometimes it's important to get the name of the exception just to show it, right? Like right here. Let's say that I am dividing by x. You'll see that name x is not defined. Alright? You could show this to the user, for example. Let's assume that we have a case where multiple exceptions can happen at the same time. Okay? Let's go back to our very simplified example. Let's say a is equal to 0, b is equal to 5. Alright? Let's try to divide them. C is equal to b divided by a. So far we have no problem. Let's say that I would like to catch if a does not exist. Let's say that there is a possibility of division by 0, but at the same time there is a possibility that a is not really defined. Then how should we take this priority? How should we arrange it? We can actually type multiple exceptions under each other. So here I could say except. What do you think is a priority here? The variable does not exist or division by 0. Of course, if a variable does not exist, I cannot in the first place assume that it is 0 and divide it, right? So priority here is name error. I want to make sure that my variable does exist. I'm going to print here variable does not exist. And then I'm going to say print creating variable maybe. And then I will say a is equal to 0, a is equal to 1 maybe, and then I will say c is equal to b divided by a. All right? This is the first one. Next, let's say that for some reason a is still 0. So here I'm going to say except 0 division error. We're going to print cannot be divided by 0. Then let's print that we are correcting this, adjusting value. And then we are going to say a is equal to 1 and c is equal to b divided by a. All right? Let's say that maybe the error here, the error here cannot be known for any reason. Then we would like to close the whole program in a friendly way. So I would say here except exception as e and then just print e and then just print sorry, but an error occurred, and then we will say exiting. All right, now let's put an else here and just print C. Like that. This should be okay. So first we make sure that A is defined, then we make sure that A is not 0, then we make sure that there isn't any other errors, then we print C. Let's execute this. As you can see here, we said cannot be divided by 0, adjusting value. Alright? This is correct because A is 0. Let's say that A is not created. You need to reset Jupyter Notebook and try to run again. You'll see that variable does not exist, creating variable. That's good. Now let's say A is a string equaling 0. Let's see what could happen. As you can see, now we caught an error that we did not actually take account of, which is that A is a string and here it is an unsupported operand type integer and string. So we will be saying sorry, but an error occurred, exiting. So this is how we prioritize our exceptions according to the situation. So try except need a little bit of thinking before coding. It totally depends on the problem you are trying to solve, on the way you are coding. So you really need to think it through. And this is one of the first things that actually testing engineers try to do when they are testing your software. Usually developers will be writing code and testers will try to crash it. So in order to create a solid software, you always need to make use of the try except blocks. Otherwise, the testers can break your code and then they will give it back to you to fix it because they found bugs in it. Here, this is what bugs is actually. When you have an unexpected behavior in your code and you did not really think about handling it. Okay, now let's get a little bit more advanced in exceptions. Sometimes we would like to create our own exceptions to use them in our program. The way to do that is by utilizing a little bit of object-oriented programming, which we have talked about in previous sections. And when we are working with customized exceptions, we would need to raise the exception ourselves because Python is not actually programmed to be giving you to raise exceptions that are not built in, right? Because you just added this exception and you need to tell the program that, hey, this case is an exception, so please don't crash it and just generate an exception. Now, let me clarify what I'm talking about in few codes of line. First, let's create a customized exception. I'm going to say here class and call it whatever you want. Let's say customized or just custom exception. All right? Now, this needs to inherit from the class exception built in Python. So all you need to do is just pass exception. Okay? And say pass here. You don't want to do anything with this class. All right? So now you have a class built in Python called exception, and you are using this customized exception to inherit this base class. Okay. This is the first step. Now it's time to implement your actual exceptions. We're going to say here class. What kind of exception would we like to do? Let's say if a certain element does not exist in a list, I would like to raise an exception. Let's say that my use case requires such an exception. I'm going to say here element does not exist. This is the name of my exception. All I need to do now is pass the name of my class here, okay? Meaning inheriting from it, which is actually inheriting from exception. But I would like to create a class of my own that I would like to inherit from, okay? You could actually here write directly exception. That's totally okay. But what I would like to do is to create a class of my own, all right? So this is the first exception. We're done. All you need to say here is pass. Again, let's create another one. Let's create an exception when my first element is smaller than my second element. Okay? So I'm going to say here first element is smaller than second. All right? And again, we will be inheriting from our customized exception and just say pass. What did I do here? I created two exceptions of my own. That's it. This is how we do it. Now let's use them. Let's say that I have a list that equals 1, 2, 3, 4, 5. Okay? And I want to raise an exception if number 3 is not in it. So I'm going to say here try if not 3 in L, meaning check L. If 3 is not in it, I would like to raise an exception. I'm going to say here raise. This is the keyword. You need to trigger the exception yourself. Now you raise it. Which one? Element does not exist, meaning we are triggering this exception. Now, after you raise it, you need to catch it. How do we catch it? Like we catch any other exception. We say except and put the name of this one here in order to take an action. Let's say the action here is only a print statement that is saying element does not exist, raising an exception. All right, let me recap. We created an exception if an element does not exist. We have a list. We use it try except. We are trying if this element does not exist. Since this is not a built-in exception and we have created it ourselves, we need to raise it. Okay, after we raise it, we catch it, and we do whatever we want as a handling. Let's try this. Initially, we're not printing anything. So let's put an else here maybe and say success element exists. And as you can see, success element exists. Now let's remove number 3 from the list. You'll see that we write an exception saying element does not exist, raising an exception. So this is a customized exception. That's good. Now, how about we check if the first element is less than the second element? So here, we're saying if not 3, raise an exception. We can continue. We can say ELIF L0 is less than L1, then I would like to raise another exception, which is this one. I'm going to say here raise this exception. And what do we do after rising? We catch it. So we'll say except. This is the exception name. Print first element is smaller, rising and okay. Now let's execute this. You'll see that we tried the first one and we accepted, so we just said, hey, element does not exist. There is no need to execute the second one. Now let's say that 3 is there. We will see that we raised this exception because first element is smaller than the second element. And, well, we did not print the succession. We did not print the successful operation message. Okay, so this covers all the important aspects about exceptions.
This very small section will walk you through some Python built-in functions. You'll see those function a lot when you are reading professional code written by professional developers. The Lambda function, for example, is similar to a regular function, but you don't really have to define them outside of the main. They are just defined on the fly, maybe inside a loop. So let's have a look.
Okay, so now I will be talking about something called Lambda Functions. We have talked about functions before, but what is a Lambda function? Well, usually we would define a function like this. We would say def, let's say the function is called x, and then we will be passing some parameters to it. And then here we have some logic, right? And maybe a return value. So this is what a usual normal function is. Now a lambda function can be initialized as follows. You would say lambda, and then you need to give an argument or the parameter, and then you would give the expression. Okay, so what does this mean? Argument correspond to the parameters here we are passing to the function, and an expression is actually whatever we write right here. We don't need to do the diff, we can create this within our program, our main program maybe. What do I mean by that? Let us take an example. If I simply create a variable here called x, and let's say that x will be holding a lambda function. So here I would be saying lambda, as we said, we need lambda, argument, and expression. Okay, let's say we are passing x to this lambda function. Now it's time to say the expression. What would we like to do with this x? Well, maybe I want to return x divided by 10. Okay. Now simply if I say print x 100 or 50. Okay. Now if I run this, you'll see that I got 5. So this is a lambda expression. The equivalent way to do that is just by saying, hey, define, let's say, xx instead of x. And here we will be passing a parameter to it, and then we will be saying return parameter divided by 10. Okay, so now if I pass xx here, I will be getting the same result. So this is a normal function, and this is a lambda function. You might ask, why is this useful? It will be useful when we are talking about maps, when we are talking about filters, sometimes in list comprehensions. We will be taking some examples that you would see around when you are reading Python code. Because lambda is one of the important features in Python, and it's important to learn it. So let's dig into some more realistic examples. Okay, so right now we will be talking about maps and filters, which come hand in hand with lambda functions. So this lecture is about lambda, filters or filter function, and map function. All right, we have talked about lambda. Now what is filter? Filter is actually a function that takes the following. It takes a function as an argument, and it takes a list. And it is going to filter this list according to some criteria and according to the rules of the functions we are providing. What do I mean by that? Usually, let's say that you have a list and it contains characters. Some of them are empty and some of them contains letters maybe. And let's say you would like to get rid of all the empty entries right here. See, this is an empty string that we don't need. And this happens a lot actually when you work with text processing. So how would we filter this? We could use for loops, right, to iterate over this list, check if there's an empty entry in the list. This could be done, but we can do this actually in a way more simple way using lambda and filters. So since filter takes a function, it only makes sense to use lambda function instead of writing a separate function, right? So maybe we would write a rule like lambda, and we pass an argument to it, and we say x does not equal to an empty list, okay? We've talked about lambda, that it takes an argument and an expression, right? So we're saying here that, hey, I have a lambda expression, and any entry in this list should not be empty, right? Now, let's say this list is maybe called L. So here I would be passing L. And this will be my filter function. As you can see, it took a function and it took a list. Now this is for filter. What about map? Well, map takes the same thing. It takes a function and it takes a list. And it only makes sense that this function would be a lambda, right? Now map will work on all the elements of your list. See, right here, we were only working on the elements that meets a certain condition, right? So we are filtering out some elements, we are throwing out some elements, we are keeping in some elements depending on this condition. But with map, we will be working on all the elements equally. So what do I mean by that? Let's say that I have a list that is equal to numbers 2, 4, 6 maybe. And let's say that I will write a lambda expression that will multiply everything by 2. Okay, just as an example. So this will be x times 2. Okay, this is my expression. Now I can pass a list here, which is my L, and I can say, hey, map. So we will be iterating over all the elements and multiplying them by 2 according to my lambda function right here. See? There is tons of applications for maps and filters, which when you are implementing your project, it will only make sense that you replace your for loops with those functions. So we have talked about list comprehension before, which was compressing a for loop if you want to work with lists. Same thing for maps. It is about mapping. If you have a certain array, you can change the whole elements of that array using a lambda function without using for loops. We have talked about filters, which is about filtering out your list according to a certain condition without resolving to for loops. So let us code some examples now. All right, let us now code some filters. I'm going to create a list of letters, let's say A, B, C, and I will be having some empty strings. Okay, just like this. Let's use filters. So I'm going to say here, filtered list is equal to, what we want to do is call the function filter, and let's have a lambda x, we will pass it an x parameter, and we are going to say x, so we are going to append to that filtered list all the elements of L only when x does not equal to an empty string. Okay, now remember, filter takes a function, which is the lambda function, and it takes a list to filter it. So it is the L. Now let's try to print filtered list, and let's run it. We will see that we got filter object. Why did we get that? Well, because what filter returns here is just the address. If you want to convert this to a list, you need to encapsulate it in and cast it into a list. Okay? So right now, after we cast it and we print, we will see that we got ABC without all the spaces. So this is how a lambda function works. Now, let us append the letter, let's say maybe x, to all the entries of this list. If we want to modify everything in a list, we use map function. So we're going to say append list. This is my new list. It will be map, and again lambda. We will pass it an x parameter, and we will say x plus, let's append the letter D. Okay, let's not append x, let's append D. And then we need to pass it a list, which is L. Now let us print this append list. And again, we will be getting map object at a certain address. So again, we need to cast this to a list and print. You'll see that now all the entries of the list are appended the D letter. All right. So this is how map and filter works. And as I said, whenever you are programming in Python, you're going to have scenarios where you will be using for loops. So try to think about it. Can you make a shortcut by converting it to a filter, to a map, or to a list comprehension? Always take these into consideration, because this is the Pythonic way of using for loops, Okay, and the regular for loops are not really the Pythonic way. Sometimes it's important to use for loops in some scenarios, but sometimes we can really take a shortcut and resolve to these techniques that we have learned.
This section is the key to professional coding. Any library that you see around Python is definitely using the concepts that are called object-oriented programming. Your code will be treated like an object that has its own variables and functions that nobody but this certain object can use. Does this sound complicated? Well, it's not really that complicated because I'm going to be breaking those information into very small chunks that you can comprehend. And please don't hesitate asking me any questions in the Q&A section if there is something that you don't get. I will be more than happy to help you through it.
Now we are going to talk about a new topic, which is object-oriented and programming. What's this? Sometimes you will see it called OOP. This is a really exciting topic, and it really makes your code clean. It shows a professionalism, and it shows extendability of your code, and it shows that you know what you are really doing, because all companies out there, when they're writing a large code, they would be using techniques with object-oriented programming. Okay, so I'm gonna try to simplify this to you as much as possible. Let's assume that we have a very small motor, just a motor. And as you know, this motor could be for a car, this motor could be actually for a washing machine, it could be for a refrigerator, it could be for a blender, for anything. Now, a motor can either rotate clockwise or anti-clockwise, alright? And this motor has something to control its speed, okay? So you can easily change the speed of this motor and raise it up, okay? So this is the speed, this is time. You can just simply increase the speed. As you can see, it's going up of this motor. So this is motor control. So what are the main functions we collected right now for this motor? 1, turn it on. 2, turn it off. 3, rotate clockwise, which is part of the on as well, right? And 4, rotate anti-clockwise. And number 5 is change speed. Okay, so we have 5 functions. What does this even have to do with object-oriented programming? I'm gonna tell you in a second. Let me give you a clean page. Now we are going to create something called the class. This class has 2 main things. One of them is called property, and it's just a fancy name for a variable. Don't get too confused. Next is methods. And just so that you don't get confused, these functions. Okay? So it has its own functions and its own variables. So let's say we have a class called motor. This motor can have properties like on button. It could have something like an off button. It could have something like switch direction button. And maybe it has a function to change speed or a method. Because maybe changing the speed needs to be a little bit special, right? Okay, so right now we have this class for our motor. This is a generic class. Now let's say that I have multiple motors I'm trying to control from my program. Okay, as simple as that. Let's say I have a washing machine motor. Let's say that I have a mixer, a blender motor. And let's say that I have a fan motor, something simple. Okay, now instead of writing the functionality of every single one of these and calling functions and creating multiple variables, now this class is like a type. You know how we have types like lists and dictionaries? Well, we can have types with classes. So we're going to say motor, like create me a new motor, and this motor is going to be a mixer motor. And create me another motor, and this time this is a fan motor. Okay, and let's say I want to turn on the mixer. Okay, if I want to turn on a mixer, all I need to say is now mixer motor dot on button for example equals true, and I'm done. I did not define any on buttons. I did not define any extra off buttons. Let's say I want to turn on the fan motor. All I need to say is fan motor dot on button equals true. That's it. See how simple is that? Now I don't need to write multiple variables. I don't need to do anything. I just define one object. By the way, this is called object. You know we were saying object-oriented programming. This right here is an object. This is an object from the class that is called motor. Okay, so this is object-oriented programming. I have summarized to you now the most important aspects of object-oriented programming, which is classes and objects, and methods, which are functions again, and properties, which are variables. Now let's go and implement it in a code. Alright, now we are ready to start with object-oriented programming. So as I mentioned, we need to create something called a class, and this class is going to be called motor. Now we need to define something called constructor. Okay, so this constructor can help us initialize this class. We'll talk about that in a minute. So the way to do that is by saying diff double underscore init double underscore. Initially, I'm gonna leave it empty. So if I just type pass, it means that I have a constructor, but it won't do anything. I'm gonna leave it as like that. Now, as I said, we're going to have multiple functions. One of them is called turn on. What will this do? It will turn on the motor. Also, I'm going to leave initially everything empty. Okay. So initially, I just need to print something like motor is on, just to debug. I'm not going to do any functionality yet. Next, def turn off. Again, I'm just gonna be printing motor is off. Okay. Now I know in the examples I did not create those turn on and turn off functions when I was explaining, and I created them as a variable. Actually, we will be creating a variable for the status of on off, but the one that will do the on and off are functions or methods, as they are called in object-oriented programming. Next is the speed. So we have change speed, and simply speed changed. And finally, change direction. Change rotation direction. And again, we're going to say print direction changed. Okay, so this is how we create a very simple class. Now, if I try and compile this, nothing will happen. Now, let us create a new fan motor. I'm going to say fan is equal to motor. Now, fan is an object from the class motor, and it has all its properties. So simply, if I say fan dot turn on, like that, and I hit on run, I would get a type error at the init. Well, there is the thing that I want you to understand about classes. Every class needs to be passed something called self. So even though you're not intending to pass anything to this function or methods around here, you need to pass self to them, like that. Now, passing self, it is, in a simple words, it's like making all of these functions shareable with this class motor. So right now, through this definition init, you can access any of those functions. Through the turn on function, you can access any of those other functions. Now, those are not regular functions. I mean, if, for example, let me remove this for a second. If I say turn on like that, and I hit on run, I'm going to get that there is no function called turn on because these functions are only defined in the scope of this class. So in the main function right here, there is no access to them unless you do the following, unless you create an object from that class, and then you can call these functions with respect to that object only. This is why self makes all of these functions instances from this class motor. In simple words, all of these functions can see this class and can see each other once you pass this self. And in the Python syntax, you must pass these self keywords to all your methods. Okay, now if we try again, we can see that no errors and we got motor is turned on. That's really great. This is exactly what we are looking for. Now, let's say that I have a new device, a new motor, maybe a washing machine. And all I need to do to create the motor for that washing machine is just say motor. That's it. I don't need to create extra functions, variables, nothing. Now, again, I just say, let's say washing machine. I think we have a typo here. Let's say dot change speed, for example. Now, if I just hit on run, nothing will happen because I forgot the parentheses. Now let's try again. Speed is changed, and this speed changed for this washing machine. Now, this is really a dull class. We did not create any functionality yet, but I just wanted to make a proof of concept about how classes and objects like fans and washing machine works. Okay, so now let's try to write the functionality of every method in our class. But first, let's delete these two lines. All right. Now, we had 4 buttons. One of them to turn the motor on, the other is off, one to change the speed, and one to change the direction. Now, we are going to pass all of these in the initialization function. Okay? All the variables that you need to use need to be passed here in the initialization function. So we're going to do something like that. Start button, stop button, change direction, and change speed. Okay. Now, where are we going to pass these variables? We need to pass them to be class variables. To do that, we need to define new variables. So we're going to say self because as functions need self, variables also need the self keyword. So we'll say self dot. Usually we give the class variables the same name we are passing into the initialization, but we add an underscore. So in our case, we are creating a class variable that is called underscore start button. Now again, we add the underscore to distinguish a regular variable from a class variable. Now this will equal to start button. Let's continue. Now self underscore what's my next variable? It's a stop button. And also remember, all of these are going to be only values. Those are not variables that will be used in the class. They will only be values that we will pass in order to initialize the class variables. Okay, it's like I'm creating a class variable called start button, and I'm giving it an initial value of 0, meaning the start button is still in the off position. Okay, so those are only values, and those are the real class variable. Let's continue. We have a stop button. Then again, self, and we have change direction is equals to change direction. And finally, we have change speed. Again, self dot underscore change speed and change speed. Okay, so far so good. Now the modification we're going to do right now is in this object definition. We are going to say here 0, 0, 0, 0, meaning that start button is at 0, stop button is at 0, change direction, we are not requesting any change direction, also for the change speed, everything is 0 right now. Now, we can make sure that all of these variables are actually 0 by accessing them. Let's remove this method for a second and just say fan dot. Now, we use the dot in order to access either methods or the class variables. So we're going to say fan dot underscore start button, for example. Okay, now let's print this, run, and we will see that the value of it is 0. So this variable right now has a value of 0. We can do this for any of those class variables. Now let's try to write the functionality of turn on. So in order to do that, all we need to do is when we call turn on, I want my start button to be activated. So in this case, I'm going to do the following. Self dot start button is equal to true. See, we're using self to access this variable. If I don't use self here and I forget it, it would be like creating a local variable only inside this function that is called start button. So once this start button is done executing, it will delete this variable, and the value here will not be affected, and that's not really what we want. Okay, so we need the self keyword. Now let's try it out here. So I'm gonna say fan dot turn on, and now we will check again the start button value. Let's check it before and after we call the turn on method. We also need here parentheses start, and as you can see it was 0, then motor is on, and it turned to true. So we have turned on the motor. Okay, so now let's turn off the motor. To turn off the motor, first I want to make sure that the start button is also turned off, right? Because if I only activate the stop button without deactivating the start button, it will be like start and stop are true at the same time. And that's not really the behavior we want. So we're going to do the following. If self dot underscore start button is equal to 1, then I just wanna turn it off. 1 or true, it's the same thing. It should be 0. Now we can proceed with my turn off. Now in my turn off, I would like to just activate the stop button. So I'm going to say self dot underscore stop button is equal to true. Now we need also the same mechanism in the turn on. If the turn off is already activated, I want to deactivate it. So we would copy all of this, put it here, and just replace start with stop. Okay, we are getting an indent does not match any outer indentation level because these need to be on the same indent level. Okay, so far so good. Now let's try to turn it on, then turn it off. I'm going to say here fan dot turn off. And I want to print the status of my stop button. I'm going to say here stop button is, and also let's add this here, start button is. Also we need it here just to distinguish what we are printing. Now let's run. We are having a problem here. Yeah, because it's called turn off. We had a typo. Try again. Now, as you can see, start button is 0. We turned it on. It became true. Then motor is off. Stop button is true. Now let's see. Is start button deactivated? So let us print the start button one more time to make sure that when we press the stop button, that the start button is deactivated. And as we can see, start button is deactivated once we press the stop button. Okay, so far so good. Now let's quickly write this change speed. Now in the change speed, I want to specify a value, let's say between 0 and 100. So I will be waiting for a value here. And this value will set my change speed variable. So I'm going to say here, this equals to value. Change speed equals to the value I'm going to pass to it. Same thing for direction. I would be accepting values of either 0 or 1. 0 is clockwise and 1 is anti-clockwise. So I will take a value here again. And this is my change speed variable. And I'm going to say here this equals to value. Okay, so 0 is clockwise rotation. And 1 is anti-clockwise rotation. Okay, so now let us quickly change the speed. I'm going to say fan dot change speed, and we're going to give a speed of, let's say, 50, and then we are going to print the variable called fan dot underscore change speed. Now I will do the same thing, or let us try this first. As you can see here, speed changed and now it's 50. That's good. Now let us change the direction. It's the same as setting the speed, but just a different function. This one is called change rotation direction. And we're going to pass 1 for anti-clockwise. And then we just need the change speed variable. Oh, sorry, not the change speed, but the change direction. Okay. Here we go. Now let's run. As you can see, speed it changed, direction it changed, but somehow my direction did not take the value I passed to it. Now let's see why. Because here this should be direction. We have a typo here again. Let's try again. And direction changed. So this is how we create a class, an object. This is how we deal with methods and with variables. Now, those variables specifically can turn into properties with a little bit more complex syntax. I'm not going to get into that at this stage because this is a little bit of an advanced Python. But just bear in mind that there is another way that we can change the values of these variables, which will turn them into properties. Alright, so we are still in object-oriented programming, and right now I would like to talk to you about inheritance. Now, inheritance is a very, very nice concept, and it saves you a lot of code. What does inheritance do exactly? Now, as the name implies, you are inheriting some features. So, for example, let's say that you have created a class for an employee, okay? And this is actually an employee card. The class is for an employee card, okay? You have coded where can this card go? Let's say it can go to the kitchen. You created a method for that. It can go to the printing room where you can print stuff. It can go to the meeting room, and etc. It can go to all of those rooms. Now let's say that you have a manager. Now, of course, managers can have more access to more facilities, right? Let's say you created this class that is called manager and you would like to give different access. Now, it makes sense that the manager will access everything the employee can access, okay? Okay, but there is additional places where the manager can access. It makes sense. So instead of rewriting the whole function by saying kitchen, printing, etc., we won't be doing any of that. What we're going to do is we are going to inherit all of that employee here. So I'm going to say here employee card, meaning that I'm going to be passing all the function variables and all the methods to this. And I can add more to it. So maybe I can add here a VIP room. So the manager now can access everything the employee can access in addition to a new features. So this is what inheritance is. You take a class that has certain functions, you take all of its functionality, and you can also add to it. You can even override some of the functions here, like to change its functionality, right? So it saves you a lot of rewriting when you have similar classes. So right now, let us code inheritance. First, I'm going to create a class called employee. And this class, I'm going to create the init function. Just a regular class like before. Pass. And let's create some accesses. Define access meeting room. Pass. Let's leave the functionality for now. Fine. Access to kitchen and access to personal office. Let's add pass to here as well. Okay. Now, let's say that I want to create that employee with higher advantages. So I'm just going to call it advanced employee. The name is ridiculous. Now here, in those parentheses, I would just put the name of the class I want to inherit. So by that, I have inherited employee. Now if I add one more function, let's say access private meeting room. Okay, so let's test this out. If I create an object out of this class, I should be able to access all of these as well. Let's see. So I'm gonna say employee number 4, let's maybe, and let's say advanced employee, and then I'm gonna say employee 4 dot, let's see if this employee 4 will have access to the meeting room. Okay. Now we need some print function just to indicate that we are in this function. So I'm gonna print here just the name of every function. This would be better than passes in order to check if we are accessing the function or not. And here as well. Let's add this. This is the name. Print this as well. Okay. Now if I hit on run, we forgot to add self to all of those. This is why we got an error here. So let's add self. Let's run again. And as you can see, we can access the meeting room, even though we did not define a meeting room in this inherited class. Okay, now we can also access that private room. And here we go, we have access to the private room. That's great. Now, we are going to talk about if we have an initializer here, how can we handle it in the inherited class? We'll see that. We are going to continue with inheritance. We are not done yet. So let's take the following scenario. You have a basic class, meaning that class that you would like to inherit from. Let's call it employee again. And we have our inherited class, which is called advanced employee. Now let's say that we have an init function right here. And you know, in the init function, we can create class variables that we can access, right? So let's say it will be something like name, age, initially just these two. Now we said that the moment we just pass employee like that, we will be inheriting from this class, right? From the basic class that we have. This is inheritance. Now, every class can have its own init. And let's say I would like to add more variables to those in my inherited class. So if I come here and just create a diff, a function that is with the same name, which is the init, as my basic class, which class will be taken? Which function will be used? Is it this one? Is it this one? Well, the answer is the moment you write a function that has the same name in the basic class, you'll be overriding this one. You'll be overriding the method or the function in the basic class, and you will be using the method in the inherited class. So this will win. But wait a minute, if I have like 8 variables, let's say, in here, would I have to rewrite them again? All of them here? Well, you're really not supposed to rewrite everything, right? So there should be a way to do that. And the way is by using the super keyword. Now with the super keyword, if you say super init like that, what you would do is you are saying, I want everything that was in here to be also copied here. Even though I have the same function, the moment I write super and I add the name of my function, what I'm doing is I'm taking everything that was inside this init function and I am bringing it here. So by that we have overcome the problem of if we override this base function with a different init, what would happen to all the class variables? Well, we can also copy them by adding this super. Now there is a little bit more into it. Let's say that you would like to add one more class variable to this inherited one. Okay? So if I expand this a little bit, these parentheses would have, let's say, a new class variable called maybe business number. Okay? For those advanced employees, I have something called business number. The normal employee does not have this. Well, if I do this, and in my object, when I create an instance from this, from the advanced employee, if I create an instance or an object here, well, and I just try to initialize it with name, age, and business number, I would have a compilation issue. Because even though we have copied this content, these variables right here, to the init, I still did not resolve how can I pass those variables. Remember, I am passing them here, and then I am assigning them here. How can I solve this passing problem? Well, let's do some coding and see how we can tackle this issue. Alright, so we have already written this class in the previous tutorial. To sum it up, we have an employee, we have a constructor, it's still empty, and we have three access authorization. And in the inherited one, we just added one more authorization for this advanced employee. Okay, now let's add a constructor here. And we are going to say that here we have age, first we need self, then we have age, then we have name and age. And here we are going to create these two. So we need self dot underscore name equals name, right? And self dot underscore age equals age. All right. Now here, let's say we have also a constructor because we have one more information that we would like to add as a class variable. So we are going to say def init, and simply here we will say self. Let's say I want to just add one more trait, which is business number. Okay. Now I told you that you can use super keyword to copy all of these, right? So we will say super underscore super dot init. Okay. And by that we have copied everything here. But we still have the problem of passing those here. Okay. Maybe we have copied those with the super, but we're still having a passing problem. Now if I try to maybe compile this, first let me get the object. So we have employee, or no, advanced employee, which will equal to advanced employee, like that. Maybe just call it a employee. All right. Now let's say I try to pass the three parameters, since they are supposedly inherited, like John, and age maybe 25, and then the business number, let's say it is 7891. If I try to run this, I'm gonna have issues. It is saying that it was prepared to take 2, but it got 4, as you can see. Self it's always considered 1, but you don't really pass it. So when you say it was supposed to take 2 for a method in a class, it means that it was supposed to take 1 actually, because self is already taken care of. But here it's saying that 4 were given, so it was expecting only 1. That means we did not really copy those to our inherited class. So how can we do that? You can do that simply by doing the following. You need to pass here star args and double star quarks. Okay? You need to do that here and also here. Okay? So what those means, in very simple words, it means take everything that the init has, no matter how many variables are, and just copy them here. Okay? Same thing here. It says take everything here and just copy them here. All right? Now if I try to run this, okay, we forgot to add that super is need parentheses as well, so let's try again. As you can see, now we have no errors. Now if I try to print a employee dot, let's say name, and I just print it, underscore name, we would see we have 25. Now if we try to print the business number, take a look what's going to happen. Well, it got us the name. Why is that? Because of the order we are passing here. Okay, so here we need to put the new variables at the beginning. So this needs to go here right now. And then we have the regular order that we have over here, which is name age. So whatever new variables you have, you just put them at the beginning, then you put the others. Okay, now if we try to run, you'll see that we have John and the business number. Now let's try to print the age as well. Okay, we just have an indentation problem. Let's try again. We will see that we got the age. Okay, so these orgs and quarks has many applications, and one of them is just to copy whatever variables you have in your init in the basic class to the inherited class. So this is a very important concept, and I hope that you learned something when you looked at this tutorial. Now I need you to really try to write a similar application so that you can get your hands busy and maybe you can learn this topic a little bit better, because these stuff only are learned with hands-on experience. Okay. Hello guys, and welcome back to you in this new section. In this section, we will be focusing on decoration. Now, decoration is actually an advanced technique in Python, and it is wrapping functions inside each other. A lot of libraries like unit test, like Flask, use decoration heavily in their syntax. So it's really important to at least grasp the concept of decoration. Now, I'm not going to jump into decoration directly. I'm going to be doing a gentle start on decoration by first seeing how we can pass functions to functions in Python. Now, you might ask, why would I want to pass a function to a function? Let's assume that I have multiple functions that calculate a certain formula, and I have a third function that, let's say, decorates and prints a nice report for whatever formula I have. Let me give you an example. Let's say here that I am defining a function called calculate formula. This is formula 1, and we are passing it to variables, all right? Let's say that this function returns x times y plus x divided by 2 plus 2, okay? It just returns this formula. Now let's say that I have a second function called calculate formula 2. Also takes x and y, but this one returns a totally different formula. It's like x times x times x plus y times y times y plus x plus y plus 10. Okay, 10 here. Okay, this could be anything actually. Now, usually if I am gonna call this function, I would say C1 is equal to calculate formula 1, and I would pass it two numbers like 2 and 2 maybe. And here C2 is equal to, let's say, calculate formula 2, and then I will be passing 3 and 3 here. I'm calling this function and then this function, okay? Let's print C1 and C2. Okay, here we have a typo. Okay, we forgot to say return here. Alright, so here we are returning 7 and here we are returning 70. Okay, we still did not really talk about passing function to a function. Now, let's say that I have a function here that is going to give me a nice output. Okay, I'm going to say here print output report, even though it's not really a report, but just let's demonstrate what we're talking about. I'm going to be passing this a function and its parameter, okay? The function and its parameter. Now, this function is going to do the following. It will say x is equal to function, whatever it is, and I'm putting the parameters in. Here it's like decomposing function name and functionality and its parameters, okay? So here I'm saying x is equal to the function I sent, and I'm passing the parameters I sent as well. Now I'm going to be printing the report. Let's say print. Let's do some dashes maybe. This is a report for your formula maybe. And then let's print something else. Print your x variable is something. Here I will be passing x. I will do the same for y maybe. I need to put commas here. Okay, and then here I will be printing the result of your formula is, and then I would be passing x. All right. Let's not call this x actually. Let's call it z. All right. So this is z. So this is like a report, right? And I don't want to put this report here because the report might change, and I don't want to change my formula function. I could just create a function specifically for formatting, right? Now, let's say here, print output report. Let's say that I would like to pass it this function. I will pass it the function name and the parameters. Let's say this time it's 4 and 2. Take a look. You'll see that I have formatted this function the way I want. X is like that. Here it should be y actually. X equals 4, y equals 2, and the formula calculation yields 2, right? Now let's pass it as well the second function and give it different parameters. You'll see here, this is the report for your formula. First number is like this, second number is like this, and then the result is like this. See, we are wrapping these two functions inside this function. But as you can see here, we are wrapping a lot. Let's say that I have changed this function and I added a z, and assume that I have multiple printing reports. All right, let's say this is printing report 1, this is printing report 2, and for some reason I would like to add to this formula a third variable. I need to go to each formula and do some changes, and that's a lot of work. See, here the cascading becomes a huge problem. And the way to solve it is with Python decorators. Let's start with a small introduction about decorators themselves. Okay, now in order to get rid of this dependency, let's do the following. I'm gonna remove this xy, okay? I'm gonna be passing only function. Now I'm gonna be defining a function inside a function. And I'm gonna say here f, x, and y. Whatever f that will be passed, alright? I will be putting all the syntax of decoration inside here. And then I will be returning the result, which is z in our case, maybe. And then here I will be returning f. This is totally new to you. I know that. Like, what does it even mean to define a function inside a function? Now, the printing is wrapping this other function. Okay? Now bear with me. If I say here, calculate formula 2, I will be altering the behavior of this whole calculation formula 2. Let's see how. I will be saying here print output report, and I will be passing this calculate formula 2. What I'm doing is I'm changing this whole function with this statement. I'm saying, hey, I want to update calculate formula 2, which is this function. How? I would like to take print report, this one, and pass it the original calculate formula, which is this one, meaning that this function here is now calculate formula 2, and it will be just right here. All right? So right now, calculate formula 2 is actually this returned f. What is this returned f? It is this function. So I altered the function. Now calculate formula 2 is nothing but this function itself. See? I have changed calculate formula 2 from being like this to being this wrapped small function inside. So first, we took calculate formula 2, we called the print output report, which is this one. We passed calculate formula 2. So calculate formula 2 now has changed. What's happening in details is that func here is now calculate formula 2, meaning that this function comes and replaces calculate formula 2 because this is what we said we want to do. All right? Try to wrap your head around this by repeating what I said multiple times if you still did not get it. The whole idea is wrapping a function or altering the shape of the function. This is what we've done in this statement. Now let me delete these. Now simply, if I just say calculate formula 2, see, I'm not calling print output report. I'm just saying calculate formula 2, and I pass 2 and 3 to it. See what I got? I've got the formatted output. See, how did we do that? We define a function, we define a wrapper, we pass that function that we have defined to the wrapper. Now, the new function equals whatever we have inside, whatever we have encapsulated. We alter the function, and then we just call it regularly. Okay? This is the basis of decorators. Now I'm going to show you how we can even make this shorter. It was important to go step by step to understand this concept because this is one of the hardest concepts in Python and people really struggle sometimes to understand it. But by breaking it like that to a step by step, I'm sure that it is way easier to grasp this concept. Now let's jump to the next video to see how we can make this shorter. What is the ugliest thing about this way of coding? What is the ugliest thing about this wrapping? The ugliest thing is that we have to do this, which is taking the function name, calling the wrapper function, and repassing again the function inside it. Well, this is really ugly. We can do better. Take a look. Let's say that you have defined your wrapper function, all right? Let's say you defined it first. Then those are your functions. Now all you need to do is the following. You need to say at, the symbol at, and you need to pass the name of the function here, which is this one. Let's say you want to decorate this one, you do this. So this is what we call decorator, meaning instead of just writing the wrapper and wrapping it yourself, all you need to do is just get your function and write the wrapper above it in the header like this, instead of doing all of that. Now, let's just try this. You'll see that we get the same result. Let's try it on the first function. We also get the same result. We get the formatted output. I hope that now you understand what decorators is. We are still facing some issues. As I said, it's hard to expand this. If I have more variables, I really cannot pass them to this function. So how can we resolve this issue? When we were talking about object-oriented programming, we have mentioned args and quarks. We use args and quarks whenever we don't know how many variables we are passing to a function. This is exactly the solution for unknown number of variables or the possibility that the number of variables might change. So now, let's do this. I'm going to be saying here, instead of x and y, args and double star quarks. Okay, and I'm going to be passing them as well to this func right here. Now we need a way to handle this report so that it can handle any number of variables. As you can see, my problem is not here. My problem is with how many variables I want to display. We can create a very simple for loop saying for arg in args and just print like that. I'm going to be printing your, and here we'll be saying r. Instead of x variable, we will be, either we can use text format or we can just do it quickly like this. We will say your, and then here we can enumerate. Okay, and here we can put a counter. And we are going to say your, then we will be converting I to a string, I plus variable. So your first variable, your one variable, your two variable is argument. All right, and that's it. By that, we have took care of all our variables. Now let's test this out. We need one more star here. And here we go. Maybe we need some space here. Your zero variable is 2. Your first variable is 3. See? Now let's say that I have changed my formula 1 and I am passing now z and w. And here I want to add w and z. Okay? I don't have to go and change my print variable. All I need to do is just pass the numbers I want here, run it, and it will take any number of variables that I want. The thing is just write a good decoration function that can handle any number of variables. You always want to think about, if this function expanded, will I be able to handle it well? So now, whenever we want to modify something, we just modify our function. We don't care about modifying our wrapper anymore. We can do the same thing for formula 2 here. And let's say it is also taking two variables, t and u. Here we can say plus t times u. And as you can see, formula 2 worked like a charm. And by that, we have covered the most important aspects in Decorators. I hope you understand it. If you have any issues, you can write me in the Q&A or in the comment section. All right. So we have learned how we can plot using Matplotlib library. Now I want to teach you another way to plot, and this method can be seen in a lot of codes throughout the internet, or if you are working in a company, or if you are checking a library that is plotting something. So I would like to introduce you to how to do subplots. Now, a subplot is actually a way to divide your plot into multiple sections. Now, in my particular case, I'm not going to be dividing my plot to multiple sections, like multiple plots in one plot, but I'm just going to show you the way they do it. So first, let me import matplotlib.pyplot as plt. Okay. Now let us define some coordinates. So I'm going to say x is equal to 1, 2, 3, 4, 5, 6. And y would equal to, let's put random numbers like 5, 15, 1, 3, and 5. Okay? Now, first we're going to define something that is called figure. So we say fig is equal to plt dot figure. Okay? Now this will define my figure, or the canvas that I'm going to use in order to plot my figure. Okay, now the thing is, there is a setting that we need to change as well in order to see this plot in a separate window. Before we were seeing all the plots right here, around here in the console. So now if we go to Tools and go to Preferences, and we just go to IPython console and go to Graphics, now you will see the back end right here. There is automatic and there is inline. Okay, now let's leave it at automatic, because at automatic we're going to get a separate window whenever we plot something. Okay, click on OK. Click on Apply to all existing consoles and restore all kernels. Now the kernel will restart, as you can see here. Okay, and we're good. Now, let me try to just show this figure that I have created, or the canvas that I have created. All I need to do is say plt show. Okay. Now if I hit on run, as you can see now I have a separate window, and this window has a zoom, has a move, it has multiple settings actually, and that's really cool. Now, as you can see, I have no grid, I have no x-axis, I have no y-axis, so let's add those as well. The way to do this is by defining something called a subplot. So I'm going to define an axis, I'm going to call it axis 1, and I'm going to say fig, the same figure that I have created here, this one, and I'm going to apply a method that is called add subplot. Now I'm going to pass it the following parameters, 1, 1, 1. Okay, now those are going to say how many horizontal or how many vertical plots do I have. And here is the index of that plot. Now, if you are plotting only one figure in the canvas, you don't need to worry about all of those. Just pass 1, 1, 1, and by that you are plotting only one. You can read more about this actually in the documentation of Matplotlib. And you can read more about subplots or how you can add multiple plots to one figure. Okay, so now if I run this, as you can see, I have a grid, I have an x-axis, and I have a y-axis. That's great. Now let's draw some stuff in this canvas. Now always we draw before we are executing plot show. So how can I add those coordinates to what I have done here? It's very simple actually. I just need to say ax1.plot and just pass it the x and the y coordinates. Now I tried to run this, but I got that the values here are not consistent because I have 6 values here and 5 values here. So let's add one more value. Let's run. And as you can see now, I have a smooth plot. That's really cool. Can I use a scatter right here instead of plot? Let's take a look. As you can see, we can use a scatter as well, but the cool thing is that now we have a separate window and we have the ability to draw multiple figures in one canvas. So what I want to talk about right now is plotting. How can we plot figures using Python? Python is one of the most powerful programming languages in order to plot statistics. So we can plot graphs, we can plot multiple types of graphs, we can compare figures, we can do a lot of visualization with Python. And the most famous library for that, it's called Matplotlib. So we're going to say import matplotlib.pyplot as plt. Okay, now let's try to plot multiple dots. Let's say we have a data that has a certain shape and I would like to plot it as dots on this graph paper. Okay, so let's say we are defining this ourselves. So we have x-axis and let's say it has the values 7, 50, 12, 8, and 42. Okay, we have 5 values. We need a comma here. Okay, now the y-axis is going to have also values like 1, 8, 80, 17, and maybe 27. Okay, now let us just plot this quickly. The way to do that, I would say plt dot, let's say we want to plot them as dots. So we need scatter, this is the name of that graph, and we need to pass to it the
x coordinates and the y coordinates, right? I mean, to plot anything, you need x and y coordinates, at least in our case here. Now I need to also show the plot, so I'm going to say plt.show. Okay, now if I run it, as you can see, I got those dots plotted on a plot sheet. Well, that's really good. Now let's say that I want to label what is the name of the y-axis and what is the name of the x-axis. This is very simple. The way to do that, we just say plt.xLabel, and we just put the name of the label. Let's say this is number of incidents. Doesn't matter what data I'm plotting right now. I just want to demonstrate this. And here, let's say this is the y label, and this is the occurrence. Okay. Now, if I run this again, as you can see, this is the occurrence and this is the number of incidents. Okay, so this is how we use a scatter. Now, if I change a scatter to bar, bar is going to be something like that. This is a bar configuration. As you can see, Python makes visualization very, very easy. Okay, now how about if I want to plot a line? You know, a graph line that has a certain look. Now, if I try to plot this as a line, it won't make sense because the points are not really linear and they are not really coming in sequence. So if I just hit like this, as you can see, the lines are scattered in a weird way that we got a weird graph. But let me change these. Let's say the x-axis is counting in sequence. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and now let's do some value. Let's say 5, 7, 10, then it's decreasing. 1, 3, 9, 15, 2, and 1. We have 9 points here, I guess. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 9 values here. Now, if I try to plot this, as you can see, now I have a graph that makes sense because the x-axis need to be in sequence in order to get a line like that. Okay, so this is an introduction to plotting using Python.
Okay, so far we have been talking about plots, right? Okay, so we have been talking about plots. And we were doing a really great job plotting some static plots. Now, what if my data is live? So let's say that I have a device here, I have some database that is being updated and it's sending me multiple data. And I want to be representing this in real time or almost in real time. So here I have time and the data is changing. It could be a stock, it could be anything actually. This data is changing, that's the point. Well, so far we were defining the X list and the Y list, which is predefined, and even if I change it in real time, this will not reflect in the changes in the subplot, right? Because this is static. So how can we make a live plotting? Well, there is something in the Matplotlib library that is called animation. Now, animation requires you to pass it a canvas or a figure that we have learned about previously. And it requires an animating function and an interval. So what does this mean? Well, figure is actually self-explanatory. It's just the canvas that you'll create, okay? And then animate is a function we are going to use, which will read, let's say, from a txt file or from an Excel file. And it will keep repeating this reading at a certain interval, let's say equaling 1 second. So every 1 second, we are going to activate this animation function, which will read, let's say, from a file, and it will draw on this figure. And this will repeat every 1 second forever. So if you are repeating this every 1 second, and let's say for
somehow this txt file is updating with live values, you will see every second a new data being plotted on your plot. Well, that's really cool. Let's see how we can execute it.
Python can help you create files and folders, which you can use to organize your data. Let's say that you are building a software, you definitely need a way to organize all those files and folders that comes around. Now, of course, you have installed software before, and if you open to any directory of that software, you'll see that there is a lot of files and folders laying around. And Python has a way to generate those so that you can organize your data. I'm going to give you another example. Assume that you are creating a software that collects photos from the internet. You'll need a folder to put all of those photo files in. Maybe you'll need multiple folders to do that. Python has a very handy built-in functions to help you do that. So let's get started.
Hello guys, and welcome back to you in this new section where we will be talking about directory management. With directory management, we can create paths, folders, files, and we can move them around, we can delete them, and this could be really important when we are creating projects. The way to do that is by using a couple libraries like shutIL, and also we have the OS library. So basically, we will be having one root directory. Let's say that this is a folder. This is the root folder. And then we will be creating a bunch of folders around here, like that. Then every folder might have a different folder, like this. See? And we can put files inside every folder. We can put images, we can put text files. I mean, this is how we create a directory tree. This is the purpose of directory management. And you might ask, where could I be using this for an application? This has tons of application. Whenever you are building an app, you are going to need directories. I'm sure that you have installed some Windows app or OS apps before where you have found those folders around with the executable file. I'm sure that you have installed some software on your computer, and if you browse that software directory, you would find multiple folders, multiple files. So all of those are created using something like a directory management. Whenever you install a software and you know all of these pressing next in order to install a software in a certain directory, well, the back end of that installer is all about directory management. So it's a really important topic, and I'm really excited to start this with you guys. One more application that we can find as well is when we have some images datasets, maybe that we would like to rename. Sometimes you bring datasets from the internet and you would like to rename the whole images with a certain string. So directory management helps you as well with renaming a bulk of folders or bulk of files. So I'm really excited to start this with you guys. Let's get started. Okay, so let's start with directory management. The first thing I want to do is to import a library called OS. Now with OS, we are going to do a lot of stuff like creating folders. Let's say I'm creating an app that requires the three directories. The first one is called the scripts, the second one is called libraries, and the third one is called data. I'm not going to be creating subfolders at the moment. I'm just going to be creating the base folders. I'm going to be defining the folders names in a list. So I will say here scripts. I also have libraries. Let's call them lips. And then we have data. Okay, I only have these three folders. Now all we need to do is create a for loop to create that. So I'm going to say here for F in folders. The method name in OS is called make directory or DRS. And then we will be passing the name of the folder, right? So here we are getting the names one by one, and then we are making the folder. Okay, let's call this as folders, and we're good. Now if I execute this, it will execute. Now let's go and check the directory. We will see that we have 3 folders. By the way, I chose where I want to execute this using this open folder here. Okay, I put all of them in the test and I execute it. So here it will create folders in the base where you have chosen with your editor, or with the base where your script is running. Okay, so these are my 3 folders. This is what I want. Now take a look. If I try to execute this one more time, I'm gonna get a problem saying that these folders already exist, because you cannot create a folder when it is already there. So what you need to do here is use exceptions. Here exceptions can be very useful and you must use it, otherwise you might fall into issues. So here I'm going to say try to create it. Okay, we have talked about exceptions in a whole section in this course. So try first, then if this doesn't work, I would like to accept. But what do I want to accept here? I'm going to be expecting an OS error. Okay, I'm going to say as error, and then I would like to print this error. Okay, now my program is going to execute, and if one of the directory already exists, it will just say, hey, there is an error, and it will continue creating the others without really crashing the whole program. So if I try this, you'll see that I cannot create file, cannot create file, cannot create file. Now let's say that I have deleted the data. Okay, if I run this, you'll see that cannot be created. Now let's reset this. Now if we try to run this, we will see that we only got 2 messages, and we will see that data is recreated. So this is the safest way to create folders. Let's assume that these folders right here were temporary in order to just create your project. Sometimes you have to create folders, put files in them, do some processing, and then delete everything. So how can you delete those folders after we are done processing? Well, there is a method that is called OSRemove. We can simply replace it here, but OSRemove has some issues. Sometimes it is too reliant on the permissions of that certain folder we are trying to delete. So a better method is from a library called shutil or shuttle. So here we're going to import shuttle, and then let's assume that we would like to only modify here. We are still looping through all the folders, but this time to delete, not to create. So I'm going to say here shuttle dot rm3. Okay. Now, if I simply execute this and go check my directory, you'll see that it is empty. And this is exactly what we are expecting, an empty directory. Okay. Now, if I try to execute this one more time, I will get exceptions because the folders are already deleted and there is nothing to delete. So with deletion as well, it's very, very important to do it with the try exceptions. Otherwise, you might risk your program crashing if the folder does not exist that you are trying to delete. Okay, so let's assume your scripts will be given to a client and you would like to place folder at a certain place and you would like to know where is the script at the moment. So how can you tell what is the current directory of your script? Well, we can do that by some method that is called getCwd. So here if I say print os.getCwd like that, and I run it, you'll see that I have my current directory. That's really great. Now, there is another method that is very important, which is joining 2 directories together. Let's say that you have a base path and an image path. You have multiple images that you would like to store, okay? So you have things like Let me give you an example. Let's say that these are my images, all right? And these images will be in a list, and their names are, let's say, image1.jpg. And let's continue by copying and pasting these quickly. We have image2 and image3. Okay? And you would like to save all of those into a certain directory or to the current directory. And if we are using any library like OpenCV in order to write an image, we would need something like that. Let's say import cv2. This is just a dummy example. And here we would say cv2.image right? And we need to specify the path here, the full path. Now, we need here to specify the full path with the image name. But our full path is here and the image name is here. So we need a way to make it something like D folder1 blah 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 and then image1.jpg. We would like to create this format. Okay, now we can combine strings together, but this is not practical and it will make problems when we are, let's say, running this script on Linux or on Mac OS. So it's best to always combine using the OS library. We're going to see how we can do that in a minute. Now let's remove this OpenCV and let's put this in a variable. Let's say this is the base directory. I'm going to call it a base. Okay. Now I'm going to create a new path here, variable, and I will use the method os.path.join. All right. This join is going to join two paths here. I'm going to join the base, and I want the path to contain the first image name. So I'm going to say here image 0. Okay. I would like to take the first image. Now, if I try to print this new path, you'll see that my new path is now all of this, including the image name. Now I can use this path in order to store it somewhere, right? In order to pass it to a certain storing function. How about if I want to print all of these paths? Well, I can just simply say for p in image os.path.join and then base and p. Okay? And let's create an empty here list, image path, we're going to call it. It's empty, okay? And let's append all of those. So I'm going to say here, let's assume that this is a new path now. And let's append all of these new paths to this list. I'm going to say image path.append new path. And finally, I would like to just print this image path. If I execute this, you'll see that now I have all of them. This is the first one. This is the second one with the image name, and this is the third one. So OS path join is a very important method that we need to use in order to create paths. Now let's learn how we can create subfolders. So far we learned how to use OS make directory in order to create the root folders and the base folders. Now let's assume that I would like to create deeper folder. We are going to utilize the OS make directory and the OS path join together in order to achieve this. Let's first create the folders that we need to create. So let's say folders is equal to, like the last time, scripts, and we have the lips, and we have the data. Okay? Now let's say that I would like to create a subdirectory for scripts. Okay? All I can say here is just do sub for subdirectory and just scripts. You can create a variable like that. And then put what kind of folders you would like to create. Let's say that under scripts, I still have two folders. One of them is called the pre-process images, and the other is pre-process table. Okay. So these two folders will be inside the scripts folder. What's the first thing to do is let's create our base directory, which is os.getCwd. Now, your base directory could be anything actually. It does not have to be your current directory. Some files like to install things in the C directory. So if you want to do all of these in C or in D directory directly, you would do something like C, okay? Like that. So this is your base directory. But for me, I would like my base directory to be actually my current directory. Okay, so this is my base. Now it's time to create the folders. Let's do this quickly. We have 4F in folders, and then we need to try os.make directory and then F, right? Now accept os error as error and then just print this error. Okay, we have talked about this multiple times. Now it's time to create the subdirectories. This section will create these three directories. Now let's create the subdirectories. We are going to say again for F in, this time in subscripts, not in folders. In subscripts. And here we are going to create the base path. Okay, so my path is going to equal to os.path.join. All right, what do I want to join? Well, I would like to join the base where I am right now, and I would like to join the name of the folder, the first folder, which is scripts, which is in folders here. So it is in folders 0, meaning scripts. So it's like saying D, second folder scripts, and then I need the name of the folder I want to create, which is we are looping through right now, which is F, right? So this F will loop here. So the first folder will be D scripts and then preprocess image in this F, then D scripts, and then the second one, which is a preprocess table. Okay, now it's time to just create it. Again, how do we create it? We just say try os make directory, and we need the path, right? This path that we have created. And then accept. Let's copy this. I don't feel like writing it again, so here we go. Now if I run this program and go to the directory to check, you'll see that I have 3 folders. If I go inside the scripts, you'll see I have 2 another folders. And you can do the same if you want to create subfolders and libs in data. You can create a small script that create those for you. And by that you can have a tree directory and you can manage it as you wish. So far we were learning about how we can create things, create directories. How about when we want to read directories or modify directories? Well, let's first talk about exploring what directories do we have in a certain folder. Let's say that I have my current directory, which contains one folder on my script, which is I have opened right now. How about checking what are the directories that I have inside here and just to print them out? We can do that simply by just saying print os.list directory. Okay? By just running this simple command, I would get what do we have inside my directory. We have data and we have exploring directory by. Now let's say I would like to know what is inside my data. If we take a look, you'll see that I have a data set of different rocks. Okay? So how can we get what's inside the data? We will be using base is equal to os.getCwd, of course, and then we will say here path is equal to os.path.join. I would like to join base, and what's the name of the folder? It's called data. And then I can pass path here, so we can explore a certain path. And as you can see, I have a list of all of my images. So this is how we list what we have inside a certain folder and explore our directories. Okay, what I would like to talk about right now is changing directories while we are inside the script. Right now, my current directory is this one. Okay, how about if I wanna do some things inside this data folder. Of course, I could use ospath join and use this new path every time and just include it in all my new files. But wouldn't it be easier if I jump directly inside this data and start doing my work? So my goal here is to jump inside this data while I am in my script. So the script will do this. It will go inside here and then just do the work it needs, okay? So how can we do that? Well, we can just say os.change and directory, and then let's say now my new directory is data. Take a look. Now I am inside data and I can do whatever I want in data. Okay? The question is, what if my data folder does not exist? Well, changing directory is also dangerous. You need to do try, and you need to do this, the same as creating a new directory. You need to accept, and you need to print the error. And this will be much better because now if my folder is called like that, dasta instead of data, we would get a problem right here. Why? Because also we are trying to list. See, even listing is dangerous. If I comment out list, you'll see that we got an error, system cannot find the specific data. So whenever we are listing directories or we are changing directories, it's important to do it inside a try except. Okay, let's do a small cool project. I would like to take the pictures in this folder and rename all of them. Okay? When you are creating datasets for data science, for deep learning, for any learning model, sometimes it's important to rename all of your, let's say, images and their labeling files so that they are matching each other. So bulk renaming actually has a lot of applications, and we would like to know how we can do that. Let's write this small program. So we will import OS. Our directory right now is already inside the data, meaning we are already inside this folder. If I say directory list, and then I say os.list directory, and I just print this directory list, I will get the name of all the images. Let's try renaming one of them, okay? Now the method to do this is called os.rename. It's pretty straightforward. I would like to rename the first element of this list. So I'm going to say dir list 0. What's the new name? I'm going to call this rock number 1. Okay? And .jpeg. Now let us execute this. Let's open the directory, and here it is. It is called rock number 1. So we have renamed it successfully. That's really good. Now, before renaming, I would really like to do a try, right? Because, well, let's say that we are trying to name a different picture with the same name. If we try to do that, we are going to get an exception error, and I'm going to show you. Now, if I try to take the first element, which is now this 13.jpg, with the same name that we already have here, we will get an error, cannot create a file when that file already exists. Okay, so we need to say try except. Always with OS library, when you are creating directories, always use the try except method. OS error as error print error. Now our program will not crash. Now if I try to name it something else like rock number 2, I will have no problem, and I will be renaming that file as well. Let's take a look. We have rock number 1 and rock number 2. Okay. Now that we have established how we can safely rename, what I would like to do is to try to rename a bulk of images. Let's give a base name. So the base name is going to be rock sample. Okay, this is my base name. Then I have my extension. So extension is equal to .jpeg. All right. Now what we are going to do is we are going to loop over all of our images. So I'm going to say for image in directory list. Now we will be renaming all of those. First, we need to create the image name. The image name consists of this name, this extension here, and also a number. So we need rock sample 1, 2, 3, and all of them .jpeg. To get this counter, I'm going to use enumerate. So we have I, enumerate. Now image is going to be having these values while we are looping, and I will be counting 1, 2, 0, 1, 2, 3, 4, etc. So I'm going to say here image name is base name plus, I'm joining strings, string I plus extension. Okay, now don't come and try to use path join here, because path join is going to create not an image name, it will create base name 2 slashes I 2 slashes .jpeg. Okay, so it will treat every entry as a folder, and this is not what we want. So we use a string combination to name the name of the folder, okay, or the file. So here we need to pass the image, and here is my image name. All right, I think we are ready. Let's run this. Now let's go and check. You'll see that we have rock sample 1, 2, 3, 4, 5, all the way to 34. And this is exactly what we wanted. We needed to do a bulk rename. That's great. Now I can, with a few clicks, I can just change the name. Let's say this is data set. So I have now data set 0, 1, 2, 3, 4, etc. That's great. This is how we rename. First, we have all GPG files here. I would like to create some dummy folders along with it, okay? So right now, my directory does not only contain files, but also contains folder. If I do this right now, and I just execute it for, let's call these images. If I open, you'll see that my folders are also renamed, and that is something I really don't want. I only want to name those files here. Folders I should never touch. Maybe there is also other files with different extensions, okay? I don't want to touch other files, let's say with txt extension. Let's take a look here. Let's say I have a txt file here. I don't want to grab it and change its extension. So let's rename this again to folder 1, folder 2, and folder 3. Okay? And, well, let's see how we can only choose those files, those GPG files to rename. We are going to be looping through all of the images, but even though the list directory here contains everything that I have, including folders and text files, I can filter them here. I can say if image dot end with jpeg, then I would like to do this, okay? So this end with is actually a method that we use on strings, and it checks the last portion of the string. Let's say we are reading the string. It reads what the ending of it, okay? And you tell it what is the ending. So here I am saying if it ends with .jpeg, then do these operations. If it's not, let's say we read something like a text file, then I would not like to do that, because let's say a folder, not a text file, let's say a folder here, it does not end with .jpeg, right? It ends with folder, new, whatever. It does not have this extension at the end of the name. So if I execute this, we got an error because it is called ends with. We got an error. Let's take a look. Why? Yeah, it's ends with, not end with. Okay, now if I execute this, this is ends with. If I run this, let's go back. You'll see that we renamed those to images. Now let's change the name. Let's call it data. If I go and check, you'll see that all of them are renamed to data except for my txt and my folders. And this is how we do filtered search and filtered renaming. Let's say that I don't want to do this filtering inside my loop here, and I would like to actually do it here. How would we do that? Well, we would do the same thing actually. We can say directory list is equal to list comprehension x for x in directory list, if not x dot ends with gbec. Okay, I'm gonna just remove these for a second and run it. Now you will see the files I have got are all the files that are not gbec. This is how I filter out gbec. Okay, now if I remove this not here, I will be getting all the gbecs. See, with the simple list comprehension, we are doing that. And by that we have finalized filtering. The next topic we will be talking about is CLI applications, and they stand for command line actually, interface. And the question is, where do we use command line interfaces in general? We use them whenever we want to create an application. So far we were coding like this. We have our editor, we are writing code. After we are done writing our code, we hit on compile, right? And we see our output. But is this practical? Let's say we wanna use this application, but this time in a production environment, okay? Meaning that you have a client that you would like to give out this application. Do you think that it's a good idea to give him the code and he has to press the compile button every time? Well, this makes no sense. You need to package this application somehow so that he can run it externally. You could have, let's say you save this as program.py, and then the user can just run it through the command line. This is what a command line interface is. And when we run it, we should be able maybe to specify arguments to this program, right? Sometimes you need to initialize it with some data, with some folder paths. So all we need to do is open a command line like that and type the name of my application. Let's say it is app.py, and then just pass it some arguments like this and hit execute. By that, the user doesn't have to go, the client doesn't have to go inside the script and run it. He will just be provided the .py extension, and then we will pass arguments, and these arguments will be passed inside our .py application. Now let's see how we can package our applications to be useful for the client without actually having to interact with the code. Now we are ready to start our first CLI application. Let's see how we can do that. The first thing we want to do is actually import a library that is called argument parser, and it's called arg-parse. Okay, this is the library that we will use. Now we need to create a parser object. So I'm going to say here my parser is equal to arg-parse dot argument parser, and then we need to specify what is the name of this application I'm creating. Let's say that this application is called app. By that we have created the parser and the initial information of my app, which is just the name actually. Okay, we need to say here prog is equal to app. Alright, next we need to add arguments. Arguments are like what you pass to a function. You know, we have a function like that and we pass it arguments like this. So these are the arguments that we will be passing from the command line to my program. Okay? This is the difference between a function argument and a CLI argument, is that the function argument is passed inside the program, and the CLI argument is passed through the command line itself, like going here, saying app.py, and passing some arguments like this. Okay, how can we add a new argument? We just need to say my parser dot add underscore argument, and then what is the name of this argument? I'm gonna say argument1. We are creating a dummy application at the moment. We also can provide help. So this help is going to be shown on the command line later, so that we know what does this argument do, or what are we supposed to pass here, so that the client knows what he's supposed to pass. So here I'm gonna just say dummy argument1. Okay, now let's add a second argument. I'm gonna just copy this and call this argument2, and this is argument2. Okay, now it's time to execute our parser. We're going to say args is equal to my underscore parser dot parse underscore args. Okay, so we are getting my parser and we are calling parse args, meaning that go to the command line and get me whatever the user gave for these two and store them inside args. Okay, then I would like to print done executing. Okay, it's a very simple program. Let's save it. Now, what you want to do is open Anaconda prompt from the Windows Start, and then I would like you to go to the directory right here, the directory of your application. How can you do that? If it is in C, just say cd and just paste the directory here. If the directory is in a different drive, like in D in my case, I would need to go to D first, then say cd for change directory and paste. And this is now my new directory. Okay, now I can find my script right here. It's called CLI app. So now if I just say CLI app.py, I will get too few arguments, and I will get usage app. This is the name of my app, and this is argument 1 and argument 2. Now if I say CLI app.py and then say -h, I would get help, meaning that I will see what am I supposed to pass. See, remember we have written here that arguments can have help section, so this is the help section. I need to pass argument 1 and argument 2. Okay, so now if I just say CLI app.py and I pass, let's say, number 5 as argument 1 and number 6 as argument 2, I will get done executing, meaning that we have got the arguments and they are in right now. That's great. This is how we create the basics. Now let us continue. Let us create an application that will return the summation, the subtraction, the multiplication, and the division of any two numbers. Okay, it will display 4 results. This means that we need 2 arguments actually only. And here I'm going to change the help into the first entry to the first entry, and here I'm going to call this the second entry. Okay, I also would like to add a description to my app here. So I'm going to say here description is equal to returns the addition, multiplication, division, and subtraction of any two numbers. Okay? Alright, so we added a description as well. Now, how can we read the arguments that we have passed? I mean, yes, we have passed them here, but how can we extract them? Now, what we can do is say input1 is equal to args.arg1, which is the name here we have, right? And then we could say here input 2 is equal to args dot, what is the name here? arg2, so this is arg2. So these became like a variables that we are passing through a function, right? It's the same thing. Now we can do some operations. We can just simply say print the summation is, and then just say input 1 plus input 2. Let's say here the subtraction. This is the subtraction. We have also the multiplication is a multiplication. And finally, let's say the division is by dividing those, okay? Now let's save this. Now let's run this app. It's called CLI app.py, and let's pass two numbers, let's say maybe 10 and 5. We got an error because here we were expecting two numbers, but we got a strings. This is the very important thing. When you pass any arguments from command line, they will come as a string. So you need to convert those into integers or floats or whatever type you want. If you want them as strings, you can leave them as they are. Otherwise, you need to convert them by casting. So now we have casted these into integers. Let's execute again. We will see we got this. The summation is 15, subtraction is 5, multiplication is 50, and division is 2. That's great. We have created a very simple CLI app that can receive arguments. Now, CLI apps are way more powerful than that, and they can do whole-scale full applications that can run through few commands on the command line. I just want to teach you a quick thing here. We have said that we need to cast this into an integer in order to read it. Now, if we don't specify the type, always it will be read as a string. But what we can do is just say type is equal to integer for the arguments. And by that, this add argument is going to cast it before sending it back as an argument. We can remove these integers from here and try it out. Now let's save this. And let's try to run this. I'm going to say CLI app.py and then 4 and 4. You'll see that we did not have to cast if we just specify the type. Sometimes it's really important to read the arguments from an external file, and we see that in a lot of CLI applications. So how can we actually do that? How can we pass the arguments through a text file instead of passing them in the command line? This is important as well if we are trying to pass a default arguments that we are storing for our app. All you need to do is go to this argument parser and add the following parameter from file underscore prefix underscore chars and then equal to a parenthesis and the @ sign. Okay? Initially, this is all you need to do on your program. Now, if I go to the command line, this is where my app at right now, and I just say CLI app.py, I will get that I don't have enough arguments because we did not really specify here that I want my arguments to be from a file, and we did not even create the file yet. Let's go to the py here directory, the app.py directory, and just create a file, and we're going to call it args.txt. Okay? Add the @ Now all we need to do is just add the @ sign, because we have really specified in this line that to specify where is the arguments, add the @ sign first. Then you just need to say args.txt. This is the name of my arguments, my argument file. Now, after we have created the file, let's open it and just add two arguments. Let's say 5, and let's say there are 20 and 4. Let's save them. Now we need to make sure that we are in the same directory as our script and our args file. And we just need to say CLI app.py and then add the name of my file, args.txt. And as you noticed, we have said here that in order to specify this file, we need to add this @ sign. So this is why we are adding it. Now, if we execute, we'll see that the arguments were obtained from that file. What I would like to talk about right now is something called optional arguments. So far, all of our arguments are compulsory, so we must type something, otherwise the program will not execute. What we can do is sometimes we need optional arguments, meaning that we might use them and we might not, depending if the user specified it explicitly. Now, how can we create this optional argument? All we need to do is just add a regular argument, and then at the beginning of its name, we can add double dashes like this. Okay? Now, let's say that here I am going to be adding a shift number. So shift is equal to 5, meaning that all of my results will be shifted by 5 no matter what. Now let's say that I can change this shift by this argument right here. Well, how can we do that? Let's call this shift optional argument, okay? But how can I make sure that this shift is changed or not? Usually, if you don't specify this argument, by the way, it's argument 3, if you don't specify this argument, if you try to read it, it will be none. So here I would say input 3 is equal to args.arg3, and now I can check if it's none. So I will say here if input 3 is equal to none, I would like to do this shift, okay? Meaning that I did not specify any new shift. Else, what I would like to do is shift will equal to input 3, okay? Now let's test this out. If I say here CLI app.py and I specify the numbers only 2 and 2, and let's say I did not specify any optional argument, I will get this result with a shift. 2 plus 2 is 4, plus 5 is the shift here, it's 9. Then subtraction will be 5, 9, 6, okay? Now let's change the shift to 0, okay? Meaning I will not be having any shift. All I need to do is just pass these 2 and say here arg3 and specify it as 0. As you can see now, the shift is 0, and I am just summing these two. 2 plus 2 is 4, 2 minus 2 is 0, multiplication is 4, division is 1. So this is how we use an optional argument. Sometimes we would like to actually store flags, meaning if we specify a certain argument, we would like to set a flag like a true or a false. We can do that simply by using something called actions. Now let's create a fourth argument, and this argument, I'm not going to specify a type for it. I'm just going to say action is equal to store underscore true. That means whenever I just type the argument 4 right here, I will be setting true. Let's say that it is optional to print the power of 2 of the first number we provide. Okay? And if we set this to true, we will be taking the power 2 of the first argument. Let's first extract this. I'm going to say input 4. By the way, we can just use the args arg1, arg2, arg3 in here in the condition, but we can also store them in a separate variable. So I'm going to say here args.arg4, okay, and this is optional. And I'm going to say here if input 4 is equal to true, then I would like to print the power of 2 of the first argument is input 1 times input 1, right? This is the power of 2 of the first argument. Only if we specify this. Alright, let's take a look. I'm gonna store this and I'm gonna call my app, specify the first number as 10, second number as 2. And then I'm not gonna specify any shift. I'm just gonna specify that argument 4 is set. So all I need to pass is just argument 4. We have a typo in the action, so let's just fix it quickly. This is action. And let's try again. As you can see, now we have specified this argument. We are setting it to true, meaning that we can print this statement, which is the power of 2 of the first argument. Now, assuming that I did not pass this argument, see, I did not get the power of 2. Now, this here can be specified as true or false, so you can store false or store true. It's up to you.
In this section, we will talk about the most famous math library, which is called Numpy. It is built using C and C++ libraries, so it's extremely fast in execution. So to anyone that is telling you Python is slow in data calculations, you can prove them wrong with this library. It contains everything from arrays, search algorithms, geometric calculations, and everything any math algorithm would require. So let's discover this library together and get started.
Now in this lecture, we will be talking about Numpy. Now, Numpy is not really a programming method or anything, it's just a Python library. So, what does this Python library do? Well, you will see Numpy in a lot of code around. And it's a very famous library for numerical operations. And it really helps you create arrays, create operations on arrays, create lists. And you might be asking, why would I use Numpy, let's say, instead of using the regular Python syntax? Well, Numpy is way faster because it's based on C. So the background so Numpy is actually wrapping a few C and C++ libraries, which make it really fast when executing numerical operations. So the advantages of using Numpy is that it makes your life easier. You can simply create arrays. You can simply, let's see what kind of stuff we can do. Well, first you can define lists or arrays really fast. So you could simply say np. So you can simply, let's say np here, array, and you can easily well, what type of operation does Numpy support? It supports tons of stuff. You can find the maximum number in a list. You can find the minimum number in a list. You can sort a list according to the ascending order or descending order. You can multiply lists together. You can do any type of mathematical operation on that list really quickly. You can create arrays actually on the fly and pre-define all the values inside them really quickly. So it's really a huge library and it's really famous. So let's get started and write some examples. Alright, so right now let us talk about 2D arrays. So far we have been talking about arrays that are one-dimensional. Now let's say that you want to create an array that is two-dimensional. How can you do that? Well, as usual, we will just import numpy as np. And now let's say array is equal to np.array, the same way we were defining the single-dimensional arrays. However, right now, we are going to open a bracket and then put every dimension separately in a separate bracket. So It's like a nested list, actually. It's like a list inside the list. Now, if you do that, you would get a two-dimensional array. So this is the first dimension. This is like 1, 2, 3, 4. And this is the next dimension, which is 5, 6, 7, 8. And we can also optionally add the type. So in my case, I want this to be MP integer 64 bits. Okay. Now, if I print this array, I'm going to get two-dimensional array. As you can see, this is dimension 1 and this is dimension 2. Now, if you have some mathematical background, you would know that multidimensional arrays are very popular and have tons of applications, and this is how you can create them with NumPy arrays. Okay, so there is one more thing I want to mention before wrapping up this small section, which is the shape. So if I get this print and just say here array.shape and I print this, you'll see that I got a shape of 2 by 4. What does this mean? It means that this is a two-dimensional array and every dimension has 4 elements. Okay, that's good. Now let's say that I extend this further. Okay, so right now if I hit on run, you'll see that now I have a dimension of 3 by 4, meaning I have 3 dimensions and every dimension has 4 elements. Okay, so this can be helpful actually. Let's say you are reading from an external library and you have an array and you would like to know what is the shape of this array. Well, you can do that simply by just saying array.shape and you would get the shape of your array. Now, let's say that you don't know the type of the array that you have because you are reading it from an external library. This happens a lot actually. The way to do that, you would just say array.dtype. Now, if I hit on run, you'll see that the type is integer 64 exactly as I have defined it right here. Alright, so right now I want to talk about searching an array. Okay. Now let's say that you have an array that has multiple names. Let's say Adam, Mr. Hamshaw, and John. Okay. Let's say that this array is called names. And let's say that I have another array that is called age. So this will be like 23, 29, and 40. Okay. And the 23 corresponds to Adam, 29 corresponds to Mr. Hamshaw, and 40 corresponds to John. Okay, now, sometimes we would like to search an array and get the index of that array. Searching means that when you find the element, you would like to get its index, okay? Because once you have the index of this element that you have found, and let's say you have multiple lists that have multiple information, this index would correspond to all the information, right? Because what's the index of Adam? It's 0. Mr. Hamshaw is 1 and John is 2. If you find the index of Mr. Hamshaw, which is 1, okay, now you can use this same index to get his age, to get maybe his address, because all the information are ordered the same way in all the data. So finding the index of an element is very important, okay? And NumPy makes this very, very easy. With NumPy, we can simply say, hey, I want to search for a certain name. Let's say for this name, okay? And it will return to me the index. Once I have the index, I can use it to find other information. Okay, let's see how we can implement this. Now, in the regular ways, you can use for loops to search for a string, and when you find it, you try to find the index. You can do that actually by hand, but when using NumPy, this is way faster, more robust. So we will use NumPy methods in order to find an element in an array. Okay, so let us try now searching an array. Let's say we have import NumPy as np, and let's say that my array is equal to np.array, and this array contains John and Mr. Hamshaw and Jack. Okay. Now, how can I find what is the index of Mr. Hamsho? Well, this is very simple. I would define a variable. Let's call it index, for example. And I'm going to say mp where. And I'm going to say a is equal to John. Let's say I'm searching for John. So this method where, you just pass it. What is your array? It's array here. You're saying, hey, search array for an element that is called John and return the index. Now, if I try to print the index, I won't really get it directly. So if I just print this, you'll see that I got this output. It got me the type first of this array, then here it got me the index. So I need to extract it. To extract it, first, we need the first element because this is index and this is type. So to access it, we need index 0. Now we have accessed this element and it is returning it as a list. Okay, so if I print now, I will get a list that has the index. Now I want to get the first element of this list and the only element in my case. Now if I do this, I will get the index of John. Now let's say that I'm searching for Jack. I should be getting 2, right? Because this is index 0, 1, 2. I'm searching for the index of Jack, which is 2. Now if I print this, I got 2 right here. So I got the index. Now, mp where actually returns all the indexes of that element. So let's say that we have the same name duplicated in multiple places. Now, if I just remove this, okay, 0, 0, and I just print it, you'll see that Jack was found in one place. But if I say I want to search for Mr. Hamsho, you'll see that now I got an array of 2 elements. Okay, so we have 2 indexes. We have index here, we have an element here, and an element here. This element has index of 1, and this element has an index of 3. So we can choose whatever we want. So if we access the first element, we will see that we got a list of the indexes, which are 1 and 3. Now we can use either one of them. We can use the first element, which is the 1, here it is, or we can use the second one, which is the 3, as we can see here. Okay, so mp where returns all the values that we could find. Now, maybe a duplicated name does not make much sense in this example, but this would be very, very helpful if you have, let's say, an image, a binary image that is consisting of zeros and ones. Let's say you would like to get only the blackness in the image. Let's say the image is masked and you would like to only get that mask which is drawn in black, and black has values of zeros. So let's say this is your image, it has zeros, 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 this is the object, and then you have some background, and then you have some object, and you would like to extract only the object without the background. Well, in order to extract that, you can use mp where to get all the indexes of all the pixels that are black, let's say. So mp where is a really powerful method for NumPy. Now let us continue with NumPy methods, and now we are going to learn how can we find the maximum and the minimum element using NumPy. Usually we would use for loops and algorithms in order to find the minimum and the maximum number, but since Python is great for fast prototyping, we can do that with a simple method. Let's say that I have an array and it has elements, let's say like 50, 20, 30, 91, and the largest element maybe is 101, and the minimum is 2. Okay? Now, in order to quickly find this, I need to define a maximum. Let's say maximum is equal to np.amax, meaning array max, and you just pass it the array. Now, you pass the array to this function, and it should get you the maximum. Now, if I print maximum, you'll see that I got 101, which is the maximum number of this array. Now, let's say I want to find the minimum. All I need to do is just say minimum is equal to mp.amin and just pass the name of the array, which is arr or array. Now, if I print this minimum, you'll see that I got 2. So see, it's really, really simple to find the maximum and the minimum element in an array using NumPy. Now we are going to talk about sorting arrays in an ascending or in a descending way. Okay, so let's say I have this array right here, and I would like to order it in an ascending way. Even though we have duplicates, still this won't affect our sorting. So let's define a variable and call it sort maybe. And it's going to equal to mp.sort, and just pass it the array that you want to sort. Now I just want to print it. Now if I hit on run, you'll see that now my array is sorted in an ascending way. That was really easy, right? Now, let's say I wanna order this in a descending way. Well, there is multiple ways to do that, but I'm gonna teach you a trick to use this same method in order to order them in a descending way. So all we need to do is, let's say sort is equal to minus np.sort. Then here I will pass minus array. So first I am multiplying all of these by a minus sign inside here, okay? Then it will be sorted. Now, since I have converted all of them to a minus, well, and I sorted them, they will be sorted in a descending way, right? Let's try it. First, let me remove this minus and just try to sort them when they are multiplied by a minus sign. Let me print it. We forgot to print. You'll see here actually that they are ordered already in a descending way, but they are in minus, right? Now, all I need to do is just multiply by minus one more time after they are sorted. So now you will see that I got the array sorted in a descending way. See, it's a really simple trick. You just convert all your array to a minus, you multiply it by a minus one, then you sort it, then you multiply it again by a minus one so that you can negate the first minus one you have multiplied in the first time. And that's it. This is how you can sort in an ascending and descending way using NumPy. Alright, we are still learning the methods of NumPy. Now we are going to learn how can we merge two arrays together. Let's say you have two arrays and you would like to put them in one single array. This is a very common application. The way to do that is by using a method called concatenate. Now to concatenate two arrays, all you need to do is just define, let's say, a new array. Let's call it C. Then just say mp.concatenate. And you just pass it which two arrays you would like to concatenate. But you need to pass them as lists. Okay, it's really important. So you would say here A and B in my case. Now if I try to print C, you will see that the second array was concatenated with the first array, as you can see right here. Now, let's say you would like to do it the other way around. You would like to concatenate the first array to the second array. So this would be B, this would be A, and as you can see, this happened. We concatenated the first one to the second one. Now, please don't forget to pass them as list, okay? Because if you try to do this, you'll get an error, okay? Always concatenate. It will always only accept a list of arrays. Now, I can concatenate more arrays with here. Let's say this is D, and let's say I have different values like that, and we can just simply say, hey, add C to this. Oh, sorry, not C, it's D. Let's say we want to add D to this. Now if I run, you'll see that I have all the arrays concatenated into one array. Okay, now we are going to talk about splitting an array to equal parts. Let's say you have data and you would like to split it into multiple parts for your algorithm. Now in machine learning especially, it's really important sometimes to divide your data set into equal sets and then pass them one by one, or split them into training sets and testing sets, which we will be talking about later. But for now, let's say that you have this very, very simple list and you would like to split it into two equal lists. Okay? The way to do that is by defining a variable. Let's call it splitting. And we need to say mp.hsplit. Now you pass which array do you want to split. Our array is called A. And to how many parts you would like to split it. In my case, 2. Now if I print splitting, you'll see that I got 2 arrays with equal length, right? So here I have 5212, so 5212, and this next one is 1792, and they are 2 different arrays right now. Here I can print, let's say, splitting 0, the first array I have splitted, and the second one. So if I do that, you'll see that now I have 2 arrays. This is the first one with index 0, and this is the second one with index 1. Now, splitting is tricky because if you try to split this to 3 parts, you would get an error because here you have 8 elements and you cannot really divide 8 by 3 into 3 equal parts, right? You need to make sure that your array is splittable to equal parts first. Okay, let me add one more element here and now try again. And I'm gonna print the third one that will be emerging here. Okay, so now if I hit on run, you'll see that I have 3 arrays with an equal length, and they are all stored in this splitting array. Okay, so split is very important in order to divide your data sets and manipulate them as the application requires. Alright, so far we have learned how we can create arrays from NumPy using ranges or using all zeros or using an array that contains all ones. But what if I want to create an array with a randomized number? This is also very important in data science because sometimes you would like to create arrays that have no random numbers, okay? Or maybe initialize a certain array that you will be used in your algorithm with randomized number. So how can we do that? The NumPy library provides us with the random module. So we can say here from numpy.random import default underscore random number generator. Okay, I have a typo, import. Okay, so this default random number generator is going to be the one that will generate all of these numbers for me. So I'm going to create a variable that is called random array. Okay, and take a look how we can generate random numbers here. First, we need to call random. Then we would pass it the default RNG method. Okay, like that. Then we need to specify what is the range of my random numbers. So I'm going to say here integers. I would like to generate integers from 0 to 100. So we just pass 100 for the range from 0 to 100. And then I would like to specify what is the size of my array that I would like to generate. Okay, so in my case, I would like a one-dimensional array only. And this array, let's say it contains 20 numbers. Okay, and here we're still having an error because we have forgot to say that this NP, this random, is coming from NumPy. Let's see why we still have errors. Yes, because here it's saying there is no size. We need to say size is equal to. Okay, now we're good. So we are calling this random number generator from our NumPy. Then you are specifying my array would be integers only, and the range will be from 0 to 100. And then I am saying, hey, I would like a one-dimensional array with 20 elements. Now, if I just print this random array, you'll see that I got 20 numbers, all in the range between 0 and 100. Let's limit this to 5. So this is from 0 to 5. So it's actually here saying 5 elements, meaning from 0 to 4, all right? So it's always the max number minus 1, as we have learned actually before. So now we are generating numbers between 0 and 4. And as you can see here, we generated 20 numbers right here between 0 and 4. Now let's say that I would like to have a two-dimensional arrays. Very simple. I just need to change the dimension right here to 2. Then I would get, this is the first dimension, and this is the second dimension. I could put any dimension I want. I could put any number of elements I would like to have in every dimension and any range that I would like to have, let's say from 0 to 9. As you can see here, I got 1, 2, 3, 4, 5 dimensions, and every dimension is initialized with values between 0 and 9. Okay. All right. Right now, we are going to talk about reshaping an array. Let's say you have an array that has 6 elements like that, and you would like to change it to two-dimensional arrays, and every dimension would contain 3 elements. Okay? How can you do that? Or the question is, why would you do that? There is a lot of applications for reshaping. Sometimes you have 2 different arrays, one of them coming from a library, and one of them is something you have created, and you would like to make them compatible with each other in order to do some operations on them. Well, in order to make them compatible with each other, they need to have the same shape so that maybe you can relate elements to each other or to any application that you would need. So, especially in data science, you would see that reshaping is actually very important. But this is why I'm just going to give you a small example on reshaping. So let's say you have this array right here and you would like to change it to a two-dimensional array, and every dimension would contain 3 elements. All you need to do is just say a new array, let's call it B, is equal to array dot reshape, and then just put your dimensions. So I would like it to be 2 by 3. Okay, 2 dimensions, every dimension has 3 elements. Now, if I print this B, you'll see that now it is a two-dimensional array. Each had 3 elements. So far, so good. Okay, let's make it 4-dimensional and every dimension has 2 elements. You would see that this is not possible, well, because all I have is actually 6 elements and I am trying to make it a 4 by 2. Well, I cannot really divide this 6 by 4, right? The number of elements here need to be divisible by the dimension I am giving. So if I extend this to 7, then 8, now I click on run, you'll see that now I have 4-dimensional array with 2 elements in every dimension. So when you're reshaping, you need to make sure that the shape is also consistent with the original dimension and shape you have, right? Otherwise, you will get this error, and it will say cannot reshape the array for this certain reason.
I'm sure that you've seen all of those cool image and video processing apps like Photoshop or maybe your regular mobile phone photo editor. Well, all of their functions is based on what I am about to teach you right now in these upcoming couple of sections. We will learn how to use Python to edit photos and videos and then export them. We will use a library that is called OpenCV, which is the most famous library out there for image and video processing. This library is not only supported by Python, you will see it in Java and C++. And since it is supported in Java, this means that most of your Android apps that uses image processing is using a chunk of this OpenCV library for sure. So it's a really important library to learn. I'm really excited to start this section with you guys, so let's get started.
And we are ready to start a new section here. And this section is called OpenCV Library. This is the most famous library for image processing. If we have any image that we would like to read and process in Python, this is the to-go library that we use. And we are going to cover a lot of stuff. We will be covering how to read and write images. We will be covering contour extraction, which is a very, very important topic, which means that if we have an image like this and we have some object, we will be able to actually, the algorithm here will be able to identify where is this object and make a contour around it like that. Then we can crop it and do whatever we want with this object. This is very important for object detection and then object recognition. We are also going to learn how we can convert images to arrays, because an image is actually nothing but an array of values. 1, 2, 17, 3, all of these are just values. Now, even if we have an RGB image like that, every channel or GMB would have their own matrices. So the green here would have its values, the blue here would have its values. So any RGB image, meaning red, green, blue image, it has these three layers, which are nothing but arrays. Now, there is also another type of images, which are grayscale images, which consist of only one channel. Okay, no R, no G, no B, just one channel, and every pixel can have a value between 0 and 255. Okay, so this is how we got white and black images. And in most processing, we would like to process these gray scale images because they give us the most information. Of course, after we do some pre-processing to extract if there is something important in the colors themselves. We are also going to learn how we can do operations on images, like how can we maybe flip them, okay? Or how can we invert their colors? And this would be really important when we are working with image detection and image classification. We would like to pre-process the image dataset that we have, which we will be talking about extensively when we go to the deep learning and to the AI sections. And we also need to learn how we can process video. A video is nothing but a chain of images. So we have image 1, 2, 3, and if we play them back at a certain rate, we would get a motion. So let's say the point was here, next frame point was here, next frame point was here. So if we play this fast, we would see the point moving like that. And we will learn how we can process video, and we will learn how we can do object tracking in videos. Meaning that if we have a video, we would like to be able to track an object in that video and see where it is going. Okay, so we have a lot of exciting topics to cover. Let's dig into it. Now that we have an idea on what is OpenCV and what we are going to do with it, let's see how we can download it. There is two OpenCV libraries. One of them is the official OpenCV, and then there is the contribution OpenCV. Contribution OpenCV contains more functions like the one we use for object tracking. So we will be installing that. All we need to do is open Anaconda prompt and say pip install OpenCV contrib -python. Run it and we should be good to go. And then we will be starting implementing some OpenCV code. Now, before we go any further in OpenCV, I would like to introduce you to some color theory. Now, why is color theory important? Because any image you see is actually consist of colors. Now, when we talk about what we call a grayscale image, this is the simplest type of images actually, because it only consists of only one color space, which is the gray color space. This gray color space starts with a value of 0 and it ends with 255. 0 corresponds to black. Imagine that you have a pixel here, right? Your screen consists of millions of pixels, and this pixel, when you give it a value of 0, it turns off. Now, when you give it a value of 255, it's going to illuminate all the way to the max, giving you the illusion that this color is white. Now, all the colors in between this space right here is going to be shades of gray. So do you know those old TVs? Those old TVs work on this color space, which is the gray scale. It consists only of colors like black and white, and all the shades in between them, which are gray shades. We can demonstrate this simply by going to Paint. Now we can demonstrate this easily here. Take a look at this. We are scanning all the colors from white all the way to black. This is the color space we have when we talk about grayscale images. Now let's move into color images. Any image that we have and we see, let's say here we have an image that consists of multiple colors. It could be an image of anything actually, but it is a colored image. A colored image actually consists of 3 layers. The first layer is actually the R, meaning the red. Then we have the G, which is the green. And then we have the B, which is the blue. Any colored image you see consists of those 3 channels. When we combine them together, we get this colored image, and we can get any color that we want using only R, G, and B space. So this space is only 1-dimensional, and this space is actually 3-dimensional. Now let us demonstrate this. Now if we go back to Paint, take a look here. R, red, green, blue. Any color consists of these 3 combinations. Let's say when we talk about green, you'll see that the green value is the highest, and there's a little bit of red and a little bit of blue. If I am to give red 0 and blue the value of 0, you'll see that I got a pure green. Now, if I say red is 255, green is 0 and blue is 0, I will get a pure red. Now, as we go to the shades of red, we'll see that more colors like green and blue are going to get into this equation, giving you this illusion of shades. See that? Now let's go to yellow. We'll see that yellow is consisting mainly of a lot of red and a lot of green and a little bit of blue. This is what yellow is. If we go to white, we will see that to form a white in 3 channels, we need to pass 255 for red, same thing for green, and same thing for blue, meaning that we give the maximum value for red, green, blue, and we get white. Now what happens if I give the minimal value for red, green, blue? We will get the black color. And what we described here is called the RGB space. There is multiple color spaces. We have the lab space, we have the HSV space. Each one deals with colors in a different way. But this is for the RGB space. In the previous lecture, we have covered the RGB space. Now what I would like to talk about is the HSV space. Now the HSV space consists of 3 channels as well, and they are called the hue, saturation, and value. If you work with Photoshop, or actually with any photo editor, you'll see that you can change the colors of an image either using RGB or HSV. Let's take a look. The hue is the one that will be spanning the whole color space. Let's try to simulate it. You'll see that the hue is the one that determines what is the color. Is it like reddish? Is it orange? Is it green? Is it bluish? Is it purple? So the hue is going to scan which color you want. Now let's say that we chose the color. The saturation, take a look here at the saturation. Take a look at this bar right here and at this line right here. What do you notice? The saturation is actually, after you have picked the color in hue, now you choose how saturated it is, meaning how reddish it is if the color is red. As you can see, the higher the saturation, the more red the color will be. Take a look here. We are moving between red and white right now by changing the saturation. Let's choose a different color. Let's say maybe this blue. If I move it, take a look at this ball here. It is moving between white and blue. So the saturation chooses the shade of the color you want. Now, how about value? If we already picked up the color and the shade, what's left? What's left is the value or the illuminance of that color. Take a look at this bar right now. You'll see that it is dimming down or lighting up. So this is like the lighting of this color. As you can see, the more value, the more bright the color will get. The less the value, the more dark the color will get until we reach black. Now you might ask, why do we need multiple spaces? Away from the photo editing capabilities like changing the hue and the saturation maybe will give you better looking colors. In some image processing applications, it's really important, for example, to try to separate the lighting. So let's say that you are doing some image classification of a ball, and you have multiple images of a ball being outside in the sun and being inside in a not really well illuminated room. You should be able to identify that this is a ball regardless of how bright the environment is. This is why analyzing such a problem with HSV will be much easier than RGB, because you can always separate until some degree the brightness of the environment from this V channel right here. And this is HSV. And we are ready to start OpenCV. First thing we need to do is just say import CV2. You don't say OpenCV, you say CV2. Now there is two versions of OpenCV. One of them is CV1 and CV2. And well, if you are reading some documentation and you see CV in the function, all you need to do is just add this 2 to it, because well, CV is not something we are using right here. Now, I have placed an image in this directory. So in this same file directory, I have some image. If you not sure if you are in the right directory with Spider, you can click on this folder here and just go to the directory that it contains the script and the images. Make sure that the script and the images are in the same directory. Okay, this is how to read an image and how to write it back. Okay, so reading and writing. I'm gonna say image is equal to cv2.imread and then just pass the name of the image as long as you are in the same directory. Okay, now if we run this, we run it no problem. Now how about rewrite it back? Let's write this image with a different name. So I'm gonna say here cv2.image write, and then we will give the name of the image. Let's say new logo.png. Make sure to add the extension as well. And then what variable image do we have? Since we have read the image, now the image is inside this variable. Now we can write this variable again with a different name and we would get the image again. So let's run this. Let's go and check the directory. And now you see that we have the same image, but with a different name. So far, so good. Let's continue. Let's say that I would like to display the image in a separate window. Now, as you can see, we are working with Spider with images, okay? That's okay, you can work with Jupyter Notebook, but I like to show you both environments all the time. So I'm gonna be saying cv2.image_show or imshow. Then what is the title of the window that we will open? Let's say logo window, you can name it whatever you want. And then what do you want to display? I would like to display this variable which contains an image. Now this is not enough. If you run it right now, you won't be able to exit the image until you break the whole program. So what you need to do is say cv2.wait key. You will wait a certain action here. And then when this action happens, you need to destroy the window so that you can close it. So I'm going to say destroy all windows. Now if I hit on run, you'll see that I got a window containing the image. That's really cool. Now if I close it, no problem. It will close without any issues and the program will terminate correctly. Now, let us see how we can convert an image into a grayscale. Now we have two ways to do that. We can do that while we are reading the image, or we can do that in a separate function. Sometimes we get images from datasets that we download from the internet, so we don't have the luxury of reading it from directory. We would be having it directly in a variable. If we have it in a variable, how can we convert it to grayscale? We need another method, right? Let's start with the first method. Here we are reading an image. This logo is in our directory. We have talked about this. Now we need just to add a simple parameter here. We will say cv2 image read or imread, then gray scale. As simple as that. Now, if I try to run this, you'll see that I have the image as grayscale. If I remove this, you'll see that I will be reading it as a colored image or an RGB image. Okay? Now, this is the first method. I'm going to comment this out, copy this, and delete this so that we can keep this line. What is the next method? The next method can be done by calling a method called CVT color. How can we do that? Let's create a new variable called gray image, and then we will say cv2.cvt color. We pass it the image that we would like to convert to grayscale, and then we specify the following. We say cv2.color bgr to gray. Now, OpenCV does not read the colors as RGB, it reads it as BGR. So the first channel is B, then G, then R. Other libraries like Pill, for example, which also is famous, will read the image as RGB. Okay, you need to put these into consideration because sometimes if you are reading from Pill and loading using OpenCV, you could get an inverted color image because of these channels not being in the same order. But anyway, let's convert this from BGR, which we have read from here as a colored BGR image, to gray. And then we would like to copy this, paste it here, and run. And now it's gray again. Okay, so we have two methods. You can choose in between. So far, we learned how to read an image and convert it to grayscale using two ways and then display it. Now, what I want to teach you is how can we binarize an image. Sometimes we would like to mask only the object that we have in an image. So if I display this right now, you'll see that we have gray colors and here white colors. How about we convert all the objects in this image into white and the background we keep it black. Binarization is very important process when we are pre-processing images for contour extractions in order to apply it for maybe object detection to know where is the object, or even for object classification when we do some masking, which we will learn later on in this course. Okay, so how can we do binarization? We need to apply something called a threshold. Let's add two variables here. One of them is called return and then a threshold. Okay, and then we will be calling a function or a method called threshold. Which image would we like to threshold? It's the gray image, right? We would like to binarize it and convert all the logo to white. Here it will be passing 0 and 255. I will explain these in a minute. Then we need to pass the parameter cv2.thresBinary. Now what does this say? It says that all the values that are equaling 0 or less in my image, which mean all my background, because black is actually corresponding to 0 and 255 corresponding to white. Okay, so all of these values that are 0, please keep them 0, meaning keep the background as it is. Now, what I'm saying here is any pixel that the condition here does not apply, meaning anything but background, just turn it to white. Okay? It is as simple as that. Now, if I try to show you guys this threshold, we will be getting the logo in white and the background in black. That is exactly what binarization is. Now, let me show you what was the values before and after binarization. To do that, we will be using the numpy unique function. So we need to say import numpy as np, and here we will be saying a gray numpy is equal to np.array gray image. So we need to first convert the image into a numpy array, then we can call print np.unique on this gray np. Okay, now we will be doing the same thing for threshold. We will be converting it again to numpy array and then just print the unique values. Let's execute this. Now take a look here. This is the first execution. Since we have a gray scale, we have multiple values ranging between 0 and 255. And we've seen that because we had a gray image when we were using this BGR to gray. A gray is all the shades in the range between 0 and 255. Now, after we binarize it, we only have two values, 0 and 255. See? This is exactly what we have done. We made the whole image containing only two values or binary values. Okay, let's learn a small trick on how can we rotate an image. Image rotation is very important when we are training some deep learning models because there is something called image augmentation, and we would like to create multiple copies of that image, each in a different rotation angle, okay? Also, we can use rotation when we are trying to process an image and just rotating it. It's like when you take a picture with your mobile phone and then you would like to rotate the image in the editor. This is the function that is used. Let's see how we can do it. I'm going to call this rot for rotation. Then I'm going to call cv2.rotate. I'm going to be passing the image. Then just say cv2 dot capital letter rotate underscore 90 degrees and then clockwise. Now, if I run this, we will be getting this image, but here we need to pass rotate instead. So let's pass rotate. And the image is rotated. We can also rotate this 180 degrees like that. As you can see now, it's upside down. Or we can even rotate it counterclockwise, so in the other direction. So this is all about rotation. It's really a simple function. In some cases, we might have some NumPy arrays that we would like to convert to OpenCV. Or in some other cases, we would have artificial data images that are generated by NumPy array, and then we would like to further process it by OpenCV. And now we are going to learn how we can do that. We will be learning how to generate artificial images. Could be any image, doesn't really matter. And we will see how we can convert it into a format that OpenCV can really process. I'm going to be importing the following from numpy.random import default underscore random number generator, okay? Because we will be generating some random data. I'm going to create an image generated by NumPy. So I'm going to say np.random underscore default underscore RNG. We have learned about random number generators in the beginner introduction to Python in the first few modules. Now we will be passing integers to, and the size of this image will be 200 by 200, and this image will have a type. dtype is equal to mp.unsigned integer 8-bit, okay? So I'm generating an image that is an 8-bit image, size 200 by 200, using NumPy. Now, if I try to display this image, it will give me an image like that. Okay, but this is a black image. So let's process it a little bit further. We are going to say image is equal to mb.array, and then we will say image multiplied by 255, and then we will be running this again. And as you can see now, we are getting a noise image that looks like those old TVs with antennas, and that's really good. We are now able to create an array of random values and just display it using OpenCV. Now, it's really important to pass this parameter because without it, we will be getting this error. It's really important that you specify what is the type of the image you are generating. If you don't have the luxury of generating the image randomly, and maybe you are getting the image from some NumPy array from somewhere that is you did not generate yourself, then this parameter won't be here. You can just simply convert this to a NumPy array and just pass it a type. So if you have a random NumPy array that you would like to convert into something that OpenCV can deal with, just get this NumPy array, put it in a casting np.array, and then just give it a type. Then you can use it directly with OpenCV. So whenever you see this error right here, CV32S or similar ones, it means that your NumPy array does not have a type that your OpenCV can work with. Let us talk about how can we generate images and stack them together horizontally or vertically. Now, sometimes this is important if we would like to compare two images next to each other. So let's see what is the NumPy technique to do that. While learning that, we will be learning also how can we generate an image that is totally white and another image that is totally black. Let's create image number 1, and it will be using NumPy, and we will be using the method called 0. Now zeros will create an array with a certain size which we will provide, let's say 40 by 40 pixels. Well, let's specify that it is NB unsigned integer 8 so that OpenCV can process it. And well, let us display it. As we can see, we got this small black image. Okay, how can we create a white image? Since NumPy zeros is going to create an array all filled with zeros corresponding to the color black, let's see how can we create something with a custom value. Well, because the value of white is 255. Let's see what can we do. Image2 is equal to numpy dot full. Now full is a method that we can use to create an array filled with a certain value. So here it will be 40 by 40, and let's say that it is filled with 255 and of course mp dot inside integer 8. Let's remove this n. Okay, now let's display image 2, and this is image 2 and it is a white image. Now we can also use this one to create a black image. So we can substitute this zeros with full as well by just passing 0 here instead of the 255 corresponding to white. So if we run this, it's black right now. As you can see, we have two methods, and I just wanted to show you how you can implement both methods. Black and white images are very important to create backgrounds or if we are doing some masking. So these kind of black and white images are pretty important when it comes to image processing. So now let's stack two images on top of each other. I'm going to create a variable called stack vertical, and the method is a NumPy method that will be doing the stacking, and it's called vstack, short for vertical stack. It will accept multiple arrays and we pass them as a tuple. So we open a parenthesis and just put our images in. Okay, now let us display that. But before we can display it, we would like to convert it to this unsigned integer. We cannot really pass this into the vertical stack. So what we're going to do is we are going to cast it just the usual way. We say mp.array, we pass stack var, just pass mp.u integer for unsigned integer and a. Okay, now if we run this, we will see that we have two pictures stacked on top of each other. Now maybe let's change this picture to white, and that's good. We have them both now. We can stack as many pictures as we want. Let's stack another one. Let's call it image 3 and just pass here image 3. And as you can see now we have three pictures stacked on top of each other. Okay, now there's another method to stack all of these horizontally. So we're going to say stack hor is equal to mp.hstack. And I'm just gonna copy these. And I'm gonna display this stack horizontal. So the only difference is this is hstack and this is vstack. Now if we display this, we will see that all the pictures are stacked horizontally. Well, that's good. What I would like to explain now is something called contour extraction, and this is a very, very important topic in image processing. Let's say that I have an image, doesn't matter the size, and this image contains multiple shapes. Or let's start with one shape, one simple shape, a circle. And this is a filled, colored circle. Okay? Let's take the classification problem. Classification problem is to be able to identify objects in an image, then being able to tell that this object is a ball, this object is a lamp, this object is a mouse, a keyboard, doesn't really matter. The point is to identify what is in this image. Okay? Now, the first step to do that is to actually be able to locate where is the objects themselves. Let's say that we are able to locate that our object is here. Now let's say that we have located our object and it is right here. How can we extract it? The extraction is called contour extraction here. Contour is this area that is surrounding the object. So it is the boundary of the object. If I can't find the boundary of the object, then I have found the object. Then I can take these boundaries and then pass them to a classifier. Now let's say that this image contains more shape, like a triangle, a square. Now I would like to be able to extract the boundaries of every object I have. Now these boundaries will be stored in a list that contains all the coordinates of these. Okay, so you can imagine it as containing small lists of x's and y's for every single contour that I have. That means I will be having a large list like this for every object I have. I have 3 objects and they contain all the xy. Now, this is the big picture. But how can we achieve this? We need to do some pre-processing to be able to eliminate the background and focus only on the objects. Okay? Let me give you another example. Let's say that this image here has this background which is a black background. Okay? I would like to be able to create a very high contrast between the object and the background. What do I mean by contrast? Well, if this object somehow is colored white, every single object, then this contrast between the background and the object is really large. Why? Because there is a huge difference between 0 being the color black and 255, which is the color white. So this huge difference between the color spectrum, we call it contrast. The more the contrast, the easier I will be able to tell that this is an object and this is a background. My goal would be to pre-process this image so that I have the objects in white and the background in black. Okay, this is why we have binarization. Do you remember we have talked about binarization? Binarization is to choose a threshold, if that is applicable, in order to make the image looks like black and white. Okay, now there is tons of research, tons of algorithms just to solve this problem. But I'm trying to simplify it to you as much as possible so that you can understand why do we need to pre-process the image before we can start extracting contours. Because if the contrast here is not high enough, let's say that maybe the background here is containing some gray or close to gray, maybe the contour then is going to be labeled like this. So we will be having a circle here and here some noise coming out of it, and the object will not be contoured correctly, and the classifier then might not work as expected. This is why we would like to define the edges as they are on every object by creating high contrast. Alright, now we are going to solve a small exercise in order to be able to extract. Alright, let's see how we can extract contours. As I said, the first step is to pre-process the image. We have written this code before while we were learning about image read and gray conversion and thresholding. Well, this is exactly the kind of pre-processing that I would do for a simple image like the logo here. Okay, so if you did not watch this video, I recommend you to go back and watch them, but I will briefly explain them. Here we are reading an image, we are converting it into a grayscale, we are converting it then into a NumPy array. Then we are thresholding it by converting all the colors other than black to white. And then we are reconverting this to a NumPy array, and then we are displaying it. Okay, now if I run it, you'll see that I have the image like that. Now let's put the images before and after, like we learned in stacking, just to be comparing quickly. I'm going to be passing here vstack is equal to mp.vstack, and we will be passing the images as a tuple. Which images I would like to pass? Well, I would like to pass the original one and also the threshold one. Now let's convert vstack. So we have vstack is equal to mp.array and then vstack. And here we will be displaying vstack. Let's run this. Yes, it is complaining that all the images need to be the same. since this is colored and this is not colored, we won't be able to stack them like that. So maybe we will be displaying the grayscaled one instead of the colored one. And as you can see, after grayscaling, it was like this, and after thresholding, it looked like this. Now we are ready to apply an algorithm on this image here in order to extract the contour. Let's see. Let's go here. And the method we are going to use to extract this is called find contours. We are going to say contour and h. It will return two parameters. We will be concerned only with the contours right now. And we are going to say cv2.find contours. Then which image are we going to process? Well, the threshold image. So this is thresh 1. And then we need to pass cv2.ret tr_cccom. Then here we need to pass cv2.chain approx simple. Now what's all of this? Here we are passing the image. Here we are specifying how we would like to return those contours. Would we like to have relationships between the contours? Like we would like to, if we have two contours inside each other, would I want to say that the outer contour is the parent and the inner one is the child? So this is related to how would I like to return the contours. For now, I'm not going to be concerned with this parameter. We will just pass it as it is. And here the method that we would like to apply in order to extract the contours. It's like what is the algorithm you would like to use in order to extract the contours. So this is the one that we would like to use. This is the standard one. And that's it. Now, if I try to print contours, let me just comment this out a little bit and close this. Let's run it. You will see that I got a huge list of coordinates. Now, let us see what is the length of this contour. We will be printing len contours. We will see that the length of these contours is 12. Well, how can we represent them? How can we draw them? We will see how we can do that in a minute. Now let's talk about how can we draw these contours. There is a function in OpenCV that is called the draw contours. All we need to do is just say cv2.draw contours, and we need to pass it the image that we would like to draw on, which is the original image. So we would like to take the original image and draw the contours over it. Next, you need to specify where is the contours, which are right here. So we just pass contours, and here we would pass -1 because we would like to draw all the contours. If I want to draw a specific index in the contours, I might pass 0, 1, 2, or whatever, but I would like to draw all the contours, so I would be passing -1. And then the contour, the outline or the border of the object need to have a color, right? Because we are drawing it. Let's draw it with 255, 0, 255, and then the thickness of the line we are drawing. Let's pass 1. Now we will be showing the image. Let's remove this. So now let us run this. Now if we take a look, we will see that we have drawn this like that. Let's put them next to each other. There is my stack. I would like to take this stack, put it here at the end, and I would like to draw the original image. And let us create two versions of this. I know this is not really practical, but I just wanna draw them next to each other. So this will be original, okay? And now I would like to draw image and original next to each other. This is my image, and this is my original. Now let's draw the stack. And as you can see, this is the original image, and here we have detected where are the contours of this. See, they are in purple, encapsulating every object we have in here. See, the background here does not have any contours. Only the objects that we are seeing in the image are having contours. Now, let us find a method to crop this text here and every single one of these separately and draw them on a separate image. Because this small exercise is very important, because when you have an image with multiple objects, you would like to be able to crop every individual object and maybe then pass it to a classifier to tell you what is this object exactly, or maybe to crop it and store it as a separate image. So this exercise can be applied to a lot of projects out there. So let's take a look. How can we do that? So far, we were able to contour all of our pieces right here. Now, let us separate them and put every single letter in a separate image. Okay, let's do that. What we would like to do is to crop this contour, fill everything inside it, and just save it on a separate image. But how can we exactly do that? I'm going to be creating a list called image list. All right. Now this image list will contain all of my separate images. We are going to iterate over our contours. So I'm going to be saying for I, C, and T, enumerate contours. Okay, I'm using enumerate because I need a counter and I want all the contours that are inside this contours variable. Okay, what's next? Let us create empty images. Now these empty images, we are going to use them in order to crop from the original image one object at a time and then put that crop symbol on the new empty image. How can we create empty images? Remember, I told you that this is an important topic because we use it to solve such a small problem. So we have image is equal to mp dot zeros. I would like to have a black images and then draw over them. Now first we would like to pass the shape. What is the shape here? Well, the shape will be the same as my original image shape. It's important to have consistent shapes right here. So I'm going to be saying image.shape 0. And this is of course inside the tuple. Then we have image.shape 1. So we have the height and the width of the image passed here. So we don't have to specify them ourselves. We will just go to the image and get the height and the width. This will be the size of my empty image. Next, I would like to specify the type. So it is mp.unsigned integer a. It's giving us an error here because we did not add in. Okay. Now very good. Let's continue. Now let's draw the contours. We are going to say cv2.draw contours. Where would we like to draw them? I would like, see here, I'm extracting every single contour out of here. Every object we had, I mean the individual letters, the OpenCV symbols, each of them is stored individually in this contour. So I am now extracting them one by one. Okay, I'm gonna be drawing on the empty image I created and I am going to be passing the contours one by one. Now let's pass it like that. I would like to draw all the contours inside the CNT and I would like to draw everything in white. And we would like to pass -1 here because I would like to fill if the contour is closed. Remember, we were reading the outer bound of the contour, right? What I would like to exactly have is that the contour is filled as well. I don't want only the outer bounds, but I want the whole object. So this parameter is used for filling. Now that's it. Since we have around 12 contours, they won't fit if I fit them horizontally or vertically. You can write a function that will display a grid of images instead of only horizontally or vertically. But for the purpose of this lecture, I'm gonna be just splitting these contours into two sections, okay? This is how we're going to do it. We're going to say im to show, images to show 1 is equal to mp.hstack and just pass it the image list as a tuple, of course. Let's say between 0 and 7, okay? And I'm gonna be doing the same thing for the second part. I'm just dividing these images into two sections. Here I'm saying I want images between 0 and 6. Even though it's 7, we take it the outer bound -1. And here we would like to have the images between 7 and 13, meaning between image number 7 and image 12. Sorry, here 13, it means 12. Okay? All right. Now let us show two windows. In order to show two windows, it's important to give them different window title. Okay, so this is 1, this is 2. And here is my 1, image to show 1 and image to show 2. Okay, now let us see what we are going to be drawing. Oh, okay, we forgot to append as well. So let us append. So we need imlist. Right now the list is actually empty, so we need to append image. Okay, now let's run it again. And here we go. We have two windows containing all of our letters. We have open, we have O, P, we have the E, we have the N, and we have the symbols, we have the CV, but we also have some noise. As you can see, we have very small symbols over there that are noise. Well, we are going to handle these in the next tutorial, but for now, I wanted to show you what is the difference between passing the contours in a list and without a list. Now, if I don't pass it in a list and I try to just execute, you'll see that I'm not getting the full contour. I'm getting an open contour, points that are not connected to each other. And since they are not connected to each other, the whole field contours parameter right here won't work as expected. So it's really important that you pass them as a list so that all the points will be included. So here we will return it as a list. Let's close the windows and let's run again. And we're good. Now what's left is to get rid of these small noises. Let's do that. Now, how can we filter those small images that we were reading? We will be filtering them by size. There is a method in OpenCV that helps us to measure the size of a certain contour area or measure the area of a certain contour. It's very simple actually. All we need to do is just say area is equal to cv2.contour area like that and just pass it the contour. Now, how about we print all of those areas? And I don't want to be showing anything for the moment. As you can see, we have some really large objects, and at the same time, we have a very, very small object. How about we get rid of those super small objects? We can set a threshold by just observing these areas right here. Let's set the threshold to 71. Here's what I'm going to do now. I'm going to say if area is larger than 71, then I would like to do all of these things. So I'm not going to be appending any images or creating any new images unless the area is larger than 71. Now, if I run this, I'm going to be having problems because the limits here are not correct. How about we set these limits dynamically? So we could say bound1 is equal to len of image list. So we get the length of image list and we divide it by 2. And then we have here bound1, and here we would be having bound1. Right? And what about this higher bound? Well, bound 2 would be just the length of this plus 1. So this will be my bound 2. Okay? So we divided this list into 2 sections. We added the bounds and we got the length of the whole list we have, whole list of images we have extracted. And this is my bound 2. Okay? Now let us run this. And also we need this to be an integer. Okay? So it's important to be an integer, and we're good. Now let us start showing the images that we have cropped. And here are my images. It seems that we have cropped more letters than we need. So let us decrease this threshold to 26. Okay, so it seems that 71 is a letter. So let's decrease it to 26 and try again. Here we have open and we have the CV. It seems that we still have a little bit of noise because we have 4 letters for open and CV, but here we have 5 letters. That's totally okay. Now that we got rid, let us start the masking operation in order to crop the actual symbol and not the black and white one. Alright, what I want to explain now is masking. Let's see what is this concept all about. Let's say that you have an image. And again, I'm going to be taking a very simplified object in it, like just a square. Now what we have done so far is taking this image and then drawing it like that, and then using contour detection to get the image to look like this, right? So we got just a white square. Now, how can we get back and just crop the original image, right? Because yes, we used contour detection. Yes, we have created this contour around it and we filled it. So now we have something that we call a mask. Because why do I call it a mask? Because if I take these two images and just put them on top of each other, the squares here are going to be matching each other, right? So this is a mask and this is my original, right? If I put them on top of each other, this square will match this square. Now, that is the whole point of this operation. Let me jump to something else for a moment. There is something called the AND logical operation. And what does this operation do is that if you have 2 bits, it's going to calculate the AND bitwise operation of that. What do I mean by this? Let's say I put 0 as the first input and 0 as the second input. The result here will be 0. So this is A and this is B. If my first input is 0 and my second input is 1, I still would get a 0. If this is 1 and this is 0, I would still get a 0. Only if both of them are 1, I would get a 1. So this is the AND bitwise operation, and it says that only if A and B are 1, then the output should be 1. Okay? Now, what does this have to do with masking? This is what masking is about. This is one technique of masking. Let's say that we have an image that looks like this. And here, this image is 3 by 3, okay? And there is only one box that is filled here, okay? So this box has a value maybe of 255, okay? Now let's say this box have some value, doesn't matter what it is, let's say 21. This box has a value of 23, this is 107, 2, 3, 0, 251, 125, doesn't really matter. This is my original image. Now, let's say that we used contour detection, blah, 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 and now we have a mask. And this mask is only the middle box. Okay, so this mask is also an array. It's the same thing. And it has values here. Here we have 1 or 255 or whatever. And here all of those are zeros. Remember that we were cropping the object and we were putting it on a black image with all zeros. Now, how about we take the AND operation of these two images? Okay, the result is going to be every pixel will be AND with the corresponding pixels, because this original and mask have the same size. This is also 3 by 3. If we put them on top of each other, every pixel will be AND with its corresponding pixel. So this one is 0. Anything ending with 0 will end up being a 0, right? So let's put a result matrix here. So now this pixel with this pixel, we're going to get 0. Everywhere where it is 0, we will be getting 0. So it's all around here is 0. Now if we add these two numbers together, we are going to get the original number here, which is, let's be it 255. So what did we do? Now, this image that we have cancelled everything around it, and we got only the one that we have masked using this mask. It means that we got back to the original image. It means that we only have now this symbol right here. We don't have the white image anymore. We have the original image, and we cropped only what the mask wants us to crop. This is how, if we have an image with multiple objects, we create a mask for every object, then we use bitwise AND. By using that, we would get images of the separate object. This is not a mask anymore. This is not a mask. This is the original image. Let's see how we can implement that. Now that we have explained the intuition behind masking, let's implement it. I'm going to create a new list called masked images. Okay, this is the images after masking. And here I'm going to be calling a variable masked is equal to cv2 dot. We will be using the method called bitwise underscore and. This is an OpenCV method. You just need to specify. Since here we have only one source, we need to pass image one more time, and then we need to specify the mask. So here we have mask is equal to im, right? Because here it's the black and white image is the mask, and I am masking it with the original image. Now I can extract every single letter and these symbols. Next, let me append this. So I'm going to say masked img.append masked. Okay, now let us pass masked instead of image list. Masked image, and here as well. Let's run this. And as we can see now, we have separated everything. Now, each one is a separate image. Except for this small noise that we have here, well, we got all of our images. Now, it's really not unusual to get noise. And usually, let's say if we are passing these to a classifier to classify something, in the classifier we would have a label for noise where we can throw away all the things that don't matter. So we don't really have to process everything 100% in OpenCV. Usually we use after algorithms in order to do that. But so far the results are pretty good. This is exactly what we are looking for. We can additionally, if we want to, save the images separately. Well, we can just say here cv2.image, right? Just specify the name. Let's say letter plus, let's convert I to string so that we don't override the images with the same name. This is I plus .jpg, and then let's pass the masked. Let us comment this out. Let's see if we can write these images directly, or do we need something else? And we got no error, so let's see those images. Now if we take a look here, we have those as separate images. We have decomposed this image we have here. That's great. What I would like to talk about right now is video processing. And video processing is really similar to image processing, but well, it has more things going on in it. Now, if you think about it, a video that is playing multiple frames is nothing but multiple pictures that are stacked together and are played at a certain rate. Okay, now your standard mobile phone can take videos, let's say at 30 FPS, meaning 30 frames per second. It means that every picture here we call it a frame. It's just an image. It means that every 1 second we are playing 30 of those images. This is image starting 1 and this is image 30. And this will be spanning for 1 second. So if we would like to process a video, we have to process every individual image. Now some phones can maybe record in 60 FPS and some advanced cameras can go to 1000 FPS. It means that we pass 1000 images per second. This is the essence of slow motion. Slow motion is a lot of images being played within a very short amount of time so that you can capture the movement in details and you get no blurring when you're doing that. Now let's see how we can process a video using OpenCV. Now let's see how we can read a video using OpenCV, because the first step in order to process it is to actually read this video. I have here a very simple video. It's just this logo we were processing, and it is moving to the right and just moving back to the left. Okay? So we want something simple to start with. How can we read this video? We need to import OpenCV first. Then let's add the path to this video. Let's say that the video is in the same directory as our Python script. Okay, and let's just put the name of the video. It's called logomotion.mp4. Now we need to create an instance of this capturing or this video. So we need to say cap is equal to cv2.video capture, and we need to specify where is the path. Now we will be creating a while loop or an infinite loop because, well, we need to read all the frames, right? So this is why we need a loop. We will say while cap dot is opened, meaning that as long as this video is opened by our program, we are going to continue looping through this video and extract the frames. So is opened is actually a method for OpenCV, and it is used to make sure that as long as the video is open, we can do some stuff. Now we need two variables. One of them is called read and the other is called frame. We will explain these variables in a second. This will equal to cap.read. Now here is what's going to happen. Read is going to return the frames. Remember the images we've talked about, that the video is a chain of images? We will be reading these frames one by one, storing them in the frame in every while loop, and this read is going to return true as long as we have frame. Now when we reach the end of the video and we try to read a frame, we have nothing else to read, right? Because we don't have any frames because the video has reached its end. So this read will return false to us the moment we have no more frames to read. And it's a very important indicator because we're going to use it right now. We are going to say if read, meaning as long as read is true and as long as we have frames, I would like to show those frames or images. I'm just going to use image show. I'm going to call the window frame, and I'm going to be showing the frames or the images one by one in every single loop. Now, once we reach the end of the video, what are we going to do? I want to break out of this loop. Okay. Once we're done and we broke out of the loop, we need to release the cap. Remember here, we have opened the file and we were executing this as long as it's open. Now we need to close things after we are done. We need to say cap release, meaning that don't hold the capturing anymore, just release it so that does not hold anymore. This condition will not hold anymore if we try to rerun the program a second time. Now we need to destroy the windows. So we need to say destroy all windows so that we don't get stuck, because here we are showing an image, and as we are showing normal images and we were just waiting for a key and destroying the window, we need to do the same thing for videos as well. And by talking about wait key, we also need to wait for the key here. So we will say cv2.wait key 1. Okay, now let's play this, and it is playing. All right, so this is how we read a video. Let's see if we can apply the techniques we have learned in image processing into video processing. I mean, since here we are decomposing the video into a series of images, maybe we can take every image and just process it as we are processing a regular image. Let's try to convert this video into a black and white video. So we will have frame is equal to cv2.cvt color. Then we have the frame. Then here we have cv2.color underscore pgr2 gray. Okay, let's see if this will make any difference. If I run it, as we can see now, it's black and white and it is moving. Now, how about we rotate this video? We have learned about rotation as well. We can say here frame is equal to cv2.rotate. Then we will be passing the frame and the parameter. Let us flip this clockwise. So here we will have rotate underscore 90 underscore clockwise. Now let's see what's gonna happen. As you can see, we have rotated this 90 degrees. Well, let's comment out this rotate and maybe flip it. Now there is a function for flipping as well. Sometimes when we take a video using our camera, the video just comes out flipped, and sometimes we really don't like that and we would like to flip it back. The way to do this is very simple. All we need to do is just say cv2.flip, pass what you want to flip, which is the frame, and here you have multiple options. You have 0, meaning x-axis of flipping. If we pass 1, this would be a flip on the y-axis, and if we pass -1, it means x and y flip at the same time. Okay, so here let us flip this around the y-axis. Let's pass 1 and see what's gonna happen. As you can see, it is flipped around the y-axis. Now, let's try 0. Now it's flipped around the x-axis. If we try -1, we will be flipping it in all directions. That's really great. So this is how we can process a simple video. So right now, let's explain how can we change brightness, saturation, and also the hue of our image. Now, we have talked about HSV color space before, which is a hue, saturation, and value. Now, let's see what kind of algorithm would we like to apply in order to do that. Let's say that we have an image, and well, let's assume that we converted this image into HSV, okay? So this is my H, this is my S, and this is my V. And this is all my image. It's the same image, okay? When we convert from one color space to the other, we would be getting an image for every channel. And that makes our job easy. Let's say I would like to change the hue, which means I want to shift the colors of all the image. Well, now here I will be having values for a hue, and these values are between 0 and 255. This goes the same for saturation and value. They have this range. Let's say that the value here is 120, here it is 5, here it is 150, here it is 12, 71, and maybe 91. Okay? Now, if I want to change the hue, all I need to do is to go and add a hue value to this array. And then we recombine all of these arrays together and we get a new modified hue picture. Okay? But how can we do that? Let's say that I would like to increase the hue by something like 100. Let's say that I would like to increase the hue by a value of 200, okay? I just want to increase it to the maximum. If I try and add 200 to all of these values, I would have an issue because here, by then I would get values here that are higher than 255. And that's something that I really don't want. What can we do to resolve this issue? Well, we would create a variable, let's call it limit, and this limit will be 255 minus whatever value I have. So this is my value, and then we will do the following, okay? We will have limit equals 255 minus value. Now this is the limit. This will equal to 55. Now if I go and add 55 to any of those, I won't have any issues, right? Now what is this indicator? This will give me an idea on the pixels that would be out of range if I added this 200. Remember, my goal is to add 200. Take a look here. This is an indicator that any value in this matrix that is larger than 55 is going to give me an issue when I add this 200. Let's try. 120, is it larger than 55? Yes. If I add 200 to it, it would be 320. So yes, the indicator here worked. Let's take this value. Is it larger than 55? No. So it won't make a problem if I add 200 to it, right? Because 200 plus 12 is 212. Same thing for the 5. Now the 71. Is 71 larger than 55? Yes. It means that if I add 200 to it, I would be out of range because I would be getting 271, which is larger, right? 91 is the same and 150 is the same. So what would I do next is I would come here and say update all the values in this matrix that are larger than 55 and just give it a 255, right? Because we are going out of range, it only makes sense that we assign it the largest value. So my array right now would look something like this. This is my H array. This value will be 255 automatically. This will stay 12. This one will stay 5. This will be 255, 255, and here 255. Okay? But what about these values? What are we going to do with them? Well, here comes the next part of the algorithm. We are going to say increment all values in the matrix that are less or equal to 55. Increment it by value. What is value? It's 200. So I'm going to come here, and this will be my next part of the algorithm. It's going to stay 255. This one is less than 55, so I'm going to add to it the value that I want to assign, which is 200. So this will be 212. This is going to be 205. These will stay intact. You can apply the same thing for saturation and for value. This is how we modify images and change their HSV values, which we can see in any photo editor, be it on your phone or be it Photoshop, be it anything. This is how it is done. Now, let's say that you did not change this to HSV, you changed it to RGB. You see, some editors give you the ability to change one of these values. It's the same thing. We would be decomposing the image into RGB, and then we would be applying the same algorithm for the R and GMB channels. Okay, now let us code this function that will change the HSV values. I'm going to create a new function here because it will be easier to work with the frames like this. And I'm going to call it HSV change, okay? It will receive the frame and it will return the frame. Now, it will also here receive the value that I would like to add or subtract from here. Let's first create the variable limit that we have talked about. This limit is going to equal to 255 minus this value. Next, let us convert this frame that we have into HSV, right? This is the most important step here. We are going to call this HSV frame is equal to cv2.cvt color, and then let's pass the frame and cv2.color underscore bgr to HSV. So we are taking the RGB value or the BGR value and converting it into HSV. Now let's split this. So we have HSV is equal to cv2.split HSV frame. Now this frame will be splitted into 3 channels. Let's add the option here of what the user wants to do. Let's add it as a key. Now, if this key is equal to H, meaning that I would like to modify the H, I would do the following. H, open the list or the array, H larger than limit is equal to 255. The same as we have explained. We are checking all the values that are larger than limit and replacing it with 255. Next, we would like to update the values inside this H as well. So we will say H less or equal to limit is actually plus equal value, meaning that all the values that are less than the limit will be added the value here that we are passing, okay? We have talked about how this algorithm works already. Now let's continue. Let's do the same thing for all the keys. So if the key is equal to saturation, then I would like to change the saturation channel. Now same thing would be for the value. If the key is equal to value, I would like to change the values for all of these. Now, we have changed the HSV values. Now it's time to merge them back. How can we do that? We just used a function called merge. So we will say HSV frame is equal to cv2.merge, and let's pass them as a tuple H, S, and V. We are recreating the image after we have decomposed it. And now we need to reconvert it to PGR or RGB. So we will say frame is equal to cv2.cv2color, and then here we will say HSV frame and the converter, which is cv2.color underscore HSV to BGR. And then we are returning the frame. Okay, now let's comment out these that we have used before. We don't want to flip, we don't want to do anything. We just want to change HSV. So we're going to call HSV change. We will pass it the frame. Let's say we want to add 50. And let's say we are changing S value. Okay, let's test this out now. We have changed the saturation. Let's increase the saturation to the max. As you can see here, we can see that the saturation has changed. How about we change the hue to the max? We will see that all the colors were distorted, and this is what we are expecting when we change the hue. Let's change the value to the max. As you can see, the whole video here was distorted because the value is too large. Let's increase it by 100. Well, you can see that the background as well, all its values are changed. Well, this is good. Now we can do the same thing for RGB as well. Right now, you have edited your video, you have done some image processing on every frame, and you would like to export it and save it. Well, let's see how we can do that. The first thing we are going to do is to get the size of or the width and the height of our frames. The way to do that is by saying width is equal to convert to integer cap.get, and then we will be passing cv2.cap underscore prop underscore frame underscore width. Okay, this is an OpenCV function that will get you the frame width and here the height. So we're gonna change width here to height. And we're going to change width here to height as well. Okay. The next thing is we need to create the extension. So what is the extension we going to save our video in? Let's say we want to save it as an MP4. To do that, let's just call this EX and we are going to say cv2.videowriter underscore 4cc. And here we are going to pass the following star and then we open a quotation and we say MP4V. Okay. By that, you are preparing how are you going to encode all of your video frames. Next, we're not done yet. We are going to call a variable here out, and this out is going to equal to cv2.videowriter. Now you need to name your video. Let's call it logo edited.mp4. Next, you need to pass this extension we have talked about. We pass EX here. Then we pass number of frames. Let's assume they are 20. And here you need to pass the width and the height as a tuple. So here we have width and we have height. So here we have prepared the encoding of the video. And here we are creating a video writer. Now, we are going to be writing to this video writer. So here, after we are done processing our image, after we are done with all processing, we are going to say out.write. This is our out. And we are calling the method write on it, and we are passing a frame, okay? Now, after you are done, you need to release this out or this video writer. So we're going to say out.release, okay? By that, we are writing a video. Let's execute it. Now let's go and check. This is my logo motion edited. And as we can see, this is the edited version. By that, we can import videos, edit them, and re-export them, and we can create a simple or even complex video editor. Alright, so we are going to have a lot of fun in this new section. In this section, we are going to learn about the various fields of automation. Automation is to let the computer do tasks that we really don't want to do. So if you have some really boring job or you have some daily tasks that you must do on the computer, you can easily automate it with Python. Now there is GUI automation that is responsible for automating applications. There is web automation that is responsible for automating web pages or web-based applications. And finally, we have a screen-based automation. It's like you are going to search for certain elements on your screen, and when you locate it, you are going to click on it and then do stuff to it. So we are going to talk about all of these three types. We will also learn about voice activation based commands, meaning that we can tell the computer using our voice what to do, and then the computer is going to execute all the commands that we say. So we are going to do some really cool applications. The first thing we want to do is to install a couple of libraries. I have Anaconda prompt open right here, which you can open it from Windows as usual. And we have those libraries that we need to install. So first one is called pip install speech recognition. Now speech recognition is what you are going to use to send voice commands to your Python script, and then it will execute whatever you said. So this is the first library that we need. Next we have PyAuto GUI. So we'll say pip install PyAuto GUI. Now this library is responsible for automating what you see on the screen. We are going to take images of the things that we would like to click on, and then this automation tool is going to be comparing this image to whatever is on the screen, and it's going to click on it. We will see how to do that step by step later. But first, let's install it. Next, we need something called PyAudio, which is important if we want to work with speech recognition. So this is PyAudio. And we need to add pip install. And finally, there is another dependency that we need, which is called PyTTSX3. This is the last one. So after we install all of those libraries, we will be ready to start automating some things using Python. So let's get started. Let's write some code about speech recognition. We are going to activate our microphone to receive our voice, and then this voice will be converted to text and it will be printed out. So it is like a voice to text conversion. And this is the basis of how can we send commands using our voice to a computer. All we need to do is send our voice, and then we need some voice to a text conversion. Then we will take this text using Python, and we can do with it whatever we want, right? Because the moment we have text or strings in Python, we can execute any function we want. So this is the whole basis of this voice recognition. Let's start by importing speech recognition libraries. So we have a speech underscore recognition. We're going to say as SR for speech recognition. Then I would like to define a function which is called speech to text. Now, we need to create an object for this recognizer. How can we do that? Well, I'm going to say voice commands is equal to sr.recognizer. Now we will be using this object in order to listen using our microphone. How can we do that? Well, we'll say with sr.microphone, and we will say as source, meaning that we will be using this microphone as a source. Now we are going to say listening is equal to voice commands dot listen. What are we going to listen to? We will be listening to source, and we need to set a timeout. So the microphone will be ready to be listening to your voice for a certain amount of time. Let's give it 5 seconds. So I'm going to say here phrase underscore time underscore limit is equal to 5 seconds. So what did we do here? We create a recognizer object, which we will be using to listen. Then we opened our microphone, and now the microphone is recording to the source. And we used this recognizer and our microphone together to listen to whatever we are saying. Now what we would like to do is we need to recognize or convert what we have said into a text. And there is a method to do that, which is called recognize Google. So I'm going to say here command is equal to voice command dot recognize underscore Google. Now what would we like to convert? Remember now this listening is a voice right now, and I would like to convert it to a text using recognize Google, which will receive this voice and convert it to a text command. So I need to pass listening here, and I would like to convert everything into a lowercase. So it will be easier to deal with the commands we are using, regardless if we have capitalized letter or not. So I'm going to say here lower, and this will convert everything to small letters. Then I would like to return this command. Now, this program is not safe yet, because if I say a word that is not recognized, this program will crash. So let me test it out really quick. I'm gonna come here and just say speech to text. Now if I run this, hi. We got an unknown error here. And the reason is, it did not recognize what we have said. Let's try again. Hi, hello. As you can see now, it recognized what we said and printed hi, hello. But as you've seen, there is scenarios where it won't understand what we said and the program will crash. So the next step is to resolve this issue and create a safe program. So as we said, we are going to create a Python program that is safe whenever we have an error. The way to do that is by try except syntax, right? We have learned about that and now we are going to use it. Now, after we listen to our command, we need to make sure that the command is recognizable by Google. So I'm going to say here try and put these statements in try. And then if there is an issue here, meaning that the command is not recognized, I'm going to be saying except, and there is an exception that you can find coming along with this library, which is called sr.unknown value error. Okay? This one is specialized for when you give a voice command and it is not recognized. Now, what are we going to do if this happens? I'm going to be printing, sorry, could you repeat? And how can we handle this? Whenever we say this, I would like to call this function again so that the program won't crash, but it will give you another chance to say the command again. So here I'm going to just say speech to text, meaning that whenever we say an unknown command, we will re-execute everything again. So we will go back here and initialize recognizer and just listen to the command one more time. Okay, now let me try this out. Yes, it understood. Now let us say nothing. Okay, before we test, let us just add this letter here. We forgot the N. All right, now if I say nothing, what's going to happen is we are going to jump into this exception and print this. Because once we say nothing, Google Recognizer will not understand what we said. This is how it's designed. So let's try it. Here we go. As you can see, the program did not crash. And it said, sorry, could you repeat? All right, so this is how we create a safe program. I would like to show you how we can branch different decisions based on what we say. So let's create here a variable that is called command. Here's what we're going to say. I'm going to say if command is equal to, let's say, go, small letter, print, voice said go, do something, okay? Instead of this print, we can do whatever we want. We can open files, we can automate some GUI, we can open a web page, we can do whatever we want with our voice. So this print is nothing but a placeholder. If command is equal to open, print, voice said open, I will open something, okay? Now this is very basic, so let's just try it out. If we run this, go. And we have printed voice said go, do something. Okay, now let's continue. Open. Voice said open, I will open something. And that's really good. And we can put this in a while one loop and repeat it forever. So I'm going to say here while one, and we will execute this as long as we want. So let's execute it. Go. Open. go. And as you can see, this is how it works. This is how we create an infinite loop of commands. Now, can we add a command that will quit this while loop? Or as we say, break it? We would say if command, let's say, is equal to stop, right? If I say stop, then I would like to break. So I'm going to say here print by, and then we will say break to exit this loop. Stop. And it did exit the loop. That's really cool. This is how we create the basics of speech recognition. Now we will be jumping into some automation, then we will be linking both topics together. Alright, now we are going to start with the library that is called PyAutoGUI. PyAutoGUI is great to automate whatever it sees on the screen. It can move the mouse around, it can type text using your keyboard, it can search for images around the screen and locate where are they so that you can have the mouse move over there. It can do anything that you as a human can do when working with computer. So here's what I'm going to do. First, I'm going to be importing PyAutoGUI. Alright, what's next? How about we learn how we can move the mouse around? Well, this is very simple. I'm going to say here, import PyAutoGUI as py. Now, I'm going to be moving this mouse around, so I'm going to say py.move to, and then I can just specify a certain coordinate around the screen. So if I say 1000 by 1000, take a look at the mouse. I did not move the mouse was moved with that move to function. That's really great. How about letting the keyboard type something? Well, this is also very easy. All I need to do is just say py.write I am a robot. Okay. Now let's try if this will work or not. I'm going to execute the cell and it did not actually work. Why is that? Because we need to click on this rectangle to be able to write in this text box. Okay, let's find a location where we can type to any of those boxes. So let's try maybe 500 by 1000. Let's just try it out. No, let's try by maybe 200. A little bit lower. 300. Lower. 400. A little bit lower, maybe 430. Yes, we can actually click here. So right now, if I move the mouse here and I click like that and then type something, it should work because it follows the same steps you will be doing in order to type in this cell. To type in this cell, you need to move your mouse. Let's say this cell is not clicked. You need to move this mouse, activate the cell by clicking on it, and then type something. So this is moving the mouse. Now we need to click. So I'm going to say py.click. Okay, now take a look what happens if I just execute these. I already clicked on that cell. I did not do that by myself. The script did it. Now if I just say py.write I am a robot, here we go. See how cool it is to automate with PyAutoGUI? Any actions that you would do with your keyboard, mouse, this library can just mimic it and do the same thing. Now next we are going to learn how we can locate what we see around the screen using this library. So right now we know how to move the mouse, click, and write. There is another function that is called PyDoubleClick, and it can double click on something. Let's use that and the function that can see the screen and search for a certain image on it to open a file. Let me show you what I mean. Right now, in this folder, I have a SpongeBob picture and a Patrick picture. How about we let our Python script find this SpongeBob picture and double click on it and open the file. To do that, first we need a reference for this picture. Okay, how we do it? You have two choices. If you are on Windows, you can open the snipping tool and try to snip only this image right here, like that. Something like this should be enough. Save this image in some directory. Let's say here, sponge reference. Now I'm gonna close this. If not, you can simply print out the screen if you're on Mac OS or Linux, and then let's say something like that, open Paint or whatever photo editor you have, do this, and then you can just crop this image and save it somewhere. You have multiple options here. All right, so what are we going to do with this picture? Well, we are going to let this script search to find a picture that looks like this on the screen and double click on it. How can we do that? There is a function that is called locate on screen. So if I say here py.locate on screen and give the path to that image, put R here so that the path is handled automatically, and then give the name of the image like this. Okay. Now what's going to happen is the script is going to open this image and search on the screen if this image exists somewhere. So right now I'm going to keep my script open here and I'm going to keep the window open here. The window should be visible so that the script can find it. Let's try it out. Actually, we don't need these anymore, so I'm just going to comment them out. All right, let's try this out. We have a typo here, locate. And as you can see, it gave us some coordinates regarding where is this picture. Okay, now let's convert those coordinates into something that the mouse can work with. So I'm going to say here center is equal to py.center and pass coordinates. Where are the coordinates? I'm going to be storing those coordinates here in this variable. Okay. And then this function is going to extract this left, top, width, and height to find the center of that image it found. The center means it will find the x and the y of the center of this image right here. Okay, so the mouse should be exactly here. Now what do we do with the center? We will use it to move the mouse. Now if I just print center like this, you'll see that I got x is equal to this, y is equal to this. So I can simply just pass it to move to. I'm going to say py.move to. I'm going to pass center 0 for the x coordinate and center 1 for the y coordinate, right? Because this is a tuple actually containing two elements, and I am accessing the first element, which is this, and the second element, which is this one. Now let's take a look what's going to happen. And the mouse just went to the middle of SpongeBob over there. That's really great. All right. Now, how about we open that image? We are going to say py.double click like this. So after the mouse is already in the middle of our icon over there, we will be double clicking. So let's try this. And the image opened by itself. That is really cool. Let's do another demonstration. How about we move the mouse to this Python icon over there? We can do the same thing. Go to Start and type Snipping Tool. Take a snipping of this. Save it. Let's call it Python. Close this. And let's change this name to Python. Now if I execute this, the mouse is already on Python. That is really great. Imagine the possibilities with these couple of actions. As I said, you can automate anything right now with those couple of functions. How about we make some really cool project where we will be automating WhatsApp? So WhatsApp is a messaging app that is very, very popular, and we can actually automate it using our Python. We can make it send messages to our friends, send stickers. We can make it do whatever we want. So let's learn how we can do this cool project. First, you need to have WhatsApp on your desktop. And to do that, you need to install it from the Microsoft Store if you are on Windows. And after you do that, you need to scan the QR code from your phone. And after you do that and open the app, you're going to get a QR code. And all you need to do is open the WhatsApp app on your phone and scan that QR code. The instructions of this changes from time to time, so I really prefer that you look it up and see how you can have WhatsApp installed on your Windows machine. But basically, this is how we do it. If you don't have WhatsApp and you have other apps, you can follow the same procedure to do the same automation. So it really doesn't matter what is the app you are using because the steps are exactly the same. Okay, so first, let's see how we can send a message. I'm going to assume that WhatsApp is only at the lower bar right here, which is this one. And we are going to automate how we can open it. Alright, so this will be the first step, to just open up the app. Let's get into our script and start typing some things. I copy and pasted the same functions we have used in the previous lectures so that we don't have to rewrite them because this is almost everything that we need. What do you think the first step should be? Well, now the first step to do this is to move the mouse down here and let this taskbar show up. Now in some Windows machine, this taskbar is already showing up all the time, so you don't need to do this step, which is moving the mouse down here. Because for me, if I remove the mouse, the taskbar will be hidden. So my first step is to move the mouse here and then locate this image. So let's do the first one. I'm going to be moving the mouse first. All right. I will take all of those and just put them in a different cell. Okay. Now, let me make this window smaller like this. And let me execute the cell. Well, it did go to the right. So this one is for the X and this one is for the Y. So maybe I will move the Y to 1000. It's not enough. Maybe to 1100. And here we go. As we can see now, once we take the mouse to this position, we will see the taskbar opening. Now you need to experiment with these coordinates, maybe if the resolution of your screen is different. So let me try it again. If I just execute this, the mouse will be down here. What should be my next step? Well, my next step is to take an image, to take a picture of this WhatsApp icon. So I'm going to open Snipping Tool, like this. I'm going to put it here so that I can capture the image without this being hidden. So new, and I am capturing this. I'm going to try to avoid taking the number with it because we will get an almost exact match usually for the image. So try not to take the number of messages because this number can change and this will make you some issues actually. So just take this portion of this and save it. I'm going to call this WhatsApp. Okay, so maybe now I can take this function and just call here WhatsApp. So this function now is going to search for that WhatsApp icon and then we need to click on it. So to click on it, we need to convert those into the center and then just clicking. So I'm going to copy all of those. Let me expand this a little bit. Okay, this is much better. Okay. I would need only to click on it. All right, so let's try it out. We need to take the mouse down there and then calculate the center and then move the mouse to that center and click. And we got an error here and it said non-type is not subscriptable. And that's correct because here, when we tried to locate this WhatsApp, we did not wait. So it was too fast. See, the taskbar takes time to open. So we need to give the program some time before we can locate it. So we move the mouse, we wait a little bit, then we try to locate that icon. To do that, I'm going to be importing here a library that's called time. And after we move the mouse, I'm going to say time.sleep for maybe 1 second. This is like a wait statement. Before executing this statement, we will be waiting for 1 second, then we will be executing this. So let's try it. And here we go. As you can see, WhatsApp was opened. Next, we will be automating sending messages. Now, how can we actually send messages? Imagine that you want to do this yourself. The first step is to open the app, choose the person, and then click on the text box and type. This is exactly what we want to do. Now we need a picture of who you are trying to send your message to. We need to take a snipping of that image. So I'm going to say here, I'm going to create a new snipping, save it, and I'm going to call this profile. And now we are going to do the next step. First, we moved the mouse to the lower taskbar, then we clicked on WhatsApp, then we got the coordinates for WhatsApp, we moved the mouse there, we clicked on it. Okay, so I'm going to copy all of those and just put them here. I don't need the move, I don't need the sleep. I'm going to need a sleep after we click so that we can wait a little bit before we continue. So let's wait for only half a second. Now, we are going to locate that profile picture and then click on it. As simple as that. Now, if I run this, let me close WhatsApp. Let's run it. Open WhatsApp and we clicked on that person. That's really great. What's next? We want to write some message. So after we click on the person, we need now to click on this type a message box. So let's take snipping tool again. And let's copy this. Save it. I'm going to save it as text box. And let's do the same thing. Copy all of this. Okay, so this is my text box. And we're going to click as well. And as usual, we need to sleep a little bit here after every step. Now let's take a look if this will work. Close WhatsApp and try it. And here we go. The mouse now is on a type a message. Now, how can we type a message if the text field is active? Well, we will use this function, which is called by_write. Now I'm going to delete this whole cell. We don't need it anymore. And here now we can say by_write, I am a robot. Let's see if it will type anything. Again, close WhatsApp and run the script. And here we go. We can see that we typed I am a robot. That's really cool. What's left is to just send this message. So again, snipping tool, copy this send message icon, save it. Let's call this send. And again, copy all of this, put it here, and just change the name here from text box to send. Close WhatsApp and recompile the whole script one more time. Open WhatsApp, choose a person, write the message, but we did not send anything. Why is that? Because we did not say sleep after we write the message. You always need to put some sleeps in between those actions. Let's try it again. Here we go. And again, we got an error. Let's see what is this error. All right, so it seems that we have an issue in the text box. So let's take another picture of it. By the way, things happen, so you need to retry these steps sometimes, multiple times, to see what works as an image. So let me try again. So I'm going to be taking something like this, maybe. Save it. I'm going to replace this text box. So I'm going to close this now and let us try again. And here we go. Now we are sending the message. So the whole problem was that we should have just taken another picture of this text box and this solved the issue. Now let me try it one more time to make sure that everything is fine. And everything is okay. Next, we are going to learn how we can automate and send stickers on WhatsApp. Now, how about we automate sending stickers? To send stickers in WhatsApp, you need to click on this emoji icon. Go to Stickers, go to Favorite, and I have this cool sticker of Leonardo DiCaprio that I would like to send. Well, so we have multiple steps. First, we need the image of this emoji, we need the image of the stickers, we need the image of this star, and we need the image of the sticker we want to send. So let's take those images. This is my snipping tool, and here we go. This is the first one. Let's call this emoji. Let's take the second one now, which is the stickers over here. This text of stickers. Save it. I'm gonna call it stickers text. Next, we need to click on this star. Save it. I'm gonna call this star. And next we need the sticker itself. So let's do that. Save sticker. All right, now let's automate this process. We are going to continue from where we have left off. Let's create a new step. We're going to copy everything. Just change the names here. First we have emoji. Next we have sticker text. Stickers text, right? And after that, we have the star. And finally, we have our sticker. Now let's see if we have any mistake. I'm going to be testing this out. Close WhatsApp. Alright, so let us start right now. Let me adjust this and then run the script. Here we go. Open WhatsApp. Write a message. Send it. Click on sticker. And we have an issue. Let's take a look at it. It is actually having difficulty with this sticker. So let's retake it. As usual, if we have issues, we can just retake the image, save this, replace the stickers over there. Okay. Close everything and rerun. And here we go. We have automated now sending a sticker as well. That is really cool. So whenever you get stuck, all you need to do is just retake the image and try again. And welcome back. Now what I am going to do next is actually to utilize voice commands. So how about we activate our voice command, and whenever we say something like a message or say sticker, it will execute that corresponding function. I'm going to be having three functions. One of them is called open, which will open WhatsApp. The second one will be send, which will send me a message, predefined message. And third, sticker, which will send me a sticker on WhatsApp. So let us do this. I'm going to be utilizing the script that we have written before regarding voice command, which is this one, speech to text function. Now, what we are going to do is I'm going to be reading this speech to text here. So this is speech to text, and we will return a command here. Okay, let's call the function. And depending on this command, we are going to execute one of those functions. So let's say if command is equal to open, then I would like to open WhatsApp. How would we do that? Where is the open WhatsApp? Well, it is actually this section here, okay? We will be going to the lower taskbar. We need to locate the WhatsApp icon. We need to move to it using the mouse, and then we need to click and WhatsApp will open. All right, what's next? How about we create a command that will send me a message. So if command is equal to send, what would I like to do? Well, I would like to click on that certain profile, select the text box, and click on send, right? So we need to put those in here. Next, let's say that I would like to send a sticker. So if command is equal to sticker, then I would like to do the following. I'm going to be opening the emojis, the sticker text, opening the star icon, and then sending that sticker. Okay. Now there isn't much of customization here, but you can add as much customization in terms of what kind of sticker you would like to send, in terms of what kind of message you would like to send. We can do all of that. But here I'm just doing the basic structure, and you can later modify it as a practice, which will be really fun. Alright, we are almost done. How about we put all of this inside a while loop? So here I'm going to be saying while 1, and we are going to put all of this inside a while 1 loop so that we will continue receiving commands and executing them. Open, send, sticker, and here we go. Everything is working as expected. That's really cool. Alright, now we need a mechanism in order to prevent returning coordinates of none. Now let's say that we did not find profile or text box or send, the program will crash, and this is not really good. So how can we prevent that? We need a condition making sure that we don't have a none coordinate, because if the program tries to find this image and it did not find it, the coordinate here will be none, and this is applicable for every coordinate. If it is none and we try to calculate the center, well, we are going to crash. So let's try it. If I say send, as you can see, we crashed because we said send and it was trying to search for profile pictures, which does not exist. So let's do it quickly. I'm going to say if coordinate is not none, okay, we will be doing all of this. Now this statement will be applied everywhere. So this is here, like this as well. So this is a safe method every time we try to read a coordinate. And we have 2 more. This is one of them. And we have 1 more here. I hope we did not miss anything. Yes, we still have this one. All right. So let us test this out. Send, open, open. Let's make this smaller, open. And we have open. Alright, so right now everything is working as expected.